Consequently, it is not conceptually grasped as the negation of negation, as infinite unity. Only in the qualitative opposition does the posited infinitude, the being for itself, come to the fore, and the quantitative determinateness itself, as we shall presently find out, pass over into the qualitative. 64. Remark 2. It was earlier remarked that the Kantian antinomies display the opposition of the finite and infinite in a more concrete shape, applied to a more specific substrate of representation. 65. The antinomy that we were then considering contained the opposition of qualitative finitude and infinitude. In another, the first of the four cosmological antinomies, it is rather the quantitative limit and the conflict associated with it which is the issue. Here is the place, therefore, to undertake the examination of this antinomy. 66. It concerns the limitation or non-limitation of the world and time. 21.229 and space. The antithesis could just as well be considered with respect to time and space themselves, for whether time and space are relations of things themselves or only forms of intuition instead makes no difference to the antinomy of limitation or non-limitation in them. A closer analysis of this antinomy will likewise show that both theses as well as their proofs, which, like those previously considered, are conducted apagogically, amount to nothing more than these two simple, opposed claims. There is a limit, and the limit must be transcended. The thesis is, the world has a beginning in time, and in space it is also enclosed within limits. One part of the proof, concerning time, assumes the opposite. For if one assumes that the world has no beginning in time, then up to every given point in time an eternity has elapsed, and hence an infinite series of states of things in the world, each following another, has passed by. But now the infinity of a series consists precisely in that it can never be completed through a successive synthesis. Therefore, an infinitely elapsed world series is impossible, so a beginning of the world is a necessary condition of its existence, which was to be proved. 67. The other part of the proof which concerns space also relies on time. To traverse the parts of a spatially infinite world and hold them together would require an infinite time, and this time would have to be considered as elapsed if the world is to be viewed in space not as in becoming, but as completely given. But it was shown of time in the first part of the proof that it is impossible to assume an infinite time as elapsed. But one sees at once that it was unnecessary to make the proof apagogical, or even to conduct it at all, for the proof is itself directly based on the claim which was to be proved. Namely, assumed is some or any given point in time to which an eternity has elapsed. Eternity has only the meager meaning here of a bad temporal infinity. Now, a given point in time has no other meaning than that of a determinate limit in time. In the proof, therefore, a limit is presupposed to time which is actual, but that is just what was to be proved. For the thesis is that the world has a beginning in time. 21, 230. There is only this difference, that the assumed limit is a now which comes at the end of a time just elapsed, whereas the now to be proved is at the beginning of a future time. But this difference is unessential. The now is assumed as the point at which an infinite series of successive states of things is supposed to have flowed away in time, therefore to be an end, a qualitative limit. If this now were considered as only a quantitative limit that flows on and is there, not simply to be surpassed, but as itself self-surpassing, then the infinite time series would not have flowed away in it, but would go on flowing, and so the nerve of the proof would fall. On the other hand, if the temporal point is assumed to be the qualitative limit of the past, in which case it is equally the beginning of a future, for each temporal point is in itself the connection of the past and the future, then the point is also the absolute, that is, abstract, beginning of that future, and this is what was to be proved. It is irrelevant that there is already a past preceding its future at this point, for the temporal point is a qualitative limit, and that it is to be taken as qualitative rests on its determination of being completed, elapsed, and therefore of not continuing. And so time is interrupted in it, The past is then without connection to a future that could be called such only in respect to it, and therefore, without this connection to a future, itself only time in general, which has an absolute beginning. But if the future were to stand in connection with the past, as indeed it does, through the now, the given point of time, and in this way were determined as future, then this point of time also, from the other side, would not be a limit. The infinite time series would continue in what was called the future and would not be, as assumed, completed. The truth is that time is pure quantity. The point which the proof uses, and in which time is supposed to be interrupted, is rather the self-sublating being for itself of the now. All that the proof does is to picture the time limit which in the thesis is claimed to be absolute as a given point of time, and straightaway to assume it as completed, that is, as an abstract point. A 21.231 popular determination, which since representation easily lets pass for a limit, thus allowing as assumption in the proof what earlier had been put forward as the thing to be proved. The antithesis runs, the world has no beginning and no limits in space, but is infinite with regard to both time and space. Here too the proof assumes the opposite. For suppose that it has a beginning. Since the beginning is an existence preceded by a time in which the thing is not, there must be an antecedent time in which the world was not, that is, an empty time. But now no arising of any sort of thing is possible in an empty time, because no part of such a time has, in itself, prior to another part, any distinguishing condition of its existence rather than its non-existence. Thus many series of things may begin in the world, but the world itself cannot have a beginning, and so is infinite with respect to past time. 68. Like the others, this apagogical proof contains the direct and unproved assertion of what is supposed to be proved. For it first assumes a beyond of the existent world, an empty time, but it then goes on to continue the existence of this world beyond itself into the empty time, sublates this time thereby, and consequently extends the existence to infinity. The world is an existence. The proof presupposes that this existence arises, and that its arising has an antecedent condition in time. But the antithesis itself is just this, that there is no unconditional existence, no absolute limit, but that the existence of the world always demands an antecedent condition. What was to be proved thus finds itself in the proof as assumption. Further, the condition is then sought in the empty time, and this is as much as saying that it is assumed as temporal and consequently as existence, and as something restricted. The general assumption, therefore, is that the world presupposes as existence another conditioned existence in time, and so on, therefore, to infinity. The proof regarding the infinity of the world in space is the same. The spatial finitude of the world is apagogically posited, for it would then exist in an empty, unlimited space and would stand in relation to it. But such a relation of the world to no object is a nothing. 69. What was supposed to be proved is here, too, directly presupposed in the proof. It 21.232 is directly assumed that the spatially delimited world is to be found in an empty space, and that it stands in relation to this space. That is, that there must have been a move transcending it. On the one hand, a move into emptiness, into the beyond and the non-being of the world. But, on the other hand, in order that the world remains in relation to that empty space, that is, so that it continues in it, that beyond is to be represented as filled with world-like existence. The infinity of the world in space which is asserted in the antithesis is nothing else than, on the one hand, the empty space, and, on the other, the relation of the world to it, that is to say, its continuity into space or the filling of space. And this contradiction, that time is simultaneously empty yet filled, is the infinite progression of determinate existence. The contradiction itself, the relation of the world to empty space, is made the foundation on which the proof rests. The thesis and antithesis in their proofs produce nothing more, therefore, than the opposed claims, that a limit is, and that the limit is just as much a sublated one, that the limit has a beyond with which it is however connected and into which it must pass, but in which there arises, however, another such limit, which is no limit. The solution of these antinomies, as of those previously mentioned, is transcendental, that is, it consists in the assertion of the ideality of space and time as forms of intuition, by which is meant that the world does not contradict itself within, is not something that sublates itself, but that consciousness alone, in its intuition and in the connection of intuition to understanding and reason, is rather the being which is self-contradictory. It is an excessive tenderness for the world to keep contradiction away from it, to transfer it to spirit instead, to reason, and to leave it there unresolved. In fact, spirit is the one which is strong enough that it can endure contradiction, but it is spirit again which knows how to resolve it. But nowhere does the so-called world, call it the objective, real world, or, in the manner of transcendental idealism, subjective intuition and sense content determined by the category of the understanding, nowhere, however you call it, does it escape contradiction, but it is not capable of enduring it, and for that reason it is left to the mercy of the coming and ceasing to be. 21,233. The infinity of quantum. The infinite quantum as infinitely great or infinitely small is itself, in itself, the infinite progress. As great or small it is a quantum and at the same time the non-being of quantum. The infinitely great and the infinitely small are, therefore, figurative representations which on closer inspection prove to be but unsubstantial nebulous shadows. In the infinite progress, however, this contradiction is explicitly present, and with it that which constitutes the nature of quantum which, as intensive magnitude, has attained its reality and is now posited in its existence as it is in its concept. We must now consider this identity. Quantum is as degree simple, self-referred, and determined within it. Because the otherness and the determinateness are sublated in it through this simplicity, the determinateness is external to it. It has its determinateness outside it. This, its being outside itself, is at first the abstract non-being of quantum in general, the bad infinity. But further, this non-being is also a magnitude. Quantum continues in its non-being, for it is precisely in its externality that it has its determinateness, and this, its externality, is itself therefore equally a quantum. The non-being of quantum, the infinity, is thus limited, that is, this beyond is sublated, is itself determined as a quantum which, consequently, in its negation is with itself. But this is what quantum as such is in itself. For through its externality it is precisely itself. The externality constitutes that in virtue of which 21.234 quantum is quantum, where it is with itself. In the infinite progress, therefore, the concept of quantum is posited. If we now first look at this progress in its abstract determinations as they are displayed before us, what we find in it is the sublating of quantum, but no less also of its beyond. What we find, therefore, is the negation of quantum as well as the negation of this negation. Its truth is the unity of these two negations in which the negations are, but as moments. This unity is the resolution of the contradiction of which the infinite progress is the expression. Its most immediate meaning, therefore, is that of the restoration of the concept of magnitude, of being an indifferent or external limit. On the subject of the infinite progress as such, the only reflection which is usually made is that each quantum, however great or small, can disappear, that it must be possible to transcend it, not, however, that this sublating of the quantum, the beyond, the bad infinite itself, also disappears. Even the first sublating, the negation of quality as such whereby the quantum is posited, is in itself the sublation of negation. Quantum is sublated qualitative limit, consequently sublated negation, but it is at the same time only in itself. The sublating is posited as an existence, and its negation is then fixed as the infinite, as the side beyond quantum. while the latter remains on its side as an immediate. Thus the infinite is determined only as first negation, and it is in this way that it appears in the infinite progress. But there is more to it, as has just been shown. There is the negation of negation, or what the infinite is in truth. And this we have just seen with the restoration of the concept of quantum. Such a restoration means, in the first place, that to the existence of the quantum there has accrued a more precise determination. What we now have is quantum 21.235 determined according to its concept, and this quantum is different from the immediate quantum. Externality is now the opposite of itself, is posited as a moment of magnitude. Quantum, for its part, is posited as having its determinateness in another quantum, through the intermediary of its non-being, of infinity, that it is qualitatively what it is. Yet this comparison of the concept of quantum with its existence belongs more to our reflection, to a relation which is not yet present here. The next determination, rather, which is present here is that quantum has returned to quality, is from now on qualitatively determined. For its defining property, its quality, is externality, the indifference of the determinateness, and quantum is now posited rather as being itself in its externality, of referring to itself therein, of being in simple unity with itself, that is, of being qualitatively determined. This qualitative being is still more closely determined, namely as being for itself. For the very self-reference which quantum has attained has proceeded from mediation, from the negation of the negation. Quantum no longer has infinity, the being determined for itself, outside it, but in it. The infinite, which in the infinite progress only has the empty meaning of a non-being, of an unattained but sought beyond, is in fact nothing other than quality. Quantum, as indifferent limit, surpasses itself into the infinite. It thereby seeks nothing else than its being determined for itself, the qualitative moment which, however, is only an ought. Its indifference towards the limit, and hence its lack of a determinateness which is inexistent for itself, its surpassing itself, is that which makes the quantum what it is. This, its surpassing, is to be negated, and quantum is to find in infinity its absolute determinateness. Quite generally, quantum is sublated quality, but quantum is infinite, it surpasses itself, is the negation of itself. This, its surpassing, is therefore in itself the negation of the negated quality, the restoration of it. 21.236, and what is posited is that the externality, which seemed to be a beyond, is determined as quantum's own moment. Quantum is thus posited as repelled from itself, and with that there are two quanta which are however sublated, only moments of one unity, and this unity is the determinateness of quantum. Quantum, self-referred as indifferent limit and hence qualitatively posited, is the quantitative relation or ratio. In ratio, quantum is external to itself, different from itself. This, its externality, is the reference connecting a quantum to another quantum, each quantum acquiring value only in this connection with its other, and this reference constitutes the determinateness of the quantum, which is this unity. In this unity, quantum possesses not an indifferent, but a qualitative determination. In this, its externality has turned back into itself. It is in it what it is. Remark 1. The conceptual determination of the mathematical infinite. The mathematical infinite is of interest because of the expansion and the significant new results which its introduction into mathematics has produced in it, but also because of the oddity that this science has to date still been unable to justify its use conceptually, concept being taken here in a strict sense. Ultimately, the justifications are made to rest on the correctness of the results obtained with the help of this infinite as demonstrated on other grounds, not on the clarity of the subject matter and of the operation by which the results are obtained. Indeed, the operation itself is even admitted as incorrect. 70. This alone is in and for itself a deplorable situation. This way of doing things is unscientific. But there is a further disadvantage that goes with it. As long as 21.237 mathematics does not know the nature of its instrument by failing to master the metaphysics and critique of the infinite, it cannot determine the scope of its application and cannot secure itself against the misuse of it. But from a philosophical point of view, the mathematical infinite is important because underlying it, in fact, is the concept of the true infinite, and this infinite stands much higher than the usual so-called metaphysical infinite from which the objections against the other infinite, the mathematical, are made. The normal recourse that the science of mathematics has against these objections is to deny the competence of metaphysics by claiming that it has nothing to do with this science, and that it need not trouble itself with its concepts as long as it operates consistently with its own principles. The task of mathematics is to consider what is true within its own domain, not what is true in itself. Metaphysics, while objecting to the mathematical infinite, is aware that it can neither deny nor upset the brilliant results of its use, and mathematics, for its part, is aware that it is not clear about the metaphysics of its own concept, and also, therefore, about the derivation of the procedures necessitated by the use of the infinite. If the only difficulty affecting mathematics came from the concept in general, then mathematics could brush it aside without more ado, since the concept is more than just the statement of the essential determinacies of a fact, that is, of its determinations according to the understanding, and, so far as precision in such definitions goes, mathematics leaves nothing to be desired. It is not a science that concerns itself with the concepts of its subject matter and which would have to generate their content by developing the concept, even if only by means of ratiocination. But mathematics finds in the method of its infinite a major contradiction to the very method which is specific to it and on which it rests as a science. For the infinitesimal calculus permits, even requires, procedures which mathematics must absolutely reject when operating with finite magnitudes, and at the same it treats its infinite magnitudes as if they were finite quanta and insists on applying to them the same procedures which are valid for these. A significant aspect of the formation of this science has been its success in applying to transcendent determinations and their treatment the form of ordinary calculus. 21,238. Mathematics shows that, despite the conflict inherent in its operations, the results that it obtains through them wholly agree with those found by the strictly mathematical method, namely the geometrical and analytical. But, for one thing, this does not apply to all results. The purpose of introducing the infinite is not solely to shorten the ordinary procedure, but to achieve results unattainable through it. And for another, success does not by itself justify the mode of procedure. In an infinitesimal calculus, the method is seen to be afflicted by a seeming inexactitude. After the finite magnitudes have been increased by an infinitely small quantity, in the subsequent operation this quantity is partly retained and partly ignored. What is remarkable about this procedure is that, despite the admitted inexactitude, the derived result is one which is not just fairly close, or close enough that the difference can be disregarded, but is, on the contrary, perfectly exact. In the operation itself which precedes the result, however, one cannot dispense with the fiction of a something which is not quite null, yet is so inconsiderable that it can be left out of account. But mathematical determinateness, as we understand it, excludes the possibility of a greater or lesser degree of exactitude. Just as in philosophy there can be no question of a greater or lesser probability, but of truth alone. Even if the method and use of the infinite is justified by the success, it is nevertheless not so superfluous to ask for its justification, so superfluous as it patently would be to ask, with respect to one's nose, for a proof of the right to use it. For to deal in proof is essential to mathematical cognition, since it is scientific cognition, and even with respect to results, the fact is that rigorous mathematical method does not certify them all with success, which is an external piece of evidence anyway. It is worth the effort to take a closer look at the concept of the infinite together with the most notable attempts at justifying its use and removing the difficulty with which the method feels encumbered. The consideration of these attempts at justifying and determining the mathematical infinite, which I 21.239 shall undertake at some length in this remark, will at the same time throw the best light on the nature of the true concept itself. It will also show how there was an intimation of this concept in such attempts, and that it actually lay at their basis. The usual definition of the mathematical infinite is that it is a magnitude of which there is no greater, when it is defined as the infinitely great, or smaller, when it is defined as the infinitely small, or, in the former case, which is greater than, in the latter case smaller than, any given magnitude. In this definition, the true concept is of course not expressed. What is expressed is rather, as already remarked, the same contradiction which is present in the infinite progression. But let us see what there is implicitly contained in it. In mathematics, a magnitude is defined as something which can be increased or diminished. In general, therefore, as an indifferent limit. Now, since the infinitely great or small is such that it can no longer be increased or diminished, it is no longer in fact a quantum as such. This consequence follows necessarily and directly. But it is this reflection, that quantum is sublated. And in this remark I call quantum what quantum is as such, finite quantum, which is not commonly made, and is the source of difficulty for ordinary thinking. For in so far as quantum is infinite and therefore sublated, it requires being thought as something which is not a quantum and yet retains its quantitative determinateness. Kant did not find the said definition to accord with what one normally means by an infinite whole. To cite his judgment, J. According to common understanding, a magnitude is infinite if none greater than it, that is, greater than the multiple of a given unit contained in it, is possible. Now no multiple is the greatest, because one or more units can always be added to it. The infinite whole does not represent how great it is. Hence this concept is 21.240, not the concept of a maximum or minimum. Rather, it thinks only of the relation to an arbitrarily assumed unit, in respect of which it is greater than any number. Depending on whether the unit is assumed to be greater or smaller, the infinity would be greater or smaller. Yet infinity, since it consists merely in the relation to the given unit, would always remain the same, even though in this way the absolute magnitude of the whole would obviously not be cognized at all. 71. Kant objects to infinite wholes being regarded as a maximum, the completed aggregation of a given unit. The maximum or minimum as such still appears as a quantum, an aggregate. This way of representing the infinite cannot avert Kant's conclusion that it leads to a greater or smaller infinite. And in general, so long as the infinite is represented as a quantum, the distinction between greater and smaller still applies to it. This criticism, however, does not touch the concept of the true mathematical infinite, of infinite non-indifference, for this is no longer a finite quantum. Kant's concept of the infinite, on the other hand, which he calls the truly transcendental one, is that the successive synthesis of unity in the traversal of a quantum can never be completed. 72. So a quantum in general is presupposed as given. This is supposed to be converted by the synthesizing of the unit into an amount, a definite assignable quantum. But this process of synthesis can never be completed. Clearly, what is expressed here is but a progress to infinity, except that the progress is represented transcendentally, that is, in fact subjectively and psychologically. True, in itself the quantum is supposed to be completed, but transcendentally, that is to say, the only determination which should arise in the subject that gives it a relation to a unit is that of an incomplete quantum intrinsically affected by a beyond. We still are, therefore, at the contradiction contained in magnitude, except that it is now distributed between the object and the subject. Limitedness is assigned to the object, and to the subject the capacity to transcend over and over again, in a bad infinite, any determinateness it grasps. 21,241. We said above that, on the contrary, the definition of the mathematical infinite, precisely as it is used in higher analysis, corresponds to the concept of the true infinite. 73 here is the place for a detailed comparison of the two. First to be said regarding the truly infinite quantum is that it determines itself as infinite within. It is such because, as demonstrated, 70 for the finite quantum or the quantum as such and its beyond, the bad infinite, are equally sublated. The sublated quantum has thus gone back into the simplicity of self-reference, but not as the extensive quantum did when it went over into the intensive quantum, by having its determinateness only in itself, in an external multiplicity with respect to which it is nevertheless supposed to remain both indifferent and diverse. On the contrary, the infinite quantum contains first the externality and then the negation of it in it. It no longer is, therefore, just some finite quantum or other, no longer a magnitude determinateness which happens to have a determinate existence as quantum. It is rather simple, and therefore only a moment. It is a magnitude determinateness in qualitative form. Its infinity consists in its being a qualitative determinateness. As moment, it is thus in essential unity with its other. It is determined only through this, its other. That is, it has meaning only with reference to something which stands related to it. Outside this relation, it is a nullity. Just because quantum as such would have to be indifferent to the relation, and yet in the relation an immediate, unmoved determination. In the relation, as only a moment, quantum is not something indifferent, is not for itself, since it is at the same time a quantitative determinateness. In the infinity, which is being for itself, it is only as a being for one. The concept of the infinite as abstractly expounded here will prove to be the basis of the mathematical infinite, and the concept itself will 21.242 be further clarified as we consider the different stages in the expression of quantum as moment of a ratio, from the lowest, where it is still also quantum as such, to the highest, where it attains the meaning and the expression of a properly infinite magnitude. Let us then first take quantum in the relation in which it is a fractional number. A fraction such as, for instance, is not a quantum like 1, 2, 3, and so on. To be sure, it is an ordinary finite number, but not an immediate number like the whole numbers. Rather, as a fraction it is determined through the intermediary of two other numbers which stand to one another as amount and unit, the unit being itself a determined amount. However, if we abstract them from this close determination which they have to each other, and consider them in the qualitative connection in which they are here only according to what befalls them as quanta, then 2 and 7 are indifferent quanta, but since they take their place here only as moments, each a moment of the other and therefore of a third, the quantum, which is called the exponent, they at once count not as 2 and 7, but only as determined with respect to each other. We can, therefore, just as well put 4 and 14 in their place, or 6 and 21, and so on to infinity. In this, they begin to take on a qualitative character. Were they to count as mere quanta, 2 and 7 would then simply be 2 and 7 respectively. The 4, 14, 6, 21, and so on would be something simply different from them, and, to the extent that they are only immediate quanta, could not be entered in their place. But in so far as 2 and 7 are not to be taken in the determinateness of such mere quanta, their indifferent limit is then sublated. To this extent, therefore, they have the moment of infinity in them, for not only are they no longer 2 and 7, but their quantitative determinateness remains, although in qualitative existence, namely, as the determinateness which they have in relation. Their place can be taken by infinitely many others without the value of the fraction being altered by the determinateness of the relation. 21,243. However, the representation of the infinite by a fractional number is still imperfect, because the two sides of the fraction, 2 and 7, can be taken out of the relation and are ordinary, immediate quanta. The connection which makes them moments in a ratio affects them externally and immediately. The connection itself is also an ordinary quantum, the exponent of the ratio. The letters with which general arithmetic operates, the next universality to which numbers are elevated, do not have a determinate numerical value defining them. They are only general signs standing in for some possible determinate value. The fraction seems to be, therefore, a more suitable expression of the infinite, since A and B, taken apart outside their connecting reference, remain indeterminate, lacking any particular value of their own, even when separated. However, although these letters are posited as indeterminate magnitudes, their meaning is still to be some finite quantum or other. Therefore, since they are a universal representation, but only of determinate number, their being in a ratio is likewise a matter of indifference to them. Outside the ratio, they retain the value of determinate number. If we look more closely at what is present in a ratio, we see that it contains two determinations. First, that it is a quantum, but, second, that this quantum is not immediate, but contains rather qualitative opposition within it. And since in this opposition it remains at the same time a determinate and indifferent quantum, by returning from its otherness, that is, the opposition, back into itself, it is also an infinite. These two determinations are seen displayed in their distinctness in the following well-known form. The fraction can be expressed as 0.285714. As and so on. As so expressed, it is an infinite series. The fraction itself is called the sum or the finite expression of the series. If we compare the two expressions, then 21.244 the one, the infinite series, no longer represents the fraction as a ratio, but represents it in its aspect as a quantum, which is an aggregate of magnitudes which are added to each other, as an amount. That these magnitudes constituting the amount consist in turn of decimal fractions, that is, themselves consist of ratios, is irrelevant here, for this circumstance concerns the particular kind of unit of these magnitudes, not these magnitudes as constituting the amount. Likewise, in the decimal system, an integer of more than one digit counts as one amount. And the fact is ignored that it consists of products, a number, the number 10, and their powers. Also of no consequence here is the fact that there are fractions other than the adduced as example which, when expressed as decimal fractions, do not yield an infinite series. What is relevant is that every fraction can be expressed as yielding an infinite series in a numerical system based on another unit. Now, since in the infinite series that displays the fraction as amount the ratio aspect of the latter disappears, so does also the aspect by which, as just shown, 75 it had infinity in it. But this infinity has entered in another way, for the series is itself infinite. Now, of what kind this infinity of the series would be is self-evident. It is the bad infinity of progression. The series exhibits the contradiction inherent in it of representing something which is a relation and possesses qualitative nature within it, as without relation, as a mere quantum, as amount. The consequence is that there is something always lacking to the amount expressed in the series, so that the posited amount must always be gone beyond in order for the required determinateness to be attained. The law of the progression is well known. It is implicit in the determination of the quantum contained in the fraction and in the nature of the form in which the fraction is supposed to be expressed. By pressing on with the series, the amount might well be made as precise as need be. Nevertheless, what is displayed through the series always remains an ought. The series is always affected by a beyond which cannot be sublated. For 21.245, the attempt to express as an amount something which is based on a qualitative determinateness is an abiding contradiction. The inexactitude of which there is only a reflective shine in the true mathematical infinite is actually present in this infinite series. These two kinds of mathematical infinite are as little to be confused as the two kinds of philosophical infinite. For the exposition of the true mathematical infinite, the form of the series has been used from the beginning, and of late it has been invoked again. But it is not necessary for it. On the contrary, the infinite of the infinite series is essentially different from it, as the sequel will show. The infinite serial expression ranks even lower than the fractional expression. The fact is that the infinite series contains the bad infinite because what the series is supposed to express remains an odd. and what it does express is encumbered by a beyond which does not go away, and it is diverse from what it is supposed to express. It is infinite not because of the posited terms, but because such terms are incomplete, since the other which belongs to them essentially is beyond them. What the series actually contains, let the terms posited be as many as one wishes, is only something finite, in the strict sense of being posited as finite, that is, as something which is not what it ought to be. On the other hand, what is called the finite expression of such a series, or the sum of it, is without lack. It contains whole the value which the series only seeks. The beyond is recalled from its flight. What it is and what it ought to be are not separated but are the same. More precisely, what distinguishes the two expressions is that in the infinite series the negative lies outside its terms, and these have a valid place in the series only as parts of the amount. By contrast, in the finite expression which is a ratio the negative is immanent. It is the reciprocal being determined of the sides of the ratio, and this being determined is a being turned back into itself, self-referring unity as a negation of the negation. Both sides of the ratio are 21.246 only as moments, and consequently has the determination of infinity within itself. Therefore, what is ordinarily called the sum, like the or the, is in fact a ratio, and this so-called finite expression is the true infinite expression. On the other hand, the infinite series is in truth the sum. Its purpose is to display what is in itself a ratio in the form of a sum, and the existing terms of the series are not the terms of a sum, but of an aggregate. Furthermore, it is in fact the finite expression, for it is incomplete as an aggregate, thus remaining essentially deficient. According to that which is there in it at the moment, it is a determinate quantum, but at the same time not quite what it ought to be, and also, what is lacking from it is itself a determinate quantum, and this missing part is in fact that in the series which is called the infinite, but according to its only formal aspect of being something missing, a non-being, according to its content, it is a finite quantum. Only that which is present in the series, together with that which is missing from it, constitute the fraction, the determinate quantum, which the series ought to be yet is equally incapable of being. The word infinite, even in infinite series, is commonly taken to mean something lofty and exalted. But this is a sort of superstition, the superstition of the understanding, for we have just seen how it boils down instead to a determination of deficiency. We may further remark that the fact that there are infinite series that cannot be summed is an external and accidental circumstance in so far as the form of series as such is concerned. Such series contain a higher kind of infinity than do those that can be summed. Namely, they contain incommensurability, or the impossibility of displaying as a quantum, even if in the form of a fraction, the quantitative ratio that they contain. It is their form as series which as such entails the determination of the bad infinity present in the series which admits of being summed. We find a like reversal of terms, as just noted in connection with the fraction and the series associated with it. Also when the mathematical infinite, not the one just mentioned but the true infinite, is called the relative infinite, whereas the 21.247 ordinary metaphysical infinite, by which the abstract bad infinite is understood, is called absolute. But in fact this metaphysical infinite is the one which is rather merely relative, because the negation which it expresses is in opposition to a limit only by persisting outside the infinite, without being sublated by the latter. The mathematical infinite, on the contrary, has in itself truly sublated the finite limit, for this limit is at one with its beyond. It is primarily in this sense, which shows that the so-called sum or finite expression of an infinite series is the one to be regarded rather as the infinite expression, that Spinoza contrasts the concept of the true infinity with that of the bad, illustrating it with examples. This concept of Spinoza will best be elucidated if I add what he says on the subject to my exposition so far. He starts by defining the infinite as the absolute affirmation of the concrete existence of any one nature, and the finite, on the contrary, as determinateness or negation. 76, that is to say, The absolute affirmation of a concrete existence is to be taken as it's referring to itself. It's not being dependent on another. The finite is negation instead, a cessation in the form of a reference to an other which begins outside it. Now, the affirmation of a concrete existence does not by any means exhaust the concept of infinity. The full concept implies that the infinity is an affirmation, not as immediate, but only as restored through the reflection of the other into itself, or as the negation of the negative. But for Spinoza, substance in its absolute unity has the form of an unmoved unity, that is, a unity which is not self-mediated, a rigidity in which there is no place yet for the concept of the negative unity of the self, of subjectivity. The mathematical example with which he illustrates the true infinite, letters X, 77, is that of a space between two unequal circles, one of which lies inside the other without touching it, and without the two being concentric. He apparently made a lot of this figure and the concept that it illustrates, so much so as to make it the motto of his ethics. He says, mathematicians conclude that the inequalities possible within such a space are infinite, not because of the infinite multitude of parts, for the magnitude of the space is determinate and 21.248 limited, and I am capable of positing larger or smaller such spaces, but because the nature of the matter surpasses every determinateness. 7.8. One can see that Spinoza rejects any representation of the infinite that would make it an incomplete multitude or series, and calls attention to the fact that here, in the space of the example, the infinite is not somewhere beyond, but is present and complete. Such a space is a limited one, but finite, because the nature of the subject matter surpasses every determinateness, because the magnitude determinations contained in it cannot be at the same time displayed as a quantum, or, according to Kant's already cited terminology, 79, the synthesizing cannot be brought to completion in a discrete quantum. How in general the opposition of continuous and discrete quantum leads to the infinite will be explained in detail in a later remark. 80. Spinoza calls the infinite of a series the infinite of the imagination. The infinite as self-reference he calls instead the infinite of thought or infinitum actu. For it is actu, infinite in act, because complete and present within itself. Thus the series 0.285714. Or. That is the infinite merely of the imagination or a merely intended infinite, for it has no actuality. There is simply something missing to it. By contrast, or is actually not only what the series is in its presently given terms, but is, in addition, what the series lacks, what it only ought to be. The or is equally a finite magnitude like Spinoza's space enclosed between the two circles, with its inequalities, and can like this space be made larger or smaller. But there is no absurdity that arises here of a larger or smaller infinite, for this quantum of the whole does not concern the relation of its moments, which is the nature of the fact, that is, does not concern the qualitative determination of magnitude. As for the infinite series, what is actually there is equally a finite quantum, but with yet a deficit besides it. The imagination, on the contrary, stops short at the quantum as such without reflecting on the qualitative connection which constitutes the ground of the occurring incommensurability. The incommensurability which lies in Spinoza's example encompasses in general the functions of curved lines, and is more accurately associated with the infinite which mathematics has introduced in connection with these functions, quite in general with the functions of 21.249 variable magnitudes. This infinite is the true mathematical, quantitative infinite, which Spinoza also had in mind. We must now discuss this determination with greater precision. First of all, with respect to the category of alterability which is held as so important and which covers the magnitudes connected with those functions, such magnitudes should not be assumed from the start to be alterable in the sense in which the numbers 2 and 7 are in the fraction, that is, because 4 and 14, 6 and 21, and other numbers ad infinitum can be put in their place without the value of the fraction being altered. This applies even more to where one can arbitrarily introduce any number in the place of a, and b without altering what is supposed to express. It is now in the sense that an infinite, that is, an inexhaustible multitude of numbers, can also be put in the place of the x and y of a function, that a and b are magnitudes just as variable as these x and y. The expression variable magnitudes is for this reason very vague and ill-chosen for magnitude determinations whose interest and manner of treatment lies in something quite other than in their mere variability. In order to make clear wherein lies the true determination of those moments of a function which are the object of interest of higher analysis, we must retrace our steps once more. In or, the 2 and 7 are independent determinate quanta, and the connection is not essential to them. A and B are likewise intended to represent quanta which remain as they are outside the relation. Furthermore, and are also a fixed quantum, a quotient. The ratio constitutes an amount of which the denominator expresses the unit and the numerator the amount of these units, or conversely, even if 4 and 14, and so on, are substituted for 2 and 7. The ratio also remains the same as quantum. But now, all this changes essentially. For instance, in the function equals p, here x and y carry indeed the meaning of possible determinate quanta. However, not these x and y, but only x and y 221.250 have a determinate quotient. Therefore, not only are these sides of the ratio, x and y, not determinate quanta, but their ratio also is not a fixed quantum, and not in the sense in which it is not fixed in the case of a and b, is not a fixed quotient, but is absolutely variable as quantum. But this is only to say that x is related not to y, but to the square of y. The relation of a magnitude to a power is not a quantum, but an essentially qualitative relation. The power relation is the factor which is to be regarded as the fundamental determination. However, in the function of the straight line, is an ordinary fraction and quotient. This function is therefore a function of variable magnitudes only formally, or x and y are here what a and b are in. They are not in the determination in which differential and integral calculus considers them. Because of the special nature of the variable magnitudes in this mode of consideration, it would have been fitting to have introduced a special name for them, as well as other symbols than the ones generally in use for the unknown quantities in all the finite equations, determinate or indeterminate, for there is an essential difference between them and such merely unknown quantities which are in themselves perfectly determined quanta or a determinate range of determinate quanta. It is, moreover, because of a lack of insight into the peculiar interest which motivates higher analysis and caused the need in the discovery of differential calculus, that functions of the first degree, like the equation of the straight line, have independently been included in the treatment of calculus. Contributing to this formalism is the mistaken belief that the otherwise intrinsically valid demand that a method be generalized can be satisfied by 21.251, leaving out the specific determinateness on which the original need is based, as if in this domain one treated only variable magnitudes in general. We would have been spared indeed much formalism in the consideration and the treatment of these matters if it had been perceived that at issue here are not variable magnitudes as such, but the determinations of powers. But there is still another stage where the mathematical infinite manifests its peculiar character. In an equation in which x and y are first posited as determined by a power relation, x and y as such are still supposed to signify quanta. Now this whole significance is entirely lost in the so-called infinitesimal differences. Dx, dy are no longer quanta, nor should they signify quanta, but have meaning only in connection, the meaning of mere moments. They no longer are a something, the something taken as quantum, nor are they finite differences, but neither are they nothing, not a null void of determination. Outside their relation, they are pure nullities. But they are to be taken only as moments of the relation, as determinations of the differential coefficient. In this concept of the infinite, the quantum is truly made complete as a qualitative existence. It is posited as actually infinite. It is not just sublated as this or that quantum, but as quantum generally. But the quantitative determinateness remains. It remains as the element of the quanta, as principle, or, as has also been said, in their first concept. It is this concept which has been the target of every attack made on the fundamental determination of the mathematics of this infinite, that is, of differential and integral calculus. Incorrect representations on the part of mathematicians themselves were instrumental to this failure to recognize the concept, but the disputes were mainly due to the incapacity to justify the subject matter as concept. But mathematics, as remarked above, 81 cannot circumvent the concept here. For, as the mathematics of the infinite, it does not restrict itself to the finite determinateness of its objects, as pure mathematics does, which considers space and time and their determinations only as finite, referring them to each other. 21.252, but treats any determination which it takes from pure mathematics by converting it into an identity with its opposite, as when, for instance, it converts a curved line into a straight one, the circle into a polygon, and so on. The operations which mathematics allows itself as differential and integral calculus are therefore in total contradiction with the nature of merely finite determinations and their connections, and for this reason can find their justification in the concept alone. The mathematics of the infinite insisted that these quantitative determinations are vanishing magnitudes, that is, such that are no longer some quantum or other, but that are not nothing either, but still have a determinateness as against another. Yet nothing is more evident than that there is no such intermediate state, as it has been called, between being and nothing. What there is to this objection and to this so-called intermediate state has already been indicated above in connection with the category of becoming, in Remark 4. 82. At any rate, the unity of being and nothing is not a state. A state would be a determination of being and nothing into which these moments would have fallen as if by accident, as if prey to a sickness externally induced by faulty thinking. Rather, this middle and unity, the vanishing, or equally the becoming, is alone the truth of being and nothing. It is further said that what is infinite is not comparable as a greater or smaller. There cannot therefore be a relation of infinite to infinite according to orders or dignities of the infinite, although we do find such distinctions of infinitesimals in the science dedicated to them. Underlying this already mentioned objection 83 is always the supposition that we should be dealing here with quanta which are compared as quanta, and that when determinations are no longer quanta, they no longer have a relation to each other. But the case is rather that that which exists only in relation is not a quantum. Quantum is a determination which should possess a perfectly indifferent existence outside the relation it is in and be indifferent to its difference from another quantum. The qualitative, on the contrary, is what it is only in its distinction from another. The infinite magnitudes of calculus are, therefore, not only comparable, but exist only as terms of comparison in relation. Let me review the most important definitions of this infinite which have been given in mathematics. It will become evident that the 21.253 thought of the fact underlying them accords with the concept developed here, but that their originators failed to establish them as concept, and in applying them had again to employ expedients that go against their better thought. This thought could not be more correctly determined than as Newton stated it. I remove here those determinations which belong to the figurative representation of movement and velocity, from which especially Newton derived the name of flux science, because in them the thought does not appear in its due abstract form, but appears concrete, mixed with non-essential forms. Newton explains, Prink. Mathem. Phil. Nat. L. 1, Lemma 11, Scholl. 84 that by flux science he understands not indivisibles, a form of which earlier mathematicians, Cavalieri 85 and others, availed themselves, and which contains the concept of a quantum which is determined in itself, but vanishing divisibles. Also, not sums and ratios of determined parts, but the limites, of sums and ratios. It may be objected that vanishing magnitudes do not have a final ratio, because any ratio before the magnitudes vanish cannot be the last, and, once vanished, there is no ratio anymore. But by the ratio of vanishing magnitudes is to be understood not their ratio before or after they vanish, but the ratio with which they vanish, quacum evanescent. Likewise, the first ratio of incipient magnitudes is the one with which they become. The scientific method of the day only required that one define what one means by an expression, but that by an expression one understands this, or that is, properly speaking, a subjective disposition or also a historical demand which in no way indicates that such a concept is necessary in and for itself and has internal truth. Nevertheless, what we have just cited indicates that the concept advanced by Newton corresponds to our exposition of the infinite quantity above, 86, to the way it resulted from the reflection of quantum into itself. Magnitudes are understood in their vanishing, that is, as such magnitudes which are no longer quanta. Also, not ratios of determinate parts, but the limits of the ratio. The quanta taken for themselves, the sides of the ratio, as well as the ratio itself insofar as it would be a quantum, are supposed to have vanished. The limit of the quantitative ratio is where the ratio is and is not. More precisely, where the quantum has vanished and, consequently, the ratio is preserved only as a qualitative ratio of quantity, and its sides, too, only as qualitative moments of quantity. Newton adds that from the fact 21.254 that there are final ratios of vanishing magnitudes, it is not to be concluded that there are final magnitudes, indivisibles. For this would be again a leap from the abstract ratio to such sides of it as would have a value for themselves outside their connection in the ratio, as indivisibles, each something which would be a one, devoid of any relation. To ward off such a misunderstanding, he further reminds us that the final ratios are not the ratios of final magnitudes, but are limits to which the ratios of the limitlessly decreasing magnitudes come closer than any given, that is, finite, difference without however overstepping them, for then they would be nullities. As we said, by final magnitudes one could have understood indivisibles or ones. But the definition of the last ratio excludes both the representation of ones that are indifferent and devoid of relation and of the finite quantum. However, if the required determination had been brought to the concept of a quantitative determination, which is purely a moment of the ratio, there would have been no need either for the limitless decreasing into which Newton converts the quantum and which only expresses the progress to infinity, or of the determination of divisibility, which no longer has any immediate meaning here. As regards the preservation of the ratio in the vanishing of the quanta, it has been said, in other places, as in Carnot, Reflections sur la métaphysique du calcul infinitesimal, 87, that, because of the law of continuity, the vanishing magnitudes still retain the ratio from which they derive before they disappear. This way of representing the matter expresses its true nature, provided that the continuity of the quantum is not understood to mean the continuity which it has in the infinite progress, where the quantum continues in its vanishing, in such a way that in its beyond only a finite quantum arises again, a fresh term of the series. But the picture we have of a continuous progress is always just that, of values traversed which are still finite quanta. On the other hand, when the transition is made to the true infinite, what is continuous is the ratio. And this ratio is so continuous and persistent that the transition consists rather 21.255 inches, just bringing it out in its purity, thus causing any non-relational determination, that is, any quantum which is a side of the ratio, yet remains a quantum also when posited outside it, to vanish. This purification of the quantitative ratio is thus not unlike the grasping of an empirical existence conceptually. The empirical existence is thereby raised above itself, so that its concept contains the same determinations as it does, but grasped in their essentiality and in the unity of the concept, where they have shed their indifferent, conceptually void presence. Equally interesting is the other form of Newton's exposition of the magnitudes under discussion, namely, as generative magnitudes or principles. 88. A generated magnitude, geneta, is a product such as a quotient, root, rectangle, square, or also the sides of rectangles or squares, quite in general, of finite magnitude. Considered in ceaseless motion and flux as either increasing or decreasing, he classifies the momentary increments or decrements of such a magnitude under the name of moments. These are not to be taken, however, for particles of determinate magnitudes, particularly finity. Such particles are not themselves moments, but magnitudes generated from moments. They are to be understood, rather, as the incipient principles or beginnings of finite magnitudes. 89. Here the quantum is distinguished from itself as a product or an existent, and as it is in its becoming, in its beginning and in principle, that is to say, as it is in its concept, or again, what here amounts to the same thing, in its qualitative determination. In the latter meaning, the quantitative differences, the infinite increments or decrements, are only moments, are only the end product, when the becoming no longer has passed over into the indifference of existence and into externality, and this is a quantum. Now, although the philosophy of the true concept must acknowledge these determinations of the infinite adduced with respect to increments and decrements, it must nevertheless be noted that the forms themselves of these increments and decrements fall within the category of the immediate quantum and of the continuous progress associated with them, and that the representations of such increments, of the growth, the increase of x by dx or I, and so on, are rather to be regarded as the fundamental evil in these methods, the permanent obstacle to extracting the determination of the qualitative moment of quantity from the representation of the ordinary quantum. 21,256. Compared with the determinations just given, the representation of infinitesimals also implied in increment and decrement leaves much to be desired. According to this way of figuratively representing them, their nature is such that they may be ignored in comparison with finite magnitudes, and not only they but also their higher orders as compared with the lower, and even the products of several in comparison to a single one. With Leibniz, especially great stress is given to this demand to ignore the infinitesimals to which the previous discoverers of methods for dealing with such magnitudes equally left themselves exposed. It is this demand especially which has given calculus, together with a gain in facility, the semblance of inexactitude and deliberate incorrectness in its operations. Wolff has tried to explain it in his customary way of popularizing things, in effect, by polluting the concept and replacing it with false sense representations. What he does is to compare ignoring the infinitesimals of higher orders as against the lower with the procedure of a surveyor who, in measuring a mountain, is not any less accurate just because the wind has in the meanwhile blown a speck of sand off from the top, or with ignoring the height of houses or towers in the calculations of lunar eclipses, element. Mathis, University, Tom I. L. Annales. Math, P2. CIS Scholl. 90. Even if common sense condescends to such inexactitude, geometricians have on the contrary all rejected this way of representing things. It goes without saying that in the science of mathematics there cannot be any question of empirical exactitude. Mathematical measuring by the operations of calculus or by the constructions and proofs of geometry is totally different from land surveying, the measuring of empirical lines, figures, and so on. Besides, as already pointed out, 91 the analysts show by the comparison of a result obtained with strict geometrical procedure and with the method of infinite differences that the result is one and the same in both cases, that there is absolutely no place for a more or less inexactitude. And it is self-evident that an absolutely exact result cannot come out of an inexact procedure. Yet, despite all the protesting against the cited attempts at justifying this ignoring of infinitesimals in calculus, 21.257 the fact is that the procedure itself of calculus cannot avoid it. And this is the difficulty towards which the efforts of the analysts are directed, to comprehend where the contradiction lies and to remove it. It is especially relevant in this connection to cite Euler's construal. While adopting the general Newtonian definition, he insists that while differential calculus should consider the ratios of the increments of a magnitude, the infinite differentiation is however to be considered, as such, as wholly nil. Institute. Calc. Different. Part 1, C3. 92. How this is to be understood transpires from the foregoing. The infinite difference is a nil only of quantum, not a qualitative nil. Rather, as the nil of quantum, it is a pure moment of the ratio alone. It is not the difference of a magnitude. But, for that reason, on the one hand, it is in principle inappropriate to speak of those moments which are called infinitesimals also as increments and decrements, and as differences. This definition implies that something is added to, or is subtracted from, the initially given finite magnitude, that a subtraction or an addition, an external arithmetical operation, takes place. But the transition of the function of the variable magnitude into its differential is to be looked at as of a wholly different nature. That is to say, as already discussed, it is to be considered as the reduction of the finite function to the qualitative ratio of its quantitative determinations. On the other hand, the inappropriateness betrays itself the moment it is said that the increments are by themselves nil, that only their ratios are being considered, for a nil no longer has any determinateness at all. This exposition thus goes as far as the negative of the quantum, giving to it definite expression, but fails to grasp this negative at the same time in its positive meaning as qualitative determinations of quantity which, if extracted from the ratio and taken as quanta, would be only zeros. 21.258 Lagrange's judgment on how to represent limits, or the final ratios, theory de Font. Analyte, Introd. 93 is that, although it is easy enough to represent the ratio between two magnitudes as long as the latter remain finite, as soon as the terms of a ratio simultaneously become zero, the ratio fails to offer to the understanding any clear and distinct concept. Indeed, the understanding must get past this merely negative side on which the terms of a ratio are quantitatively as zero and grasp them positively as qualitative moments. But what Euler has to contribute in this matter, in the cited text, section 84ff, namely, that two so-called infinitesimals which are supposed to be nothing but zeros stand nevertheless in reciprocal relation and, for this reason, other symbols than the zero are used for them. This also can hardly be considered satisfactory. He tries to support his claim by distinguishing between arithmetical and geometrical ratios. In the former, we look for differences, in the latter, for quotients. Although the arithmetical ratio between two zeros is an equality, such is not the case for the geometrical ratio. Thus, if, then, because of the nature of a proportion, since the first term is twice as great as the second, also the third is double the fourth, in keeping with the proportion, should therefore be taken as the ratio of. Even in common arithmetic, if, then, but, just because or is a relation of quanta, there cannot be a ratio, or an expression, of corresponding to it. I refrain from multiplying citations since the ones examined are enough to show that the true concept of the infinite is indeed implied in them, but that it has not been accurately brought to view and recognized. As a result, as one proceeds to the operations of calculus, there is no chance that the true conceptual determination would gain control, and what happens is rather that the finite determinateness of quantity makes a return, and the operation cannot do without the figure of a quantum, which is merely relatively small. Calculus necessitates subjecting the so-called infinitesimals to the ordinary arithmetical operations of addition and so on, which are based on the nature of finite magnitudes. It therefore necessitates letting them momentarily have the value of finite magnitudes and treating them as such. It is for calculus to justify why, on the one hand, it brings those infinitesimals down to this 21.259 sphere, treating them as increments or differences, but then, on the other hand, ignores them as quanta after it has just applied to them the forms and the laws of finite magnitudes. I shall now review the most salient points in the attempts by the geometricians to sidestep these difficulties. The older analysts had few scruples in the matter, but the moderns have directed their efforts especially towards bringing infinitesimal calculus back to the evidence of a strictly geometrical method and towards attaining in it the rigor of the proofs of the ancients. Lagrange's expression, 94 in mathematics. But since its principle is of a higher nature than the principle of mathematics, infinitesimal analysis quickly had to dispense with that kind of evidence. Just like philosophy, which can make no claim to the clarity which is the prerogative of the sciences of sensible things, e.g. natural history, and like eating and drinking, which are reckoned a business more easily understood than thinking and conceptualizing. Accordingly, we shall deal only with the efforts to attain the rigor of proof of the ancients. Several authors have tried to dispense altogether with the concept of the infinite, and without it to achieve the same results as seem to be bound up with its use. Lagrange, for instance, refers to the method that Landon 95 discovered, saying of it that it is purely analytical. It does not use infinitesimal differences, but begins by introducing different values of variable magnitudes which he then equates in what follows. Lagrange's opinion, incidentally, is that in this method the single advantage of differential calculus, simplicity of method and ease of operation, is lost. This is, indeed, a procedure that bears some similarities to the tangential method which was Descartes' starting point, about which more later on. 96 Here we can note that this much is in general immediately evident, that assuming different values of variable magnitudes and then equating them belongs to another order of mathematical operation than does the method of differential calculus, and that the peculiar nature of the simple relation yet to be more closely discussed, to which 21.260 the actual, concrete determination of this calculus reduces, namely the relation of the derived function to the original, is not brought to view. The earlier of the moderns, for instance Fermat, Barrow, and others, 97, who were the first to make use of infinitesimals in the application which was later developed into differential and integral calculus, and then Leibniz also and his followers, and Euler as well, have always openly believed that they were entitled to omit the products of infinitesimal differences, as well as their higher powers, simply on the ground that they vanish relative to the lower order. This alone is the ground on which they rest the fundamental principle, namely the determination of that which is the differential of a product or of a power, for the whole theoretical teaching reduces to this. The rest is partly mechanism of development, partly application, in which, however, as we shall have to see later, the higher, or rather the whole, interest in fact lies. 98. For the point now at issue we only need to cite here what is elementary, that the first principle concerning curves is assumed on the same ground of insignificance, namely the principle that the elements of curves, the increments of the abscissa and the ordinate, are related to each other as subtangent and ordinate, that for the purpose of obtaining similar triangles, the arc that forms the third side of a triangle to the two increments of the triangle, once rightly called characteristic, is regarded as a straight line, as part of the tangent, and therefore as the one increment which reaches the tangent. On the one hand, such assumptions raise those determinations above the nature of finite magnitude. On the other hand, a method which is only valid for finite magnitudes, and which allows no room for ignoring anything on the ground of insignificance, is being applied to moments now called infinitesimal. With such a procedure, the difficulty with which the method is burdened remains in all its starkness. We must cite here a remarkable procedure of Newton, Prink, Math. Phil. Natu. Lib 2, Lemma 2, Propo. 7. 99. The invention of an ingenious device for circumventing the arithmetical incorrect omission of the products of infinite 21.261 differences or of their higher orders in finding the differentials. This is how he finds the differential of the product, from which the differentials of the quotients, the powers, and so on, can easily be derived. The product of x and y, when each is taken as decreased by half of its infinitesimal difference, becomes But if x and y are made to increase by an equal amount, it becomes. Now, subtract the first product from the second, and the remainder is a remainder that is the surplus of the increase by a whole dx and dy. For this increase is the difference between the two products. It is, therefore, the differential of xy. Clearly, in this operation the term which is the cause of the main difficulty, the product of the two infinitesimal differences, dx dy, cancels itself out. However, despite the name of Newton, it must be said that such an operation, although very elementary, is incorrect. It is not true that only the need to give a foundation to the fluxional calculus, given its importance, could have brought Newton to deceive himself about such a proof. Other forms which Newton employed in the derivation of differentials are bound up with concrete meanings, all referring to movement of the elements and their powers. In connection with the use of the serial form, which is of course the signature of his method, it is all too tempting to say that it is always in someone's power to assume as exact a magnitude as one needs by the addition of further terms, and that the omitted terms are relatively insignificant, the result being quite in general only an approximation. It is all too tempting in order not to believe that here also Newton would have been satisfied with the same justification for omitting the higher powers which, by his method of solving equations of higher degree by approximation, arise in the given equations from the substitution of any established but still inexact value, namely, on the crude ground that they are small. See Lagrange, Equations Numériques, page 125. 100. The error into which Newton fell in solving a problem by the omission of essential higher powers, an error which gave his opponents the occasion 21.262 for a triumph of their method over his, and of which Lagrange has traced the true origin in his recent investigations. Theorie de Font. Analyte, 3rd p. ch. 4. 101 is indicative of the formalism and the uncertainty which still prevailed in the use of that instrument. Lagrange shows that Newton fell into his error because he ignored the term of the series containing the power on which the specific task depended. Newton had kept to the formal, superficial principle of omitting terms because of their relative smallness. For example, it is well known that in mechanics a determinate meaning is assigned to the terms of the series in which the function of a movement is developed, so that the first term or the first function refers to the moment of velocity, the second to the accelerating force, and the third to the resistance of forces. Here, then, the terms of the series are not to be seen as parts of a sum, but as qualitative moments of a conceptual whole. In this way, the omission of the remaining terms acquires a completely different meaning than their omission on the ground of their relative smallness. K 21.263 The error in Newton's solution was in ignoring not the terms of the series only as parts of a sum, but the term containing the qualitative determination on which all depends. In this example, the procedure is made to depend on the qualitative meaning. In this connection, the general assertion can at once be made that the whole difficulty of the principle would be set aside if, instead of the formalism of defining the differential simply by the problem that gives its name to it, the problem, that is, of the difference in general between a function and its variation after its variable magnitudes have received an increment, the qualitative meaning of this principle were stated and the operation were made to depend on it. In this sense, the differential of xn is demonstratively wholly exhausted by the first term of the series, which results from the expansion of n. So, that the rest of the terms are ignored is not on account of their relative smallness. There is no supposition here of an inexactitude, of a 21.264 fault or error which would be compensated for and corrected by another error, a view on which Carnot especially relies for justifying the ordinary method of the infinitesimal calculus. 103 Since at issue here is a relation and not a sum, the differential is completely given by the first term, and where there is the need of further terms, of differentials of higher orders, their determination does not involve the continuation of a series as sum, but the repetition rather of one and the same relation, the only one wanted and the one which is, therefore, already completely determined in the first term. The need for the form of a series, its summation, and all that goes with it, must then be totally separated from this interest of the relation. The explanations which Carnot offers concerning the method of infinitesimal magnitudes contain the most limpid and most clearly expounded exposition of the upshot of the preceding reflections. However, when the transition is made to the actual operations of calculus, the usual representations about the infinite smallness of the omitted terms with respect to the others more or less creep in again. 104 Carnot justifies the method rather because, as a matter of fact, its results are the correct ones, and because of the benefits which the introduction of incomplete equations, as he calls them, that is, those in which this arithmetically incorrect omission has taken place, brings to the simplification and the abbreviating of calculus. Lagrange has famously taken up Newton's original method again, that of the series, in an effort to rise above the difficulties inherent in the representation of the infinitely small, as well as in the method of the first and final ratios and limits of his functional calculus, of which the other advantages in the matter of precision, abstraction, and generality are sufficiently known. This much alone need be said for present purposes, namely that he rests his case on the fundamental principle that the difference, without becoming zero, can be taken to be so small that each term of the series exceeds in magnitude the sum of the following terms. 105. In this method, too, the start is made from the categories of increment and from the difference of the function, the variable magnitude of which receives the increment, whence the troublesome series, 21.265 from the original function. Also in the sequel, the terms of the series to be omitted come in for consideration only as constituting a sum, and the reason for omitting them is assumed in the relativity of their quantum. Here too, therefore, on the one hand the omission is not brought back to the standpoint which prevails in some of the applications where, as was noted above, 106 the terms of the series are supposed to have a determinate qualitative meaning, and terms are disregarded, not because they are insignificant in magnitude, but because they are qualitatively insignificant. On the other hand, the omission itself ceases to have any place in the essential standpoint which, as regards the so-called differential coefficient, acquires a specifically prominent position only with Lagrange, in the so-called application of the calculus, a point which will be discussed in detail in the following remark. The general qualitative character of the form of magnitude here under discussion, as demonstrated in what in that form is called the infinitesimal, is most immediately found in the category of limit of the ratio referred to above 107 and, when carried out in calculus, has received the stamp of a method of its own. Of Lagrange's two criticisms of this method, that it lacks ease of application, and that the expression limit carries no determinate idea, we shall take up only the second here, in order to examine more closely what is being said about its analytical meaning. Now the conception of limit does indeed imply the stated true category of the qualitatively determined relation of variable magnitudes, for the forms of it which occur, dx and dy, are supposed to be taken simply as only moments of, and itself ought to be regarded as one single indivisible symbol. That the mechanism of calculus thereby loses, particularly in its application, the advantage derived from the sides of the differential coefficient being separated from each other. This we shall disregard here. Now the limit in question should be the limit of a given function. It assigns a certain value with reference to this function as determined by the manner of derivation. However, the mere category of limit takes us no further than we have gone in this remark, namely to show that the infinitely small which in the differential calculus occurs as dx and dy does not have the merely negative, empty meaning of a non-finite, non-given magnitude, as when one speaks of an infinite multitude, of an ad infinitum, and the like, but has the specific 21.266 meaning of a qualitative determinateness of the quantitative, 108 of a relational moment, 109 as such. But the category still has no relation to that which is a given function, is not itself involved in the treatment of it, or in any use that might be made in it of that determination. So, Also, the conception of limit, held to its demonstrated meaning, leads nowhere. Nevertheless, the very expression limit entails that it is the limit of something, that is, that it expresses a certain value which lies in the function of a variable magnitude, and we must see how it behaves in this concrete role. It is supposed to be the limit of the ratio between the two increments by which the two variable magnitudes connected in an equation, one of which is regarded as a function of the other, are assumed to increase. The increment is taken here as undetermined, in general, and to this extent no use is made of the infinitely small. But the procedure by which this limit is found carries with it the same inconsistencies as in the other methods. The procedure is as follows. If, then, when y becomes is supposed to change into, and so on, thus and so on, and so on. Now if k and h vanish, so vanishes also the other side of the equation, with the exception of p, which would now be the limit of the ratio of the two increments. One can see that although h, as quantum, is posited equals 0, is not for that reason taken at the same time to be, but is rather still supposed to remain a ratio. Now the advantage that the conception of limit supposedly affords is that it circumvents the inconsistency entailed here, for p is, at the same time, supposed to be not the actual ratio, which would be, but only that determinate value which the ratio can infinitely approximate, that is, can get so near to it that the difference would be smaller than any that might be given. The exact meaning of approximation, as regards that which is supposed to be in reciprocal approximation, will be considered later. 110. However, that a quantitative difference which, by definition, not only can be, but ought to be, smaller than any given, is no longer quantitative. This is self-evident, as evident as anything can be in mathematics, but then we have gone past. If, to the contrary, that is, it is assumed as a determinate quantitative ratio as it is in fact, then, conversely, the presupposition that is compromised, and this is a presupposition on the basis of which alone is found. And should it be granted that, in which case, h being is also in fact equals by entailment, for the 21.267 increment from k to y occurs only on condition that there is an increment h, the question then to be asked is what p, which is definitely a determinate quantitative value, might possibly be. To this there is at once an obvious answer, simple and to the point, namely that p is a coefficient and that it is the product of some derivation or other, the first function, derived in some determinate way, of an original function. If one is satisfied with this, as Lagrange in effect was, then the general part of the science of differential calculus, and immediately this form of it that goes under the name of theory of limits, would be rid of the increments, rid also of their infinite or arbitrary smallness, and of the difficulty of again doing away with the rest of the terms of a series other than the first, or rather other than just the coefficient of the first, terms which inevitably present themselves upon the introduction of those increments. Purged, in addition, also of all that goes with them, of the formal categories, above all of that of the infinite approximation, and likewise of the here still empty categories of continuous magnitude L which, like striving, becoming, occasion of a variation, are otherwise deemed necessary. But it would then be required to show what meaning and value p would still have, besides the determination, meager but quite adequate for the theory, that it is nothing but a function 21.268 derived from the expansion of a binomial, that is, to show what place and which use it has in the context of other mathematical requisites. This will be the subject of Remark 2. But first, we shall follow up here with an analysis of the confusion brought about by the just documented widespread use of the figurative representation of approximation in comprehending the true, qualitative determinateness of the relation, which was our original concern. It has been shown that the so-called infinitesimals express the vanishing of the sides of the ratio as quanta, and that the remainder is their quantitative relation purely determined in qualitative fashion. 112. The qualitative relation does not get lost, far from it. It is rather precisely that which results from the conversion of finite into infinite magnitudes. In this, as we have seen, is where the whole nature of the matter consists. Thus, what vanishes in the final ratio is, e.g., the quanta of the abscissa and the ordinate, but the sides of the ratio essentially remain. The one side, the element of the ordinate, the other, the element of the abscissa. When we represent one ordinate as infinitely approximating another, the previously differentiated ordinate passes over into another ordinate, and the previously differentiated abscissa passes over into another abscissa. But essentially, the ordinate does not pass over into the abscissa or the abscissa into the ordinate. The element of the ordinate, to continue with this instance of variable magnitudes, is not in the difference between one ordinate and another ordinate, but is rather the difference itself, or the qualitative determination of the magnitude of the ordinate as against the element of the abscissa. The principle of one variable magnitude as against that of another is in the relation of the one to the other. The difference, insofar as it no longer is the difference of finite magnitudes, has ceased to be a manifold in itself. It has 21.269 collapsed in a simple intensity into the determinateness of the one qualitative moment of a ratio against the other. This is how the matter stands, but its nature is obscured because what we have just called the element of, for instance, the ordinate, is grasped as difference or increment in such a way that it is only the difference between the quantum of one ordinate and the quantum of another ordinate. As a result, limit does not have here the meaning of ratio. It only stands for the final value to which another magnitude of equal kind can come as close as one will and still be differentiated from it, the final ratio being a ratio of equality. The infinite difference is thus the fluctuation of a difference between one quantum and another quantum, and in this representation the qualitative nature, which makes dx essentially not a ratio determination relative to x, but to dx, is overlooked. dx too is made to vanish relative to dx, but even more does dx vanish relative to x, and this means in truth that it has a relation only to dy. In expositions of this kind, it is the geometricians especially whose constant concern is to conceptualize the approximation of a magnitude to its limit, and who insist on stressing this aspect of the difference of quantum from quantum, that it is not a difference, and yet it is. But all the same, approximation is by itself a category that says nothing and conceptualizes nothing. The fact is that dx has already left approximation behind. It is neither close nor closer, and as for the meaning of infinitely close, it is the negation of being close and approximation. Now, because the increments or the infinitesimals have thus been viewed only from the standpoint of the quantum that vanishes in them, and only as limits of this quantum, they have also been grasped as unrelated moments. From this would follow that it is allowed in the final ratio to posit, say, the abscissa and the ordinate, or also the sine, cosine, tangent, verse sine, or what have you, as equal to each other. But this is an inadmissible position. The inadmissibility seems especially to hold when an arc is treated like a tangent. For 21.270 the arc, too, is surely incommensurable with the straight line. Its element is, from the start, of another quality than the element of the straight line. Squaring the circle, taking a part of the arc, however infinitely small, to be a part of the tangent and thus to treat it as a straight line seems even more absurd and inadmissible than confusing abscissa, ordinate, verse sine, cosine, etc. However, there is an essential difference between this way of treating the arc and the confusion that we have decried. The procedure here is justified because in the triangle which has as its sides the element of an arc and the element of its abscissa and ordinate, the relation is the same as if that element of the arc were the element of a straight line, of the tangent. The angles which constitute the essential relation, that is, that which remains to these elements when their respective finite magnitudes are abstracted from, are the same. This can also be expressed by saying that straight lines, when infinitely small, have passed over into curved lines, that their relation in their infinity is a relation of curves. Since the straight line is by definition the shortest distance between 2 points, Its difference from the curved line is based on the determination of amount, on the smaller number of what is differentiable in this distance, a determination, therefore, of a quantum. But this determination vanishes in the line when it is taken as an intensive magnitude, as infinite moment, as element, and so does also its difference from the curved line, which rested simply on a difference of quantum. As infinite, therefore, the straight line and the arc no longer retain any quantitative relation and consequently, by virtue of the assumed definition, also no qualitative difference from each other either. On the contrary, the one passes over into the other. Similar to the equating of heterogeneous determinations, but at the same time different from it, is the assumption that 21.271 infinitely small parts of a same whole are equal to each other. By itself, this assumption is indeterminate and completely indifferent, but when applied to an object which is internally heterogeneous, that is, constrained by an essentially non-uniform quantitative determination, it produces the peculiar reversal contained in that proposition of higher mechanics according to which infinitely small parts of a curve are traversed in equal and infinitely small times in uniform motion, where this is said of a motion in which, in equal finite, that is, concretely, existing, parts of time, finite, that is, concretely existing, unequal parts of the curve are traversed, that is said of a motion which exists concretely as non-uniform and is assumed to be such. This proposition is the expression in words of what an analytical term, such as is obtained by the already cited expansion of the formula of a motion which is non-uniform but otherwise conforms to Law 113, is supposed to mean. Earlier mathematicians sought to express the results of the newly invented infinitesimal calculus, which, after all, always had to do with concrete objects, in words and propositions, and to exhibit them in concrete geometrical constructions, basically to use them as theorems in the ordinary method of proof. The terms of the mathematical formula into which analysis transposed the magnitudes of the object, of motion for instance, were invested there with an objective meaning, such as a velocity, force of acceleration, etc., and in virtue of this meaning the terms were supposed to yield correct propositions, physical laws, and also, in conformity with the analytical connectedness, their objective links and relations. For instance, the specific velocity that obtains in a uniformly accelerating motion is proportional to the times, but in addition there is always an increment that accrues to the velocity from the force of gravity. In the modern analytical form of mechanics, such propositions are advanced simply as the results of calculus, without worrying whether they have by themselves, within them, a real sense, that is, one that would correspond to concrete existence, and without bothering with a proof for it. The difficulty of conceptualizing the link between such determinations when taken in this real sense just mentioned, as for instance the transition from absolutely uniform velocity to uniformly accelerated velocity, is deemed to be completely circumvented by the analytical treatment in which the link is a simple result of the authority henceforth reigning of the operations of calculus. It is now declared a triumph of science that merely by means of calculus, it can discover laws that transcend experience, that is, propositions regarding concrete existence which have no existence. But in the earlier, still naive time of infinitesimal calculus, 21.272 the aim was to give to such determinations and propositions as were represented in geometrical figures a real sense of their own, to make them plausible and to apply them in this sense to the proof of the main propositions concerned. See Newton's proof of his fundamental propositions of the theory of gravitation in Prink. Madhem. Naturalis, Lib I, Sector 2. Prop. I. Compared with Schubert's Astronomy. First eden. Book 3, Section 20, where it is admitted that things are not exactly as Newton assumed them, that is, at the very point which is the nerve of the proof. 114. It cannot be denied that, especially with the aid of the fog of the infinitely small, much has been accepted as proof in this field for no other reason except that the result had already always been known to be true and the proof, deliberately devised to reach that result, created at least the illusion of a scaffolding of proof, an illusion which was still preferred to mere belief or to knowledge from experience. I personally make no scruples about regarding this affectation as nothing more than sleight of hand and logical charlatanism, and I extend this judgment to Newton's proofs as well, those especially which fall within the purview of the present discussion and for which Newton has been extolled to the skies above Kepler, because he has established mathematically what the latter had discovered by experience alone. The empty scaffolding of such proofs was erected in order to prove physical laws. But mathematics is in principle incapable of demonstrating the quantitative determinations of physics, for these determinations are laws based on the qualitative nature of its elements. It cannot, for the simple reason that this science is not philosophy, does not proceed from the concept, and therefore anything qualitative which cannot be derived lemmatically from experience falls outside its sphere. It is for mathematics a point of honor that all its propositions ought to be rigorously proved, and this made it forget its limits. It seemed an offense to this honor that experience would be acknowledged as alone the source and sole proof of propositions of experience. Consciousness has 21.273 gained in sophistication since then, but as long as it is not clear about the distinction between what can be proved mathematically and what can only be taken from elsewhere, between the mere terms of an analytical expansion and things that exist physically, scientific culture will lack rigor and purity. Undoubtedly, this scaffolding of Newtonian proof will be subject to the same justice as was Newton's other baseless artifact, his construct of optical experiments and the conclusions bound to them. Applied mathematics is still full of a like brew of experience and reflection, but just as part after part of Newtonian optics has already for some time begun to be ignored by science as a matter of fact, though the rest is inconsistently allowed to stand despite the consequent contradiction. So it is also a fact that a part of those pseudo-proofs has already naturally fallen into oblivion or have been replaced by others. Remark 2. The purpose of differential calculus deduced from its application. In the previous remark, we considered the conceptual nature of the infinitesimal, which is used in differential calculus, as well as the reason for introducing it in that calculus. Both are abstract determinations, and therefore also intrinsically easy. Its so-called application, however, presents more serious difficulties, but also the more interesting side. The elements of this side will be the subject of the present remark. The whole method of the differential calculus is covered by the proposition, or, that is equal to the coefficient of the first term of the binomial, raised to the power of dx or I. There is no need to learn anything further. The derivation of the subsequent forms, of the differential of a product, of an exponential magnitude, and so forth, follows mechanically. In a short time, 21.274 half an hour or so, one can be in possession of the whole theory, and with the finding of the differential. The converse, or the finding from the differential of the original function, is equally given. What takes longer is the endeavor to see, to grasp conceptually, how it is that, after easily managing analytically, that is, purely arithmetically, one condition of the task, namely the finding of the said coefficient by the expansion of the function of the variable after the latter has received the form of a binomial by the addition of an increment. How, after this part of the task, the other condition, namely the omission of the remaining terms of the series except the first, can also be correct. If the coefficient alone were all that is necessary, then, once this is determined, all that concerns the theory would be taken care of in less than half an hour, as we said. The omission of the further terms of the series would present no difficulty. Far from it, for such terms, as terms of the series, their determination as second, third, etc., function is already absolved with the determination of the first, would not come into question at all since they are of no relevance. We may begin by remarking that the method of differential calculus has all the markings of not having been invented and developed for its own sake. Not only is it not grounded for itself as any other form of analysis, What is more is that the arbitrary direct omission of terms that have resulted from the development of a function, despite the fact that this whole development is taken to belong fully to the matter at hand, which is considered to be the difference between the developed function of a variable, after this has been given the form of a binomial, and the original function, that this omission totally contradicts every mathematical principle. The need to proceed in this way, as well as the lack of internal justification for the procedure, immediately suggests that the origin and foundation must lie elsewhere. It happens also in other sciences that what is presumed at the start to be the primitive element from which the propositions of a science will have to be derived is in fact not self-evident, but proves rather to have its cause and justification in what follows. The course of events in the history of the differential calculus makes it clear that it originated in the various so-called tangential methods, its subject matter in ingenious devices as it were. It was only later, when its method was extended to other subject matters, that the nature of this method came in for conscious reflection and formalization, and the attempt was made to raise its abstract formulas to principles. 21,275. We have shown that the conceptual determinateness of the so-called infinitesimal is the qualitative determinateness of the quantity of such quanta as are first posited in relation to each other. Attached to this, there came the empirical undertaking of discovering this conceptual determinateness in such descriptions or definitions of the infinitesimal as are found of it when taken as an infinitely small difference or the like. This was done in the interest of abstract conceptual determinateness as such. The next question would be about the nature of the transition to mathematical formulation and application. To this end, we must first examine the theoretical side further, the conceptual determinateness, and this is a task which will prove to be not altogether unfruitful even by itself. We must then consider the relation of this theoretical side to its application, and show in the case of both, inasmuch as it is relevant here, that the general conclusions are adequate to both the purpose of differential calculus and the method by which it realizes it. First, we must remember that the specifically mathematical form of the concept now at issue has already been given in passing. The qualitative determinateness of quantity is first exhibited in the quantitative relation as such. However, already in the demonstration of the various so-called kinds of reckoning. See the relevant remark. 115. It was anticipated that it would be in the relation of powers, still to be considered in its proper place. 116. That number, by the equating of the moments of its concept, unity and amount, is posited as having turned back into itself, and that, as such, it would receive the element of infinity, of being for itself, that is, of being determined through itself. Thus, as already indicated, the explicitly qualitative determinateness of magnitude is essentially connected with the determinations of powers, and since differential calculus specifically operates with qualitative forms of magnitudes, the mathematical subject matter that specifically belongs to it must be the treatment of forms of powers. It is also the whole range of problems, together with their solutions, for the sake of which differential calculus is employed, which shows that its interest lies solely in the treatment of determinations of powers as such. This is an important opening position. It at once puts in the forefront something determinate instead of the merely formal categories of variable, continuous, or infinite magnitudes, or even only of functions in general. Yet it is still too general, for there are other operations that deal equally with powers. The raising to a power, the extraction of a root. Also the treatment of exponential magnitudes and logarithms, of series, of equations of higher powers. The 21.276 interest and the effort of all these operations lies solely in relations based on powers. Undoubtedly, together they constitute a system of the treatment of powers, but which of the various relations in which the determinations of powers may be put is the proper subject matter and interest of differential calculus? This is to be ascertained from the differential calculus itself, that is, from its so-called applications. These constitute in fact the core of the matter, the actual procedure in the mathematical solution of a certain group of problems. This procedure came earlier than any theory or general part and was called an application later, only in connection with the then created theory, the intention of which was in part to draw up its general method for the procedure, but in part also to find principles for it, that is, a justification. We have shown in the preceding remark 117 the futility of searching for principles that would effectively resolve the contradiction patent in the current conceptions of the method of calculus. We have shown this futility instead of excusing it or of hiding it on the pretext that what is necessary for mathematical practice is however out of consideration here, or what amounts to the same thing, with the possibility of an infinite or arbitrary approximation to the infinite or the like nonsense. These principles and all the fuss made on their behalf, if the general method of this real part of mathematics called differential calculus were abstracted differently than it has been done so far, would turn out to be indeed just as superfluous as they are inherently defective and irrevocably contradictory. If we investigate what is distinctive about differential calculus by the simple inventory of what there is in this part of mathematics, we find the following as the subject matter. Alpha, equations in which any number of magnitudes, here we need simply confine ourselves to two, are combined into one determinate whole in such a way that, first, the equations themselves derive their determinateness from empirical magnitudes which are their fixed limits, and also from the kind of link which they have with these limits and with each other, as is generally the case in an equation. But since there is only one equation for both magnitudes, and relatively more equations for more magnitudes, but always less than the number of the magnitudes, these equations belong to the class of indeterminate equations. And, second, one feature of the determinateness of these magnitudes, or of one of them at least, is that these magnitudes occur in the equation with a power higher than the first power. A few observations in this regard are in order here. The first is that the magnitudes in the first of the above two headings exclusively have the character of such 21.277 variables as occur in the problems of indeterminate analysis. Their value is indeterminate, but if a completely determinate value accrues to one of them from elsewhere, that is, a numerical value, then the other also becomes determinate, so that one is a function of the other. For the specific magnitudes here at issue, therefore, the categories of variables' magnitudes, of functions, and the like, are merely formal, as we said earlier. 118 because they are still too general to contain the kind of specificity to which the whole interest of differential calculus is directed, nor can this specificity be developed out of it analytically. They are as such simple, insignificant, easy determinations that are rendered difficult by importing into them that which is not in them, in order then to derive it from them, namely the specific determination of differential calculus. Then, as regards the so-called constant, it should be noted that it is at first an indifferent empirical magnitude determining the variables merely with respect to their empirical quantum, as a limit of their minimum and their maximum. But the nature of the link connecting the constants to the variables is itself one factor defining the particular function which these magnitudes are. But, conversely, the constants themselves are also functions. For instance, inasmuch as a straight line carries the meaning of being the parameter of a parable, this, its meaning, is that it is the function. As in the expansion of a binomial generally, the constant which is the coefficient of the first term of the expansion is the sum of the roots, the coefficient of the second term is the sum of their products in twos, and so on. Hence these constants are here in general functions of the roots, where, in integral calculus, the constant is determined from the given formula. It is to that extent treated as a function of that formula. We shall further consider these coefficients later on, but in another determination than that of functions, their concrete meaning being the real point of interest. 119. Now the essential difference between variables as considered in differential calculus and as they are in indeterminate problems lies in what has just been said, namely that at least one of those magnitudes, or also all of them, is in a power higher than that of one, though it is again a matter of indifference whether they are all of the same higher power or of unequal powers. The indeterminateness specific to them consists solely in this, that in such a relation of power they are functions of one another. 21.278 The alteration of the variables is thus qualitatively determined and consequently continuous, and this continuity, itself again only the formal general category of an identity, of a determinateness preserved unaltered in the alteration, has its determinate meaning here. Solely in the power relation which does not have a quantum for its exponent and constitutes the non-quantitative, permanent determinateness of the ratio of the variables. It is therefore also to be noted, this time against another form of formalism, that the first power is a power only in relation to higher powers. By itself, x is just an indeterminate quantum. Thus there is no point in differentiating for their own sake the equations, the equation of the straight line, or that of absolutely uniform velocity, if from, or also from. We obtain, or from, then is equally the determination of the tangent, or the determination of simple velocity. This last is expounded as in the context of what is said to be the expansion of uniformly accelerated motion, but that there would occur in the system a moment of simple, absolutely uniform velocity, that is, one not determined by the higher power of one of the moments of the motion. This, as remarked earlier, 120, is itself an empty assumption based solely on the routine of the method. Since the method has its inception in the representation of the increment which the variable is supposed to sustain, then of course a variable, which is only a function of the first power, can also sustain an increment. Now, if in order to find the differential we have to subtract the difference of the second equation thus produced from the one given, the emptiness of the operation becomes obvious. For the so-called increment is the same for all the alterable terms themselves. Beta, we have identified the nature of the equation which we want to treat. Now we must declare the interest that motivates our treatment of it. This consideration can only yield known results, especially in the form in which they are found in Lagrange's version. But in my exposition, I have restricted myself to basic elements in order to eliminate from it any heterogeneous material otherwise mixed with it. The patent basis for the treatment of an equation of this kind is that the power is taken to be a relation inside itself, a system of relational determinations. We said earlier that power is number which has attained a state 21.279 at which it determines its own alteration. Its moments, unity and amount, are identical, perfectly identical, as previously demonstrated, first of all in the square, and, a point of no consequence here, formally identical in the higher powers. 121 Now, since as number the power is an aggregate, even if one prefers the expression magnitude because of its greater generality, in itself power still is always a number, and is also presented as a sum. It can be directly broken up internally into an arbitrary grouping of numbers that have no other determination with respect to each other and to the sum except that together they equal the latter. But the power can also be divided into a sum of distinct terms determined by the form of the power. If the power is taken as sum, then its radical number, the root, is also taken as a sum, arbitrarily, after repeated division, the manifoldness as something indifferent, empirically quantitative. The sum which is supposed to be the root, reduced to its simple determinateness, that is, its true generality, is the binomial. Any other increase of the terms is a mere repetition of the same determination and, therefore, something empty. And what matters here is only the qualitative determinateness of the terms which result from the raising to a power of the root taken as sum, a determinateness which lies solely in the alteration which the potentiation is. Consequently, these terms are wholly functions of the potentiation and of the power. Now this exposition of number as the sum of an aggregate of terms which are the functions of the potentiation, added to the interest in finding the form of such functions, and also this sum from the aggregate of the terms, in so far as this find must depend on that form alone. This, as we know, constitutes the special theory of series. But it is essential here that we distinguish another source of interest, namely the relation of the underlying magnitude, of which the determinateness, since it is a complex, that is, an equation here, includes in itself a power, to the functions of the raising of it to a power. This relation, taken in total abstraction from the just mentioned 21.280 interest of the sum, will prove to be the only intended point of view of differential calculus, which is in fact realized by the science. But we must first add one more determination to what has been said, or, better, remove one which is there. For we have said that the power enters into the variable determination of a magnitude which is regarded as a sum inside itself, in fact a system of terms in so far as these are functions of the raising to a power, and that the root is also thereby regarded as a sum, in the simply determined form of a binomial. This exposition was all right for the expansion of the power, that is, for obtaining the functions of its being raised to a power from the sum as such. But the issue here is not a sum as such or the series arising from it, but only the connection to be taken from the sum. All that remains after the plus of a sum as sum is abstracted from is, on the one hand, the connection as such of the magnitudes, and, on the other hand, all that is needed for finding the functions of the expansion of the power. But that connection is already determined by the fact that the object here is an equation, already a complex of several, variable, magnitudes which contains a power determination of them. In this complex, each of these magnitudes is posited simply as connected with the others, as a function of the other magnitudes, each carrying, as one could say, a plus in it. This plus determination is given to them by their character as functions of one another, but precisely for this reason the determination is totally indeterminate, is not an increase or an increment or the like. Yet even this abstract point of view could be left out of account. We can quite simply stop at the point where, since in the equation the variables are given as reciprocal functions in a determinateness, which thus contains a relation of power, also the functions of the raising to a power of each are now compared with each other, and these second functions are determined by nothing else except the potentiating itself. At the start, to convert an equation of the powers of its variables into a relation of the functions of its expansion can be said to be a matter of choice or a possibility. Only some further purpose, need, or use has to step in to indicate the usefulness of such a transformation. The transposition was occasioned by its usefulness alone. When we began just now with the exposition, in a magnitude which is taken as an internally differentiated sum, of these potentiating determinations, this served only in part to indicate of which kind such functions were. In part, it was the way of finding them. 21,281. What we have here is an adaptation for the purpose of differential calculus of the usual analytical form of development. An increment, dx, I, is assigned to the variable, and then the power of the binomial is expanded by the terms of the series belonging to it. But the so-called increment is supposed to be not a quantum, only a form, the whole value of which is that it assists in the development. It is admitted, notably by Euler and Lagrange, and in the representation of limit earlier cited, that what is wanted are only the resulting power determinations of the variables, the so-called coefficients, namely of the increment and its powers, according to which the series is ordered and to which the different coefficients belong. It may be noted in this connection that since an increment with no quantum is being assumed here only for the sake of the development, it would have been more suitable to take one, the unit, for that purpose, for that increment constantly recurs as a factor in the development, and the factor of 1 fulfills precisely the purpose of having an increment without any quantitative determinateness or alteration being posited thereby, whereas dx, burdened as it is by the false representation of a quantitative difference, and other signs such as I, burdened for their part by a show of generality that is here pointless, always have the semblance and the pretension of a quantum and its powers, and the pretension, despite its being just that, brings with it the trouble of removing and omitting what is pretended. In order to retain the form of a series expanded on the basis of powers, the designations of the exponents as indices could just as well be attached to the one. But in any case, abstraction must be made from the series and the determination which the coefficients have according to the place they occupy in it. The relation between all of them is the same. The second function is derived from the first in exactly the same manner as this is derived from the original, and for any function counted second, the one derived first is again the original. But the essential point of interest is not in the series, but solely in the determination of the power that results from the expansion, as related to the magnitude which for the power determination is immediate. Therefore, instead of defining it as the coefficient of the first term of the development, for a term is designated as the first with reference to the others that follow it in the series, but any such power as that of an increment, like the series itself, has no place here. The plain expression, derived function of a power, or the just said, function of the raising of a magnitude to a power, would be preferable. These are expressions which presuppose that the derivation is a development, falling within a power. 21,282. Now, if the strictly mathematical beginning in this part of the analytic is nothing more than the finding of the function determined by the expansion of the power, the next question is what to do with this relation thus obtained. Or does it have an application and use? In effect, for what purpose are such functions sought? It is because of relations in concrete objects which allow reduction to those abstract, analytical functions that differential calculus has become the source of great interest. But as regards the question of the application, this much follows directly from the nature of the fact itself, because of the form which the moments of a power assume as demonstrated, without having to infer it from individual cases of the application itself. Namely, the development of the magnitudes of the powers that yields the functions of their potentiation entails at first abstraction made of a more precise determination, simply the reduction of their magnitude to the next lower power. This applicability of this operation is to be found, therefore, in connection with objects in which there is likewise present such a difference of power determinations. Thus, if we reflect on the properties of space, we find that space has three dimensions which, in order to distinguish them from the abstract differences of height, length, and breadth, we can call concrete. They are, namely, line, plane, and total space. And if we take them in their simplest form and with reference to self-determination and consequently to analytical dimensions, we then have straight line, plane surface, and surface as square and as cube. The straight line has an empirical quantum, but with the plane there enters the qualitative element, the power determination. More detailed considerations, e.g. that the case extends to plane curves, we can leave undiscussed, for we are concerned primarily with the distinction in general. It is here that the need also arises to pass from a higher power to a lower, and vice versa, when, for instance, linear determinations are to be derived from given equations of the plane, etc., or vice versa. The motion, further, in connection with which we have to consider the quantitative relation of the space traversed to the time elapsed in traversing it, assumes the various determinations of a simply uniform motion, a uniformly accelerated one, and one which is alternatively uniformly accelerated and uniformly retarded, motion that turns back upon itself. Inasmuch as these various species of motion are expressed in accordance with the quantitative relation of their moments, of space and time, we have for them equations of various power determinations, and inasmuch as the need arises to determine one species of motion, or also of spatial magnitudes to which 21.283 a species of motion is associated, from another species of motion, such an operation likewise entails the transition from one power function to another, whether higher or lower. These two examples will suffice for the purpose for which they were adduced. The semblance of arbitrariness to which differential calculus gives rise in the course of its applications would already be brought under control by a consciousness of the nature of the areas in which an application can be made, of the particular need for the application and the condition under which it is made. But now, it is also within these same areas that one gets to know between which terms of a mathematical problem such a relation occurs, as is properly posited by differential calculus. It must be noted first of all that two relations are at issue here. The operation of lowering the degree of an equation, considered according to the derivative functions of its variables, yields a result which in itself no longer truly is an equation but is a relation. It is this relation which is the subject matter of differential calculus proper. Also given with it, secondly, is the relation of the higher power determination itself, the original equation, to the lower, the derivative. This second relation we must leave aside for the time being. It will prove to be the subject matter of integral calculus. Let us start by considering the first relation, and for the determination of the moment in which the interest of the operation lies, the moment to be derived from the so-called application. Let us take the simplest example, that of curves defined by an equation of the second power. As we know, the relation of the coordinates is directly given by the equation in a power form. From the fundamental determination, there follow the determinations of the other straight lines linked to the coordinates, the tangent, subtangent, normal, and so on. But the equations between these lines and the coordinates are linear equations. The wholes, of which these lines are determined as parts, are right-angled triangles formed by straight lines. The transition from the original equation in power form to these linear equations involves now the said transition from the original function, that is, one which is an equation, to the derived function, which is a relation, specifically, between certain lines contained in the curve. The problem is to find the link between the relation of these lines and the equation of the curve. 21,284. It is not without historical interest to remark this much, that the first discoverers only knew how to report their findings in a wholly empirical manner without being able to give an account of the operation, which remains something completely external. I shall limit myself in this regard to citing Barrow, Newton's teacher, in his Opt. et Geometry, where he deals with problems of higher geometry according to the method of the indivisibles, a method which at first diverges from what is most characteristic of differential calculus. He also gives an account of his procedure for determining the tangents because, as he says, his friends so urged him. Lect. X. 122.1 must read for oneself how he sets up his problem to have a proper idea of this procedure. It is formulated wholly as an external rule, in the same style as was once, in the school books of arithmetic, the rule of 3, or better still the so-called test of 9 for the 4 operations. He draws the tiny lines which were later called the increments in the triangle characteristic of a curve and then gives the instruction, as a mere rule, to eliminate as superfluous the terms which, as a result of the expansion of the equations, turn up as the powers of such increments or as products. Edenim isti termini nihilum veilbat. 123. Similarly, to omit the terms which contain magnitudes only determined by the original equation, the subsequent subtraction of the original equation from the one construed with the increments, and finally to substitute, for the increment of the ordinate itself, and for the increment of the abscissa, the subtangent. The procedure, if one may say so, could not be laid out in a more schoolmasterly form. The last substitution is the assumption of the proportionality of the increments of the ordinate and abscissa to the ordinate and subtangent, which in the ordinary differential method is made the basis for the determination of the tangent. In Barrow's rule, this assumption stands out in all its naive nakedness. A simple way of determining the subtangent was found. Roberval's and Fermat's artifices follow a similar course. The method for finding maximal and minimal values from which Fermat started rests on the same basis and the same procedure. 124. To find so-called methods, that is, rules of that kind, was the obsession of the time, and also to make a secret of them, which was not only easy but in one respect also necessary, for the very reason that made it easy, because the inventors had found only an empirical, external rule, not a method, that is, nothing derived from recognized principles. Leibniz was indebted for such so-called methods to his contemporaries, and Newton also was indebted to them, even though he received them directly from his teacher. By 21.285, generalizing their form and range of application, They opened up new paths for the sciences, but in this they also felt the need to wrest the procedure free of the shape of external rules. They sought to give to it the necessary justification. If we now analyze the method more closely, this is how it actually proceeds. First, the power determinations, understood, of the variables contained in the equation are reduced to their first functions. But the value of the terms of the equation is thereby altered. There is no equation left, therefore, but what has arisen is instead only a relation between the first function of one variable and the first function of the other, instead of we have, or instead of we have, which it later became common to designate as the relation. The equation is that of a curve, whereas this relation which is totally dependent on it and is derived from it, above, according to a mere rule, is a linear relation with which certain lines are in proportion, or are themselves relations of straight lines of the curve, the coordinates, and the parameters. However, with all this, nothing is as yet known. The point of interest is to know, regarding other lines connected with the curve, whether that derived linear relation applies to them, to find out the equality of two relations. Second, this is therefore the question: which are the straight lines determined by the nature of the curve, which stand in this relation? But this is what was known already, namely that a relation obtained in this way is the relation of the ordinate to the subtangent. This the ancients had found out in an ingenious geometrical manner. What the moderns have discovered is the empirical procedure for setting up the equation of the curve in such a way that it will yield the first relation of which it was already known that it is equal to a relation containing the line to be determined, here the subtangent. Now, on the one hand, the setting up of this equation, the differentiation, has been methodically conceived and methodically executed. On the other hand, the imaginary increments of the coordinates, and the imaginary characteristic triangle formed by them, and an equally imaginary increment of the tangent, were invented in order to present the proportionality of the ratio, which was obtained by lowering the degree of the equation to the ratio of the ordinate and the subtangent, not as something just picked up empirically from something already known, but as demonstrated. However, in the external form that the cited rules assume, this already known something proves to be, everywhere and unmistakably, the sole occasion and justification for the assumption of, respectively, the characteristic triangle and the said proportionality. Point 21, 286. Lagrange was the one who did away with this pretense and pursued the genuinely scientific way. It is to his method that we owe the insight into the decisive point, for it consists in separating the two transitions required for the solution of the problem and improving each by treating it by itself. The one side of this solution, inasmuch as, for the sake of detailing the steps involved, we restrict ourselves to the elementary example of the problem of finding the subtangent, the theoretical or general part, namely how to find the first function from the given equation of the curve, has its own internal rule. This part yields a linear relation, hence a relation of straight lines that occur in the system defined by the curve. The other part of the solution now consists in finding the lines in the curve that enter into such a relation. And this is now done in a direct manner, theory de font. Anal. 2p2. Chap. 125, that is, without the characteristic triangle, which means without assuming infinitely small arcs, ordinates, and abscisses, and without attributing to these the determinations of dy and dx, that is, of the sides of that relation, and at the same time immediately the meaning of the equality of this relation with the ordinate and the subtangent themselves. 126. A line, like a point also, obtains determination only in so far as it constitutes the side of a triangle, and the determination of a point also lies in that. This, I may mention in passing, is the fundamental proposition of analytical geometry from which the coordinates of that science are derived, just as from it the parallelogram of forces is derived in mechanics. It amounts to the same thing, for which reason the many efforts to find a proof for it are quite superfluous. The subtangent is now posited as the side of a triangle, the other sides of which are the ordinate and the tangent connected to it. The equation of the latter, as a straight line, adding is needless, but is done only out of fondness for generality. The determination of the ratio falls within a, the coefficient of q, which is the respective first function of the equation, but may simply be considered as, and this is, as we said, the essential determination of the straight line applied to the curve as tangent. Since now, further, the first function of the equation of the curve is taken to be equally the determination of a straight line, and since p, the one coordinate of the first straight line, and y, the ordinate of the curve, are assumed to be the same, we assume, therefore, that the point at which the first straight line taken as the tangent touching the curve is equally the starting point of the straight line determined by the function of the curve. Then all comes down to showing that this second straight line is congruent with the first, that is a tangent. 21.287, or, algebraically expressed, that since, and, assuming that, and hence, also. Now, that the straight line applied as tangent and the straight line determined from the equation by way of its first function coincide, that this last is also tangent. This is demonstrated with the aid of the increment I of the abscissa and the increment of the ordinate determined by the expansion of the function. Here also, therefore, the infamous increment steps in. However, how it is here introduced for the purpose just stated, and how the function is expanded with its aid, must be distinguished from the earlier mentioned use of the increment in finding the differential equation and in the characteristic triangle. Its use here is both justified and necessary. It falls within the parameter of geometry, for it is of the definition of a tangent as such that between it and the curve with which it has a point in common, no other straight line can be drawn which also passes through this same point. For, as thus determined, the quality of tangent or non-tangent is reduced to a quantitative difference. The tangent is the line to which, with respect to the determination here at issue, the greater smallness accrues. This seemingly only relative smallness contains nothing empirical whatever, that is, nothing that depends on a quantum as such. It is posited as qualitative by the nature of the formula. Whenever the difference of the moment on which the magnitude to be compared depends is a difference of power, since this difference comes down to I and I2, and I, which after all is supposed to signify a number, is then to be represented as a fraction. I2 is in and for itself smaller than I, so that even the representation of an arbitrary magnitude in which I might be taken is here superfluous and in fact out of place. Precisely for this reason, the demonstration of the greater smallness has nothing to do with something infinitely small, for which there is thus no need to bring it in here at all. Even if only for its beauty and its well-deserved but nowadays forgotten merit, I must also mention Descartes' tangential method. It has, at any rate, a bearing on the nature of equations regarding which yet one more remark is to be made. Descartes expounds this independent method, in which the required linear determination is likewise found from the same derivative function, in his Geometry, a seminal work in other ways as well, Liv. 2, page 357 ss. over Compel. Ed. Cousin Tom v. 127. It is here that he taught the great basis of the nature of equations and their geometrical construction, and of the application of analysis, which he thereby greatly expanded in scope, to geometry. The problem takes with him the form of a task. 21.288 of drawing straight lines perpendicularly to given points on a curve in order in this way to determine the subtangent, etc. One can understand his satisfaction at a discovery which met the one object of universal scientific interest at the time, and it was so purely geometrical that it vastly surpassed the merely rule-bound method of his rivals cited above. As he expressed it there, José Dyer que se cc le problème le plus utile et le plus général, non seulement que j'y sache, mais même que j'y jamais desire de savoir, in geometry. 128. He bases his solution on the analytical equation of the right-angled triangle formed by 1. The ordinate of the point on the curve to which the required straight line in the problem should be drawn perpendicularly. 2. By this same straight line, the normal. 3. By that part of the axis cut off by the ordinate and the normal, the subnormal. Now from the known equation of a curve, the value of either the ordinate or the abscissa is substituted in the equation of this triangle, the result being an equation of the second degree, and Descartes shows how even curves of which the equations are of higher degrees reduce to this, in which only one of the variables still occurs, indeed as a square and in the first power. This is a quadratic equation, which makes its first appearance as a so-called impure equation. Descartes now observes that if the point assumed on the curve is imagined as at the intersection of the curve and a circle, this circle will cut the curve at yet another point, and the result for the two unequal x's thus produced will be two equations with the same constants and of the same form, or else only one equation with unequal values of x. But there will be only one equation for the one triangle in which the hypotenuse is perpendicular to the curve, the normal, as we can imagine if we let the two intersection points of curve and circle coincide, and the circle therefore touch the curve. With that, however, the circumstance which makes for the unequal roots of the x or y of the quadratic equation also falls away. But now, in a quadratic equation of two equal roots, the coefficient of the term containing the unknown in the first power is double the single root, and this now yields an equation for obtaining the desired determinations. This procedure is indeed the brilliant stroke of a truly analytical mind. The merely asserted proportionality of the subtangent and the ordinate with the alleged infinitely small so-called increments of the abscissa and the ordinate pale in comparison. The final equation obtained in this way, in which the coefficient 21.289 of the second term of the quadratic equation is equated with the double root or the unknown, is the same as is obtained by the method of differential calculus. The differentiation of gives the new equation. Or gives. Of course, the point can be made here that it is not by any means self-evident that such a derivative equation is also correct. Only a ratio, as remarked above, 129 results from an equation of two variables which, just because they are variables, do not lose their character as unknowns, for the simple reason that, by substituting the functions of power raising for the powers themselves, the value of the two terms of the equation are altered, and whether an equation still obtains between the two terms in their thus altered value is still per se unknown. All that the equation expresses is that P is a ratio, and there is no otherwise real meaning to ascribe to. But it is equally still unknown of this ratio to what other ratio it is equal. It is only the equation, the proportionality, that gives a value and meaning to it. Just as we said that this meaning, then a matter of application, is taken from elsewhere, empirically, 130, so with respect to the equations now at issue which are derived by differentiation, it is from elsewhere that we must know whether they have equal roots in order to find out whether the equation obtained is still correct. This is a circumstance, however, which the textbooks fail to bring to explicit notice. It is of course eliminated when an equation of one unknown, reduced to zero, is straightaway equated with y, with the result, mind you, that by differentiation only a ratio, a, is obtained. Of course, the calculus of functions should deal with the functions of power raising, while differential calculus with differentials. But it by no means follows from this as a matter of course that the magnitudes of which we take the differentials or functions of power raising would themselves also have to be only functions of other magnitudes. Besides, in the theoretical part, where it is shown how to derive the differentials, that is, the functions of power raising, there is still no indication that the magnitudes which we learn to manipulate in such a derivation are supposed to be themselves the functions of other magnitudes. Regarding the omission of the constant in differentiation, attention can further be drawn to the fact that the meaning of the omission here is that it makes no difference to the determination of the roots if these are equal, for this 21.290 determination is exhausted by the coefficients of the second term of the equation. As in the cited example of Descartes, the constant is itself the square of the roots, which can therefore be determined by the constant as well as the coefficients, the constant being no less than the coefficients, simply the function of the roots of the equation. In the usual exposition, the omission of the so-called constants which are linked to the other terms only by the plus and minus signs results from the mechanism of the procedure by which, in order to find the differential of a compound expression, an increment is assigned only to the variables, and the expression thereby formed is subtracted from the original. Nothing is said regarding the meaning of the constants and of their omission, the extent to which they are themselves functions, and, as such, do or do not serve any purpose. In connection with the omission of the constants, a similar comment can be made regarding the names of differentiation and integration as was earlier made regarding the expressions finite and infinite, namely that the term says the opposite of what is intended. 131. To differentiate indicates the positing of differences, whereas by being differentiated an equation is in fact reduced to fewer dimensions. With the omission of the constant, a moment of determinateness is taken away. As we said, 132 the roots of the variables are made equal, their difference therefore sublated. In integration, by contrast, the constant must be added back in again. The equation is thereby integrated. But, note well, only in the sense that the previously sublated differentiation of the roots is restored. What was posited as equal is differentiated again. The ordinary expression contributes to the obfuscation of the essential nature of the matter by directing the focus of attention to what is in fact subordinate, even alien to it. On the one hand, to the infinitely small difference, the increment, and the like. On the other hand, to the mere difference in general between the given and the derived function, without any indication of their specific, that is, qualitative, distinction. Another important area in which differential calculus is employed is mechanics. The meaning of the various power functions that result from the elementary equations of its subject matter, motion, has already been adumbrated in passing. 133. I shall now take it up directly. The equation, that is, the mathematical expression, for plane uniform motion, or, where the spaces traversed are proportional to the elapsed times according to an empirical unit c, which is the magnitude of the 21.291 velocity, offers no scope for differentiation. The coefficient c is already fully determined and known, and no further expansion of powers is admissible. We called attention earlier to how the equation of the motion of a falling body is analyzed. 134. The first term of the analysis is translated into language and accordingly into concrete existence to mean that we must suppose a term of a sum, a conception which we have long since abandoned, a term which is a part of the motion, specifically, that it falls on the side of the force of inertia, that is, of absolutely uniform velocity, with the result that in infinitely small parts of time the motion is uniform, but in the finite parts, that is, in those actually existent, it is uneven, to be sure. And the meaning of A and of T is known, and so, too, that the determination of the uniform velocity of a motion is thereby being posited, since 2 at is simply equal to. But with that, absolutely nothing new is known. Only the false assumption that 2 at is a part of the motion as a sum gives the false semblance of a physical proposition. The factor itself, A, the empirical unit, a quantum as such, is attributed to gravity. If the category of the force of gravity is used, then it ought rather to be said that the whole is the effect of gravity, or, better, the law of it. The same goes for the proposition derived from, that if gravity ceased to act, then the body would attain with the velocity reached at the end of its fall twice the distance it had traversed in the same period of time as the fall. Here too we find an unsound metaphysics. The end of the fall, or the end of a time period in which the body has fallen, is itself still a period of time. If it were not a time period, then rest would be assumed, and therefore no velocity. Velocity can only be calculated according to the distance traversed in a period of time, not at its end. And if now finally an application of differential calculus is made in other physical fields where there is no motion, as for example in the behavior of light, apart from what is called its propagation in space, or in determining magnitudes with reference to colors, and the first function of a quadratic function is here also called a velocity, then this must be regarded in even more inadmissible formalism, a fiction of actual existence. We find the motion represented by the equation. Says Lagrange, 135 in the experience of falling bodies. The next simplest motion would be one of the equation, but 21.292 no such motion is found in nature. We do not know what the coefficient c might mean. Although that might well be so, there is a motion nevertheless of which the equation is. This is Kepler's law of the motion of the bodies of the solar system. And what the meaning here of the first derived function, etc., might be, and the further direct manipulation of this equation by differentiation, the development of the laws and the determinations of the absolute motion from this starting point. All this must on the contrary appear indeed as an interesting problem, an opportunity for analysis to display its worth at its most brilliant. Thus the application of differential calculus to the elementary equations of motion is not by itself of any real interest. The formal interest comes from the general mechanism of calculus. But this dissection of motion takes on another meaning in connection with the determination of its trajectory. If this trajectory is a curve and its equation contains higher powers, then there is need of transitions from the rectilinear functions, which are the functions of power raising, to the powers themselves, and since such functions are to be obtained by eliminating from the original equation of motion the factor of time, which is contained in it, this factor is at the same time to be reduced to the lower functions of expansion from which those linear equations can be obtained. Here we are led to where the interest of the other part of calculus lies. The aim of the foregoing has been to highlight the simple, specific nature of differential calculus by defining it, and to demonstrate it in some elementary examples. Its nature has been found to consist in this, that the coefficient of the term of the expansion, the so-called first function, is obtained from an equation of power functions, and the relation which this first function represents is demonstrated in moments of the concrete subject matter, and these moments are themselves determined by the equation thereby obtained between the two relations. We must equally consider in brief, regarding integral calculus, what can be learned of its specific, concrete nature from the application of its principle. Taking stock of this calculus is already made simpler and more accurate by the fact that we no longer take it as the method of summation from which it got its name in opposition to differential calculus, in which the increment is taken to be the essential ingredient, and which gave to it the semblance of being essentially linked to the form of a series. The task of this calculus is on the face of it just as theoretical, or rather formalistic, as that of differential calculus, although, as is well known, it is the converse of the latter. Here we begin with a function considered as derived, as the coefficient of the first term resulting from the expansion of an equation, as yet however unknown, and the original 21.293 power function is to be derived from it. The function which in the natural order of expansion would have to be considered as original is here derived, and the one previously considered as derived is here the one given, or in general the one to start with. Now the formal details of this operation seem to have already been attended to by differential calculus, where the transition from the original to the expansion function and the relation of the one to the other is established in general. Here, although in order to set up the function which is the starting point, or again, in order to effect the transition from it to the original, recourse must necessarily be made in many cases to the serial form, it is important nevertheless to keep in mind that, as such, this form has nothing directly to do with the proper principle of integration. Now it is in view of the formalism of its operation that the other part of the task of calculus appears as the application of the operation. This is itself now the task, namely to find the meaning, in the above-mentioned sense, of the original function, the one considered as first by the given function, of a particular object. It might seem that this doctrine, too, was in principle already settled in differential calculus, except for a further circumstance that comes into the picture and will not let the matter rest so simply. For by finding out that in this calculus the linear relation is obtained through the first function of the equation, we also know that the integration of this relation yields the equation of the curve in the relation of abscissa and ordinate. Or, if the equation for the area enclosed by the curve were given, then, regarding the meaning of the first function of this equation, we should have already learned from differential calculus that such a function displays the ordinate as a function of the abscissa, and therefore the equation of the curve. But now, all comes down to determining which of the moments of the object is given in the equation itself, for analytical manipulation can only start from what is given and then pass on to the determination of the rest of the object. For instance, what is given in the equation of the curve is not the equation of an area enclosed by that curve, nor of some supposed body arising from its rotation, nor again of an arc of the curve, but only the relation of the abscissa and ordinate. Consequently, the transitions from those determinations to this equation itself cannot yet be handled in differential calculus. It is reserved for integral calculus to find these relations. 21,294. But further, it has been shown that the differentiation of an equation of several variables yields the expansion power or the differential coefficient not as an equation, but only as a ratio. 136. The problem, then, is to find in the moments of the given object a second ratio, which is equal to this ratio, which is the derived function. By contrast, the object of integral calculus is the relation itself of the original function to the derived function, which is here presumed given, and the task is to assign in the object of the first given function the meaning of the original function yet to be found. Or rather, since this meaning, say, the area enclosed by a curve or the rectification of a curve represented as rectilinear, is already declared to be the problem, the task is to show that such a determination is found by an original function, also to show which of the moments of the object is the one that must be assumed for the present purpose as the initial derivative function. Now the usual method makes things easy for itself by representing the difference as one of infinitely small elements. Thus for the squaring of curves, an infinitely small rectangle, a product of the ordinate in the element, that is, the infinitely small segment, of the abscissa, is taken for the trapezium, which has as one of its sides the infinitely small arc opposite that infinitely small segment of the abscissa. The product is then integrated in the sense that the integral is said to give the sum of the infinitely small trapezia or the surface of which the determination is being sought, namely the finite magnitude of this element of the area. In the usual method, a right-angled triangle is likewise formed from the infinitely small elements of an arc and the corresponding ordinate and abscissa, a triangle in which the square of the arc is said to equal the sum of the squaring of both the other two elements, their integration yielding the arc as a finite quantity. This procedure presupposes the general discovery on which this field of analysis rests, in this case inasmuch as the squared curve, or the rectified curve, etc., stands to a certain function given by the equation of the curve in the relation of the so-called original function to the derivative. The point is to know, granted that a certain part of a mathematical object, say, a curve, is the derived function, which other part of the same object is expressed by the corresponding original function. It is known that when the function of the ordinate given by the equation of the curve 21.295 is taken as the derived function, the corresponding original function is the quantitative expression of the area of the curve cut off by this ordinate, that when a certain tangential determination is considered the derivative function, its original function expresses the length of the arc that belongs to this tangential determination, etc. However, that these relations, the one, of an original function to the derived, the other, of the magnitudes of two parts or circumstances of the mathematical object, that these constitute a proportion, the method that employs the infinitely small and operates with it mechanically spares itself the trouble of recognizing and demonstrating it. The true merit of mathematical acumen is that, from results already known elsewhere, It is found that certain sides of a mathematical object stand to each other in the relationship of original and derived function, and it has found which sides these are. Of these two functions, the derivative or, as has been defined, the function of power raising, is the one in this calculus which is the given relative to the original which is to be found from it by integration. This derived function, however, is not immediately given, nor is it by itself already given which part or determination of the mathematical object should be considered as the derived function in order that, by reducing it to the original, the other part or determination whose magnitude is being sought in the problem might be found. For the purpose of this problem, the usual method begins, as we said, 137 simply by representing as infinitely small certain parts of the object, in the form of derived functions determinable by differentiation from the originally given equation of the object in general, like the infinitely small abscissae and ordinates in the rectification of a curve. From these parts it then takes those which can in some way be linked by elementary mathematics with the matter of the problem, likewise represented as infinitely small, in our example, the arc, and by virtue of this connection, once these parts are known, that part is also determined of which the problem was to find the magnitude. Thus, for the rectification of curves, the three mentioned infinitely small parts of the object are linked together in the equation of the right-angled triangle, while for the squaring of curves the ordinate is linked with the infinitely small abscissa to form a product, since in general arithmetic an area is assumed to be the product of lines. The transition from such so-called elements of the area, the arc, etc. to the magnitudes of the area, the arc, etc. as such, passes then only for the ascent from the infinite to the finite expression, or to the sum of the infinitely many elements of which the required magnitude is supposed to consist. 21,296. It is therefore only superficially that one can say that the problem of integral calculus is only the albeit more difficult converse of the problem of differential calculus. The real interest of integral calculus is directed rather exclusively at the reciprocal relation in concrete objects of original and derivative function. Also in this part of calculus, Lagrange did not try just to smooth over the difficulty of the problems at hand with direct assumptions. 138 here, too. It will help to elucidate the nature of the issue if we give the essence of his method with the help of a few examples. The task of this method is still the same, to prove that between particular elements of a mathematical whole, e.g. a curve, a relation of original to derived function obtains. But now, in this field the proof cannot go through directly simply by virtue of the nature of the relation at issue, for the latter connects elements within the mathematical object which are qualitatively different. Curves with straight lines, linear dimensions, and their functions with plane or plane dimensions, and their functions, etc. The required determination can only be taken, therefore, as the mean between a greater and a lesser. With this, of course, the form of an increment with a plus or minus naturally comes into play again, and Lagrange's vigorous developons can be heard again. But we have already pointed out how the increments have here only arithmetical, finite meaning. 139 from the expansion of that condition, that the magnitude to be determined be greater than the one easily determinable limit and smaller than the other, it is then deduced that, e.g. the function of the ordinate, is the derived first function with respect to the function of the area. Lagrange's exposition of the rectification of curves, since it proceeds from the principle of Archimedes, involves the translation of the Archimedean method into the principle of modern analysis, and this affords us an insight into the inner, the true meaning, of an endeavor which in the other method is carried out mechanically. 140 The mode of procedure is necessarily analogous to the one just given. But Archimedes' principle, that the arc of a curve is greater than its chord and smaller than the sum of the two tangents drawn at the endpoints of the arc and contained between these 2 points and the point of their intersection, does not yield any direct equation. Its translation into modern analytical form consists in the invention of an expression which is per se a simple fundamental equation, Whereas in the earlier form, the principle simply postulates alternating ad infinitum between terms, each time 21.297 determined as too great and too small, the successive advance only yielding new terms which are still too great and too small, albeit between always narrowing limits. On the basis of this formalism of the infinitely small, the equation is formulated without further ado. Lagrange's exposition, on the contrary, starting from this same basis, demonstrates that the length of the arc is the original function with respect to a derived function, the characteristic term of which is itself a function coming from the relation of a derived function to the original function of the ordinate. The fact that the representation of the infinitely small occurs in the method of Archimedes, just as later in Kepler's treatment of stereometric objects. 141 has been adduced as authority for the employment of the infinitely small in differential calculus, without any thought being given to its distinctive particularities. The infinitely small signifies in the first instance the negation of the quantum as such, that is, of the so-called finite expression, of the completed determinateness that quantum as such possesses. Similarly, in the subsequent renowned methods of Valerius 142 and Cavalieri 143 among others, methods which are based on the treatment of the relations of geometrical objects, the fundamental principle is that the quantum of the terms treated at the moment only in relation must, as such, be left out of account for this purpose, and the terms themselves be taken as non-quantitative. But, for one thing, these methods all fail to recognize and to bring to notice the affirmation that hides behind the merely negative determination. This is the affirmation which we saw earlier 144 in abstract form as the qualitative determinateness of quantity and, in more determined form, as the qualitative determinateness found in the relation of powers. And also, since this same relation of powers contains in turn an aggregate of more precisely determined relations such as that of a power and its expansion function, these relations also would have in turn to be based on, and derived from, the general and negative determination of still the same infinitesimal. Now, in Lagrange's exposition just cited, the determinate moment of affirmation implicit in Archimedes' method of developing the problem is made explicit, with the result that a procedure otherwise affected by a limitless progression is given its due limit. The greatness of the modern discovery in itself, and in its capacity to solve hitherto intractable problems, and to handle in simpler fashion those previously soluble, is to be laid solely in the discovery of the relation of the original to the so-called derivative functions and of those parts of a mathematical whole which stand in such a relation. These excursions may suffice for the purpose of 21.298 highlighting what is distinctive about the relation of magnitudes, which is the subject matter of the particular kind of calculus under discussion. It was possible to limit them to simple problems and the methods of solving them. Nor would it have been expedient for the conceptual work which was our only concern here, or within this author's competency, to go over the whole compass of the so-called application of differential and integral calculus, to reduce all their problems and their solutions to the principle on which, as we have inductively shown, that application rests, and thereby to complete this inductive work itself. But what was said has sufficiently demonstrated that just as for each specific form of calculating there corresponds as subject matter a corresponding particular determinateness or relation of magnitude, such a relation as constitutes addition, multiplication, the raising to powers and the extraction of roots, the operations with logarithms, series, etc. The same is the case for differential and integral calculus. For the object specific to the latter, the most suitable name might be that of the relation between a function of powers and the function of its expansion or potentiation, because it is the closest to what an insight into the nature of the subject matter suggests. Of course, calculus makes use quite in general of logarithms, of circular functions and series, especially in order to render more tractable expressions devised for the required operations of deriving the original functions from the functions of expansion, but it uses them in the same way as it uses the operations involved in the other relations of magnitude, such as addition, etc. Calculus, whether differential or integral, has indeed a more specialized interest in common with the form of series, namely that of determining the functions of expansion, which in the series are called coefficients of the terms. But whereas the interest of calculus only extends to the relation of the original function to the closest coefficient of its expansion, the aim of the series is to display as a sum aggregates of terms ordered according to the powers fitted with those coefficients. The infinite of the infinite series, the indeterminate expression of the negativity of the quantum in general, has nothing in common with the affirmative determination present in the infinite of calculus. The same is the case for the infinitesimal, the increment by means of which the expansion happens in the form of a series. It is only an external means for that expansion, and its so-called infinity either has only the meaning of such a means or has none at all. The series, since in fact it is not what is being sought, brings with it a de trop which then creates the otherwise superfluous trouble of eliminating it. The method of Lagrange has again privileged this form of series, and is therefore burdened by that trouble, even though it is by virtue of 21.299 that method that the true character of what is called the application is brought out in the latter, for it directly demonstrates, without imposing the forms of dx, dy, etc., unto the objects, to which part of these objects the determinateness of the derived function of expansion, belongs. And it transpires thereby that the form of series is not what is truly at issue here. N. Remark 3. Further forms associated with the qualitative determinateness of magnitude. The affirmative meaning of the infinitesimal of differential calculus is that it is the qualitative determinateness of magnitude, and, regarding this determinateness, we have shown in particular that at 21.300 is present in this calculus not only as a power determinateness in general, but as specifically determining the relation of a function of powers to the power of the expansion. This qualitative determinateness is also present, however, in another weaker form, so to speak, and this form, together with the use of the infinitesimal associated with it, and the meaning that the latter has in this use, will be the subject of the present remark. Before we proceed, however, it should be recalled at this juncture that the different power determinations first come in from the analytical side, that they are there merely formal and totally homogeneous, that they signify numerical magnitudes which, as such, are not qualitatively differentiated from each other. It is in the application to spatial objects that the analytical relation fully shows itself in its qualitative determinateness as the transition from linear to plane determinations, from the determinations of straight line to those of curves, etc. This application also brings in train that the spatial objects which are given in the form of continuous magnitudes in accordance with their nature will be taken discretely, the plane as an aggregate of lines, the line as an aggregate of points, etc. The sole interest of this dissolution is to determine the points and the lines into which the lines and the planes have respectively been resolved in order to be able, starting from this determination, to proceed analytically, that is, in truly arithmetical fashion. For the sought magnitude determinations, these starting points are the elements from which the function and the equation for the concrete, that is, the continuous, magnitude are to be derived. For the problems where the use of this procedure is of special interest, it is requisite that the element which is the starting point be self-determined, in contrast with the indirect procedure which can start only with limits and seek between them the self-determined element, which is its goal. But if it is only the law of progressively determining magnitudes without, however, ever possibly attaining the required perfect, that is, the so-called finite, determination, then in both methods the result amounts to the same thing. To Kepler is ascribed the honor of first having thought of that reversal of procedure and of having made the discrete the starting point. His explanation of how he understands the first proposition of Archimedes' cyclometry conveys this quite simply. 147. This proposition, as we know, is that the circle is equal to a right-angled triangle, one side of which enclosing the right angle equals the diameter of the circle and the other its circumference. Since Kepler takes this proposition to mean that the periphery of the circle has as many parts as it has points, that is, infinitely many, each of which can be regarded as the base of an isosceles triangle, he thereby gives expression to the resolution of the continuous into the form of the discrete. The expression infinite, which occurs here, is still far removed from the 21.301 meaning which it is supposed to assume in differential calculus. Now, when a determinateness, a function, has been found for such discrete elements, these should be summed up further as essentially elements of the continuous. But since a sum of points will not yield a line, nor a sum of lines a surface, the points are straightaway taken as already linear, just as the lines are taken as two-dimensional. But again, since linear elements ought not to be lines yet, which they would be if they were taken as quantum, they are represented as infinitely small. The discrete is only capable of an external combination in which the moments retain the meaning of discrete units. The only transition analytically made from these units is to their sum, nor is there a geometrical transition from point to line, or from line to surface, etc. Therefore, the element which is determined as a point or a line is also given, together also with this determination, the quality of being as point linear or as line two-dimensional, in order that their sum would indeed become, as the sum of tiny lines, a line, and, as the sum of tiny planes, a plane. It is the need to get hold of this moment of qualitative transition, and for this reason to have recourse to the infinitely small that must be regarded as the source of all the representations which, though meant to smooth out every difficulty, are themselves the greatest difficulty. But to dispense with these aids, it would have had to be possible to show that contained even in the analytical procedure, which otherwise appears as a mere summation, there is in fact already a multiplication. But a fresh assumption is trotted out at this juncture, which provides the basis for this application of arithmetical relations to geometrical figures. The assumption is that arithmetical multiplication is also for the geometrical determination a transition to a higher dimension, that the arithmetical multiplication of magnitudes spatially determined as lines is at the same time a promotion of the linear to the status of two-dimensional determination. 3 times 4 linear feet gives 12 linear feet, but 3 linear feet times 4 linear feet gives 12 plane feet, that is, square feet, since the unit in both factors, as discrete quanta, is the same. The multiplication of lines by lines appears at first sight to make no sense, for multiplication has to do simply with numbers, that is, it is an alteration of elements totally homogeneous with that into which they are altered. With the product, only the quantity alters. In contrast to this alteration, what has been called the multiplication of a line as such by a line, it has been named ductus lineae in lineam, like the ductus plani in planum. There is also the ductus puncti in lineum, is an alteration not merely of magnitude, but of magnitude as a qualitative determination of 21.302 spatiality, of dimensionality. The transition of the line into plane is to be understood as the self-externalization of the line, just as the self-externalization of the point is a line and the self-externalization of the plane a whole space. This is the same as representing the motion of the point as being the line, and so on. But since motion entails time determination, it is more likely to appear in this way of representing it as merely accidental, an external alteration of state, whereas what is to be captured is the conceptual determination as expressed by self-externalization, that is, the qualitative alteration which, arithmetically, is the multiplication of unit, the point, etc., by amount, the line, etc. It may also be remarked here that in the case of the self-externalization of the plane, which would appear as a multiplying of surface by surface, there seems to emerge a difference of arithmetical and geometrical products, for that self-externalization, as ductus plani in planum, would arithmetically give a multiplication of a two-dimensional factor by another factor equally two-dimensional, and hence a product of 4 dimensions which, however, is reduced to 3 in geometrical. Determination. For its part, since number has the 1 as its principle, it yields the fixed determination for the external, quantitative element. But the product of its operation is to that extent formal. Taken as a numerical determination, when it reproduces itself, yields. However, the same magnitude, taken as the determination of a plane, in reproducing itself is held back at, because space, imagined as a movement of transcendence which starts from the point, the limit which is only abstract, attains its true limit as concrete determinateness in the third dimension, starting from the line. The difference just referred to could prove relevant in the context of free motion, where the one side, the spatial, is subject to geometrical determination, according to Kepler's law, and the other side, the temporal, to arithmetical determination. How the qualitative moment being considered here differs from the subject of the previous remark should now be self-evident without further comment. In the earlier remark, the qualitative moment lay in the determinateness of the powers. Here it is the same as the infinitesimal, except only as a factor arithmetically related to product, or as point to line to plane, etc. The qualitative transition to be made from the discrete, into which the continuous magnitude is imagined to be resolved, to the continuous is now effected as a process of summing. But that in fact the alleged mere summation contains in itself a multiplication. Therefore the transition from the linear to the two-dimensional determination appears in the simplest form in the way in which, for instance, it is shown that the area of a trapezium is equal to the product of the sum of the two opposite 21.303 parallel lines and half the height. This height is represented as being only the amount of an aggregate of discrete magnitudes which must be summed up. These magnitudes are lines lying parallel between the two parallels limiting them. There are infinitely many of them, for they are supposed to make up the plane. And yet they are lines, and therefore, in order to be two-dimensional, they must at the same time be posited with negation. In order to escape the difficulty of a sum of lines supposedly yielding a plane, the lines are assumed as planes from the start, but also as infinitely thin, for they derive their determination solely from the linear character of the parallel limits of the trapezium. As parallel and bounded by the other pair of rectilinear sides of the trapezium, they can be represented as the terms of a uniformly differentiated but in principle indeterminate arithmetical progression whose first and last terms are the two limiting parallels. The sum of such a series, as we know, is the product of these parallels and half the amount of the terms. This last quantum is called amount simply and solely with reference to the representation of infinitely many lines. It is the determinateness as the magnitude in general of a continuous, the height. It is clear that what is called a sum is at the same time a ductus lineae in lineum, the multiplying of the linear by the linear which is, according to the above determination, 148 the emergence of two-dimensionality. In the simplest case now of any rectangle in general, AB, each of the two factors is a simple magnitude, but already in the other still elementary example of the trapezium, only one factor is simple as 1/2 of the height. The other factor is determined by a progression. It is still something linear, but its determinateness as magnitude is more complex. Insofar as it can be expressed by a series, the task of summing it is called analytical, that is, arithmetical, but the geometrical moment in it is the multiplication, and this is the qualitative moment of transition from the dimension of line to that of plane. The one factor has been taken as discrete only for the arithmetical determination of the other. By itself, like the other, it is the magnitude of something linear. But the method of representing planes as sums of lines is also commonly employed where no multiplication as such is being performed in view of the result. This is the case when the task is to give the magnitude in the equation not as quantum but as a proportion. There is, for instance, a well-known way of showing that the area of a circle bears the same relation to the area of an ellipse, the major axis of which is the diameter of the circle, as the major axis does to the minor axis, by taking each of these areas as the sum of the ordinates pertaining to it. Each ordinate of the ellipse stands to the corresponding ordinate of the circle as the minor axis stands to the major. Therefore, 21.304 it is concluded, also the sums of the ordinates, that is, the areas, stand in equal proportion. Those who would avoid in this connection the representation of areas or planes as a sum of lines resort to the usual, quite superfluous ad hoc aid of making the ordinates into trapezia of infinitely small width. Since the equation is only a proportion, only one of the two linear elements of the area enters the comparison. The other element, the abscissa axis, is assumed equal in the ellipse and the circle. Therefore, as a factor of arithmetical magnitude determination, equal to 1, and the proportion is, consequently, totally dependent only on the relation of the one determining moment. The two dimensions are necessary to the representation of a plane. The determination of magnitude, however, as is to be given in this proportion, extends only to the one moment. Therefore, to yield to the representation, or to try to improve it by adding the representation of some to this one moment, is in truth a failure to recognize what mathematical determinateness is all about. The foregoing discussion contains also the criterion for Cavallari's method of indivisibles referred to above 149, a method which the criterion also justifies and one that does not need the recourse to the infinitely small. These indivisibles are lines when Cavalieri considers a plane, or squares and circles when he considers a pyramid or a cone, etc. He calls the base line or base plane assumed as determined the regula. It is the constant and, with reference to a series, its first or last term. The indivisibles are regarded as parallel to it, therefore in equal determination with respect to the figure. Now Cavallari's general fundamental proposition is that, exerc. Geometry. 6. In the later work, exerc. I, page 6. All figures, plane as well as solid, are proportionate to all their indivisibles, these being compared with each other collectively, and, if there happens to be in them some common proportion, distributively. 150 for this purpose, he compares in figures of equal base line and height the proportions between the lines drawn parallel to the base and equidistant from it. All such lines of a figure have one and the same determination and constitute its whole content. In this way, Cavallari proves, for example, also the elementary proposition that parallelograms of equal height are proportional to their base. Any two lines drawn in the two figures at equal distance from the base and parallel to it are in the same proportion as the bases, and so too, therefore, are the whole figures. In fact, the lines do not constitute the content of the figure as 21.305 continuous, but constitute it only in so far as they are arithmetically determinable. The linear figure is the element of the content, and through it alone must the determinateness of the latter be grasped. With this we are led to reflect on a difference regarding where to place the determinateness of a figure, whether it is constructed, like the height of the figure here, or whether it is the external limit. In so far as it is an external limit, then one concedes that the continuity of the figure follows upon, so to speak, the equality or the proportion of the limit. E.g., the equality of congruent figures rests on the fact that the boundaries, the limiting lines, coincide. But in parallelograms of equal height and base, only this last determinateness is an external limit, the height on which the second main determination of the figures rests, the proportion of the two, and not the parallelism as such, brings a second principle of determination to the external limits. Euclid's proof of the equality of parallelograms that have the same height and base reduces them to triangles, to externally limited continuous figures. In Cavallari's proof, first of all concerning the proportionality of parallelograms, the limit is simply a determinateness of magnitude as such, which is explicated as taken at every pair of lines drawn at the same distance from each other in both figures. These lines, equal or in equal proportion to the base, taken collectively, yield the figures that stand in equal proportion. The image of an aggregate of lines is incompatible with the continuity of the figure, consideration of the lines alone fully exhausts the determinateness which is at issue. Cavalieri has a standard reply to the supposed difficulty that the representation of indivisibles requires the comparison of lines or planes which are infinite in number. Geometrical, Lib 2, Prop. I. Scholl. 151. He rightly points out that he is not comparing the number of such lines or planes, which we do not know. That is, it is rather an empty representation, as just remarked, 152 introduced as prop, but only the magnitude, that is, the quantitative determinateness as such which is equal to the space occupied by these lines. Because this space is enclosed within limits, its magnitude is also enclosed within these limits. The continuous is nothing other than the indivisibles themselves, he says. If it were anything apart from them, it would not be comparable, but it would be absurd to say that bounded continuous figures are not comparable with each other. One can see that Cavalieri's intention is to distinguish what belongs to the external existence of the continuous from that in which its determinateness lies, and which 21.306 alone must be stressed when comparing it or devising theorems about it. The categories which he used for this purpose, namely the continuous as composed of or consisting in indivisibles, and the like, are admittedly not satisfactory, for implied in them is the claim to an intuition of the continuous or, as already said, of its external existence, instead of saying that the continuous is nothing other than the indivisibles themselves. 153. It would have been more correct to say, and consequently also self-explanatory, that the determinateness of the magnitude of the continuous is none other than that of the indivisibles themselves. Cavalieri is not comfortable with the dubious consequence drawn by the schools from the representation of the continuous as made up of indivisibles, namely that there is a greater and smaller infinite. He expressly states further in the treatise Geometry, Lib 7, Pref. 154 that he is in no way forced by his method of proof to represent the continuous as made up of indivisibles. Continuous figures only follow the proportion of the indivisibles. He says that he did not take up the aggregate of indivisibles in the way they seem to end up in the determination of the infinite, for the sake of an infinite heap of lines or planes. He took them rather because of the way they are constituted, for the specific nature of limitedness that they have in them. Nevertheless, in order to remove this stumbling block, he does not spare himself the trouble of demonstrating the main propositions of his geometry, in the 7th book specially added for this purpose, in a way that remains free of any admixture of infinity. This way reduces the proofs to the just cited usual form of congruence of figures, that is, as we remarked, to the representation of determinateness as external spatial limit. 155. A further remark that can be made here concerning this form of congruence is that it is no more than, so to speak, a childish aid for the intuition of the senses. In the elementary propositions concerning the triangles, two such triangles are represented side by side, on the assumption that, of the 6 parts of each, 3 in the one triangle are equal to the corresponding 3 in the other. It is shown that the two triangles are congruent, that is, that in each the remaining 3 parts are equal to the corresponding remaining 3 in the other, because by virtue of the equality of the first 3 parts the two triangles cover each other. In more abstract terms, all that this equality of corresponding pairs of parts in the two triangles amounts to is that there is just one single triangle in which 3 parts are assumed as already determined, whence follows the determinateness of the remaining 3 parts. The determinateness of the one triangle is thus demonstrated to be completed with the 3 parts assumed. For the 21.307 determinateness, as such the remaining 3 parts are therefore a superfluity. The superfluity of sensible existence, that is, of the intuition of continuity. When the matter is expressed in these terms, the qualitative determinateness stands out in its distinction from what is given to intuition, from the whole as continuous in itself. Congruity does not let this distinction show through. As we have observed, 156. A new circumstance comes into play in the case of parallel lines and parallelograms. On the one hand, the equality of the angles only, and on the other, the height of the figures from which the external limits of the latter, the sides of the parallelograms, are distinct. There is an ambiguity here as to whether in these figures, besides the determinateness of the side, which is one external limit, the base, we should take as the other external limit the other side of the parallelogram or the height instead. In the case of two parallelograms that have the same base and height, but one is rectangular whereas the other has two angles sharply acute, and the opposite two very obtuse accordingly. Intuitively, the latter figure can easily appear greater than the former, for intuitively its given longer side is taken to be the determinate one, and, as in Cavalieri's figurative method, the planes are compared according to the aggregate of parallel lines intersecting them. The longer side could be seen as offering the possibility of more lines than the vertical side of the rectangle does. This intuitive ambiguity, however, is no argument against Cavalieri's method, for the aggregate of parallel lines imagined in the two parallelograms for the purpose of comparison equally presupposes the equidistance of the lines from each other or from the base, from which it follows that the height, and not the other side of the parallelogram, is the other determining moment. The situation changes again, however, when the two parallelograms being compared are of equal height and equal base, but do not lie on one plane and make different angles with a third plane. Here the parallel cross-sections that arise when the third plane is imagined cutting across the parallelograms in parallel motions are no longer equidistant from each other, and the two planes are unequal. Cavalieri is very careful to call attention to this difference, which he defines as one between transitus rectus and transitus obliquus of the indivisibles, in exercit I, N, XIFF, and already in geometry. 1.2, 157. Thus staying at the source any superficial misunderstanding which could arise at this juncture. I remember Barrow citing in his above-mentioned work, Lect. Geometry, 2, page 21, 158 an objection of Taquet 159, an astute geometer who was also working at this time on new methods, bearing on precisely this subject. This Barrow is the one who also used the 21.308 method of the indivisibles, though already adulterated by the assumption, which he passed on to his pupil Newton and to other contemporary mathematicians, Leibniz included, that a curvilinear triangle, like the so-called characteristic triangle, and a rectilinear triangle, can be said to be equal if both are infinite, that is, very small. The difficulty raised by Taquet likewise concerns the question of which line, in the calculation of conic and spherical surfaces, should be taken as the determining factor in a method based on the application of the discrete. Taquet's objection to the method of the indivisibles is that in the calculation of conic and spheric surfaces, the triangle of the cone is represented according to this atomistic method as made up of straight lines, parallel to the base and perpendicular to the axis, which are at the same time the radii of the circles of which the surface of the cone consists. If now this surface is defined as the sum of the circumferences, and this sum is determined from the number of the radii of these circumferences, that is, from the length of the axis and the height of the cone, then such a result would contradict the truth which Archimedes has taught and demonstrated. To this objection of Taquet, Barrow's response is that, for determining the surface, it is not the axis but the side of the triangle of the cone that must be taken as the line the revolution of which generates the surface, and this line, not the axis, must therefore be taken as determining the magnitude for the aggregate of the circumferences. Objections or uncertainties of this kind have their origin solely in the vagueness of the representation used for the infinite aggregate of points of which the line, or of lines of which the plane, etc., supposedly consists. It is this representation which obscures the essence of the determinateness, whether of the lines or the planes. It was the aim of these remarks to bring attention to the affirmative determinations of the category of the infinitesimal which, in the various uses made of this category in mathematics, remain in the background, so to speak, and to extract them from the nebulosity in which they are shrouded when that category is kept at a merely negative level of determination. In infinite series, as in Archimedes' cyclometry, the infinite means no more than that. If the law of the progression of the series is known, but the so-called finite, that is, the arithmetical expression, is not given, the reduction of the arc to the straight line cannot be carried out. This incommensurability is their qualitative difference. Likewise, the qualitative difference between the discrete and 21.309 the continuous contains in general a negative determination which makes them appear incommensurable. It thus introduces the infinite, in the sense that the continuous which is now to be taken as discrete no longer is supposed to have, as continuous, any quantum. The continuous, which arithmetically is to be taken as product, is thereby posited as discrete in itself, that is to say, is broken down into the elements which are its factors. Its magnitude determinateness lies in these factors, and they, precisely by virtue of being factors or elements, are of a lower dimension and, as the determinateness of power goes, of a lower power than the magnitude of which they are the elements or factors. This difference appears arithmetically as merely quantitative, a difference of the root or the power, of whatever degree they might be. However, if the expression does not go further than just the quantitative sphere as such, for example, a2 or for the law of gravity, t, at 2, it then yields the ratios 1, a2, a1, at, which say nothing whatsoever. As against their merely quantitative determination, the sides would have to be held apart by the qualitative meaning differentiating them, as s, at 2, the magnitude being thereby spoken of as a quality, as a function of the magnitude of another quality. Here then, we are only conscious of the quantitative determinateness, and it is easy enough, in its own way, to operate with it. Nor is there anything terrible in multiplying the magnitude of a line by the magnitude of another line. However, the multiplication of these magnitudes yields at the same time the qualitative alteration of the transition of line into plane, and to this extent a negative determination comes into play. It is this determination that occasions the difficulty, a difficulty which can be resolved by an insight into its peculiarity and the simple nature of the matter, but which, when the attempt is made to eliminate it by the aid of the infinite, only degenerates unresolved into confusion. J. in the remark to the thesis of the first cosmological antinomy, in the Critique of Pure Reason. K. Both views are found simply side by side in the application by Lagrange of the theory of the function to mechanics in the chapter on rectilinear motion, Theory defunct. 3rd Pch. I. Art 4. 102. The traversed space, considered as the function of the elapsed time, gives the equation. This equation, expanded as, gives. Therefore, the space traversed in the elapsed time is represented in the formula. The motion by means of which the space is traversed is, it is said, therefore, because the analytical development yields several, in fact infinitely many terms, composed of various partial motions, of which the spaces corresponding to the time will be. The first partial motion is, in known motion, the formally uniform motion with a velocity determined by. The second, the uniformly accelerated velocity derived from an accelerated force which is proportional to. Now, since the remaining terms do not refer to any known simple motion, it is not necessary to take them particularly into consideration, and we shall show that it is possible to abstract from them in determining the motion at the beginning of the point in time. This is now shown, but, of course, only by equating the series whose terms were all part of the determination of the magnitude of the space traversed in that time with the equation, given in Art. 3, of the motion of a falling body, in which only these two terms are present. But this equation has itself received the form that it has by presupposing the explanation given for the resulting terms by means of analysis. This presupposition is that the uniformly accelerating motion is composed of a formally uniform motion continued with the velocity attained in the preceding period of time, and of an increment, via n, i.e. the empirical coefficient, which is ascribed to the force of gravity, a distinction which has absolutely no concrete existence or foundation in the nature of the matter itself, but is only the expression, in false physical form, of the results of the assumed analytical treatment. The category of continuous or fluent magnitude comes in with the consideration of the external and empirical variation of the magnitudes which, in an equation, are referred to each other as each the function of the other. But in science, where the object of differential calculus is a certain relation, usually expressed by the differential coefficient, and its determinateness may just as well be called a law, the mere continuity of magnitude is something alien to this specific determinateness, and in any case an abstract and here empty category, for it says absolutely nothing concerning the law of continuity. The extreme of formalism into which one can be misled in these matters can be seen from the penetrating general exposition by my respected colleague, Prof. Dirksen, of the fundamental determinations used in the deduction of differential calculus. This exposition is appended to his critique of a number of works concerning this science and can be found in Jarb. F. Wissensch, Critic, 1827, NR 153 ff. The following definition is cited on page 1251. A continuous magnitude, a continuum, is any magnitude thought of as in the state of becoming, so that this becoming occurs not by leaps, but by an uninterrupted progression. 111. But this is surely a tautology, the same as the definitum. It pertains to the formalism of the universality to which analysis necessarily lays claim that instead of taking A plus B, N for the expansion of powers, A plus B plus C plus D. N is the expression used, as is also done in many other places. Such a form is to be regarded as, so to speak, a coquettish show of universality, for the matter itself is exhausted in the binomial. It is through the expansion of the binomial that the law is found, and the law is the true universality, not the external, merely empty repetition of it, which is all that A plus B plus C plus D produces. And in the already cited critique, Jarb, for Wissensch, Crit. 2, Volume 1827, NR 155, 6 ff. 145 are to be found interesting opinions of a learned specialist in the subject, her spare. 146 they are quoted from his Neue Prinzipien des Fluentenkels, Braunschweig, 1826, and concern a matter which has contributed substantially to the issue of obscurities and unscientific claims in differential calculus. Moreover, they accord with what we have said concerning the general orientation of the theory of this calculus. To quote, purely arithmetical investigations, admittedly those which more than all other have direct bearing on differential calculus, have not been separated from this calculus proper. Indeed, they have even been taken, as by Lagrange, for what is of the essence of the calculus, while calculus itself has been regarded as only the application of them. These arithmetical investigations include the rules of differentiation, the derivation of Taylor's theorems, and so on, even the various methods of integration. But the case is quite the reverse, for it is these applications that make up the subject matter of differential calculus proper, which presupposes all those arithmetical developments and operations from analysis. We have shown how, with Lagrange, the separation of the so-called application from the procedure of the general part, which takes its start from the series, serves precisely to bring to light the proper subject of differential calculus. However, it is strange that the author, despite entertaining the interesting view that it is precisely the so-called applications that constitute the subject matter of differential calculus proper, would then himself divagate, ibid, into the formalistic metaphysics of continuous magnitudes, becoming, flow, etc., and would want to add new ballast to old. These determinations are formal, in the sense that they are only general categories which fail to give precisely that which is specific to the subject matter. But this is what was to be recognized in, and be abstracted from, the concrete propositions, the applications. Amount, or the how many times, equals Ansel. Die Einheit. Puncticitat. Cf. above, 21,194. Cf. 11.265 ff. For the following, see B15, 16. B16. See Euclid, Elements, Book 1, Definition 4. Hegel refers to a German translation of 1798. CGW 21406 for details. Cf. above, 21,198. In being differentiated as amount and unit, the concept of number goes out of itself, according to the typically Hegelian image. These two determinations of amount and unity had to be shown to be equal to each other, and, therefore, each had to constitute the whole of number, before the concept could assume control, so to speak, of its own determinateness and thus return into itself. So far as the concept in general is concerned, in the determinations of amount and unit, this movement of externalization and return has been accomplished only in principle in the development of the particular concept of number. Cf. below, 21.310 ff. Cf. Aristotle, Metaphysics 965b, 1978b. Hegel has very likely Schelling in mind, but Bardili also, and Reinhold, when a disciple of Bardili, used pseudo-algebraic formulas to express their logical realism. 987b, in fact in Chapter 6. Moderatus of Gades, modern Cadiz, was a Neo-Pythagorean active in the 1st century AD. For the Life of Pythagoras by Malchus, CGW 21425. CGW 21425. Cf. above, 21,204. Beziehung. Mehrheit, literally, majority. In the preceding remark, Mehrern. Here and in what follows, Hegel is playing on the root meaning of the German word for several, mehrere, which is more. This wordplay is lost in English. I am using circumlocutions in an attempt to retain it as much as possible. Cf. F. W. J. Schelling. Ideen zu einer Philosophie der Natur, Leipzig, 1797, 2nd ed. English trans. Ideas for a Philosophy of Nature, trans. E. H. Harrison Peter Heath. Cambridge, Cambridge University Press, 1988. Book 2, Chapter 5, page 185. Matter occupies a space, not through its mere existence. For to assume this is to cut off all further inquiry, once and for all, but through an inherent moving force, whereby the mechanical motion of matter first becomes possible. Schelling is developing an idea of Kant. Cf. Kant, 1786, AK 4496. For Schelling's critique of M. Lusage's mechanical physics, c. Ideen, 1797. English trans. Pages 161 ff. Cf. 11.354 to 359. B414. Geyer/Wood translation, with some modifications. Hegel adds the stresses and also drops some parenthetical clauses. Sit Schicken. Cf. 21.218 to 219. AK 5162. A paraphrase more than a citation. The critical editors say that this second part of the quote cannot be located with any precision in Kant. A 613/B641. Cf. also Kant, 1794, AK 8327. Albrecht, Baron von Haller, 1708 to 1777, Swiss physiologist and poet, Imperfect Poem on Eternity, 1736. See Haller's Gedicht, Edition Ludwig Herzl, Bibliothek Alterer Schriftwerk der Deutschen Schweiz, 1882, Volume 3, page 151. The English translation is by Arnulf Zweig. The stress in the last line is added by Hegel. The citation is very likely a conflation of several texts, but cf. Critique of Practical Reason, AK 5161. Cf. AK 5162. Hegel has both Kant and Fichte in mind. For the following, cf. Fichte, The Science of Knowledge, 1794, Section 1, pages 95 ff, 104 ff, 108 ff, GAI.2.258 ff, 266 ff, 270 to 272. Notas. Fichte, The Science of Knowledge, 1794, Section 1, pages 159 ff, GAI.2.355 ff. Fichte, The Science of Knowledge, 1794, Section 1, pages 194 to 195, GAI.2.361. The reference is to Schelling. Cf. Schelling, Darstellung means. Systems der Philosophie, 1801, 1859. See Section 23, Schelling's Werke, edition Manfred Schroeder, München, 1927, Volume 3, page 19. Between the subject and the object there is no other difference possible than a quantitative one. That now, since it is the same absolute identity which is posited as subject and object, there is no qualitative difference. Cf. below, 21,235. Cf. above, 21,180. For the following, cf. A416/B454 ff. Hegel often paraphrases rather than cites Kant's text. Geyer/Wood translation, with slight modifications. Stresses added by Hegel. Geyer/Wood translation, with slight modification. Hegel skips one clause of Kant's text. Kant's text is much abbreviated. Hegel is referring to the belief, common at the time, that calculus was based on approximations, and that infinitesimal differences could ultimately be dropped without any significant error in the results because of their minuteness. Geyer/Wood, A430/B458, A432, 460. The text is slightly modified by Hegel. Geyer/Wood, A432/B460. Stresses added by Hegel. Cf. above, 21,237. Cf. above, 21.234. Also GW11, 153. Cf. above, 21,242. Ethics. Part 1 Prop. 8. Notai. Cf. Letter 6, Gebhard's 12, to Louis Meyer, in which Spinoza first distinguishes between types of infinites, and then proceeds to illustrate them with examples. English trans. Pages 317 to 318. Spinoza, Letter 6, Gebhard's 12, to Louis Meyer, English trans. Pages 321 to 322. Cf. above, 21,240. Cf. below, 21.299 to 301. Cf. above, 21,237. Cf. above, 21.90 ff. In the preceding page. C. Newton, Philosophiae Naturalis Principia Mathematica, Book 1, Section 1, Lemma 11, Scholium. In this reference, there is no mention of flux science, but Newton does make the claim that Hegel refers to, i.e., that he is working not with indivisibles, but with vanishing divisibles. They not sums and ratios of determined parts, but the limits of sums and ratios, is taken almost word for word from this scholium. Francesco Bonaventura Cavalieri, 1598 to 1647, Jesuit and professor of mathematics at the University of Bologna. Among his many works, the Geometria Indivisibilium Continuorum Nova Quadam Ration Pro Moda, 1635, anticipates basic ideas of integral calculus. Cf. above, 21.234 to 236. Lazare Carnot, 1753 to 1823, French engineer, mathematician, military man, and politician who pioneered the development of calculus. His Reflections sur la métaphysique du calcul infinitesimal was published in 1797. The place very likely alluded to by Hegel is section 43. See Newton, Principia Mathematica, Book 2, Section 2, Lemma 2. Hegel is not citing, but simply reporting what Newton says. See Note 88. Christian Wolff, Elementa Mathesios Universi, 1742, in Gesammeltwerke, Zweit Abteilung, Volume 29, edited by J. E. Hoffman, Hildesheim, George Olms, 1968, pages 545-6. English trans. A treatise of algebra, with an application of it to a variety of problems in arithmetic, to trigonometry, and conic sections. 3 preliminary treatises, trans. From the Latin by John Hanna, London, 1739. Cf. above, 21,238. Leonhard Euler, 1707-1783, Swiss mathematician who contributed to calculus and topology and was responsible for much of modern mathematical terminology and notation. Joseph Louis Lagrange, Giuseppe Lodovico Lagrangia, 1736-1812, Italian mathematician and astronomer who succeeded Euler at Berlin and was then professor at the École Polytechnique in Paris. He made important contributions to analysis and number theory. Lagrange. See Joseph Louis Lagrange, Théorie des fonctions analytiques, Contenant les principes du calcul différentiel, de gauges de tout considération d'infiniment petit, d'évanescence, de limites et de fluxions, et réduits à l'analyse algébrique de quantités finies. 3rd ed. Paris, 1847, page 6. John Landon, 1719-1790, English mathematician. C.F. Lagrange. Théorie des fonctions analytiques, page 4. Cf. below, 21.287-288. Pierre de Fermat, 1601-1665, French lawyer and mathematician. Isaac Barrow, 1630-1677, English classical scholar, theologian, and mathematician. He was the teacher of Isaac Newton. According to the critical editors, Hegel derives his information from Carnot's Reflections sur la métaphysique du calcul infinitésimal, 1797. Cf. below, 21.273-299. See Newton, Principia Mathematica, Book 2, Section 2, Lemma 2. See Joseph Louis Lagrange. Trait de la résolution de équations numériques de tous les degrés, avec de notes sur plusieurs points de la théorie de équations algébriques. 3rd ed. Paris, 1826, Note 5, Section 1. Lagrange, Théorie des fonctions analytiques, Part 3, Chapter 4. 102 C. Lagrange, Théorie des fonctions analytiques, Part 3, Chapter 1. Section 4. C. Lazare Carnot. Reflections sur la métaphysique du calcul infinitésimal, Paris, 1797, Sections 9ff. C. Carnot, Reflections, Sections 30f. C. Lagrange, Théorie des fonctions analytiques, Part 1, Chapter 1, Section 6. Cf. above, 21,262. Cf. above, 21,253. Qualitative Bestimmtheit de Quantitativen. Verhaltensmoment. Cf. below, 21.268-269. 111 Enno Heeren Dirksen, 1788-1851, Professor of Mathematics at Berlin, Jahrbucher für Wissenschaftliche Kritik, 153-160, 1827, column 1251. 112 Cf. above, 21,253. Cf. above, 21.262-263, footnote. Hegel's reference to Newton is from Principia Mathematica, Book 1, Section 2, Proposition 1. His second reference is to Friedrich Theodor Schubert, 1758-1825, Theoretische Astronomie, Volume 3, Physische Astronomie, St. Petersburg, 1798. 115 Cf. above, 21,196. 116 cf below, 21.318 ff. 117 cf above, 21.260 to 268. 118 cf above, 21,275. 119 cf below, 21.281 to 282. 120 cf above, 21,271. 121 cf above, 21.201 to 202. 122 C. Isaac Barrow. Lections Geometricae. In Cabus, Preser Tim, Generalia Curvarum Symptomata Declarantur, London, 1672, Lecture 10. Section 14. The text is available in early English books online. 123 because these terms have no value. 124 cf. Note 97 above. Gilles Person de Roberval, 1602 to 1675, French mathematician who developed powerful methods for the study of integration. 125 C. Lagrange, Theorie de Fonctions Analytiques, Part 2, Chapter 2. Sections 5, 6. 126. Die und zugleich unmittelbar die Bedeutung der Gleichheit desselben, i.e. the relation mit der Ordinate und Subtangent selbst zu geben. 127. The work referred to by Hegel is Descartes' Over Completes, Volume 5, edited by Victor Cousin, Paris, F. G. Levrault, 1824. For an English version, see The Geometry of René Descartes, trans. David Eugene Smith and Marcia L. Latham. La Salle, Illinois. Open Court, 1952, pages 95 ff. 128 Ibid. I dare say that this problem is the most useful and the most general not only that I know, but that I have ever desired to resolve in geometry. The Geometry of René Descartes, page 95. 129 cf above, 21,285. 130 cf above, 21,283. 131 cf above, 21,246. 132 cf above, 21,289. 133 cf above, 21.262 to 263, footnote. 134 cf above, 21.262 to 263, footnote. 135 C. Lagrange. Theorie de Fonctions Analytiques, Part 3, Chapter 1, Section 2. 136 cf above, 21,265. 137 cf above, 21,284. 138 Lagrange, Theorie de Fonctions Analytiques, Part 2, Section 27. 139 cf above, 21,287. 140 Lagrange, Theorie de Fonctions Analytiques, Part 2, Section 29. 141 Johannes Kepler, Nova Stereometria Doliorum Vinariorum, The Stereometry of Wine Barrels, 1615, Part 1, Theorem 3, where Kepler refers to Archimedes' use of indirect proof to deal with multi-multa, multitudes of multitude. In Gesammeltwerke, Band 9, Mathematische Schriften, Munich, 1960, page 15. 142 Lucas Valerius, 1618, extended the doctrine of the center of gravity to solid bodies. 143 Cavallari, Geometria Indivisibilium Continuorum Nova, 1635. Exercitations Geometricae Sex, Bologna, 1647. 144 cf above, 21,275. 145 cf above, 21,267, Hegel's footnote. 146 Friedrich Wilhelm Speer, 1799 to 1833, mathematician and cartographer in Braunschweig, best known for his Vollständiger Lehrgriff der reinen Kombinationslehre, 1824. 147 see note 141, above. 148 cf above, 21,301. 149 cf above, 21,253. 150 Cavallari, Exercitations Geometricae Sex, 1647, page 6. 151 C. Cavallari. Geometria Indivisibilibus Continuorum Nova, 1635. Book 2, Proposition 1, Scholium. 152 cf above, 21,304. 153 cf, 21,305, note 151 above. 154 ibid. 155 cf above, 21,305. 156 cf above, 21,304. 157 C. Cavallari, Exercitations Geometricae Sex, sections 15 through 17. 158 cf above, 21,284. 159 Andrew Taquet, 1611 to 1660, Jesuit mathematician at Antwerp. Chapter 3 Ratio or the Quantitative Relation 21, 310, 160. The infinity of quantum has been determined up to the point where it is the negative beyond of quantum, a beyond which quantum, however, has within it. This beyond is the qualitative moment in general. The infinite quantum, as the unity of the two moments, of the quantitative and the qualitative determinateness, is in the first instance ratio. In ratio, quantum no longer has a merely indifferent determinateness, but is qualitatively determined as simply referring to its beyond. It continues in its beyond, and this beyond is at first just another quantum. Essentially, however, the two do not refer to each other as external quanta, but each rather possesses its determinateness in this reference to the other. In their otherness, they have thus returned into themselves. What each is, that it is in its other. The other constitutes the determinateness of each. The quantum self-transcendence does not now mean, therefore, that quantum has simply changed either into some other or into its abstract other, into its abstract beyond, but that there, in the other, it has attained its determinateness. In its other, which is another quantum, it finds itself. The quality of quantum, its conceptual determinateness, is its externality as such, and in ratio quantum is now posited as having its determinateness in this externality, in another quantum, as being in its beyond what it is. It is quanta that stand to each other in the connection that has now come on the scene. This connection is itself also a magnitude. Quantum is not only in relation, 21.311, but is itself posited as relation. It is a quantum as such that has that qualitative determinateness in itself. So, as relation, as ratio, quantum gives expression to itself as self-enclosed totality and to its indifference to limit by containing the externality of its being determined in itself. In this externality, it is only referred back to itself and is thus infinite within. Ratio in general is direct ratio. In this, the qualitative moment does not yet emerge explicitly as such. In no other way except still as quantum is quantum posited as having its determinateness in its externality. In itself, however, the quantitative relation is the contradiction of externality and self-reference, the persistence of quanta and their negation. Such a contradiction next sublates itself. First, inasmuch as in indirect or inverse ratio the negation of each of the quanta is as such co-posited in the alteration of the other, and the variability of the direct ratio is itself posited. But in the ratio of powers, the unity, which in its difference refers back to itself, proves to be a simple self-production of the quantum. This qualitative moment itself, finally posited in a simple determination and as identical with the quantum, becomes measure. About the nature of the following ratios, much was anticipated in the preceding remarks concerning the infinity of quantity, that is, the qualitative moment in it. It only remains to analyze, therefore, the abstract concept of this ratio. The direct ratio. In the ratio which, as immediate, is direct, the determinateness of each quantum lies in the reciprocal determinateness of the other. There is only one 21.312 determinateness or limit of both, one which is itself a quantum, namely the exponent of the ratio. The exponent is some quantum or other. However, in referring itself to itself in the otherness which it has within it, it is only a qualitatively determined quantum, for its difference, its beyond and otherness, is in it. This difference in the quantum is the difference of unit and amount. The unit, which is the being determined for itself, the amount, which is the indifferent fluctuation of determinateness, the external indifference of quantum. Unit and amount were at first the moments of quantum. Now, in the ratio, in quantum as realized so far, each of its moments appears as a quantum on its own and as determinations of the existence of the quantum, as delimitations against the otherwise external, indifferent determinateness of magnitude. The exponent is this difference as simple determinateness, that is, it has the meaning of both determinations immediately in it. First, it is a quantum and thus an amount. If the one side of the ratio which is taken as unit is expressed in a numerical 1 and has only the value of 1, then the other, the amount, is the quantum of the exponent itself. Second, it is simple determinateness as the qualitative moment of the sides of the ratio. When the quantum of the one side is determined, the other is also determined by the exponent, and it is a matter of total indifference how the first is determined. It no longer has any meaning as a quantum determined for itself, but can just as well be any other quantum without thereby altering the determinateness of the ratio, which rests solely on the exponent. The one side which is taken as unit always remains unit however great it becomes, and the other, however great it too thereby becomes, must remain the same amount of that unit. 21, 313. Accordingly, the two truly constitute only one quantum. The one side has only the value of unit with respect to the other, not of an amount, and the other only that of amount. According to their conceptual determinateness, therefore, they are themselves not complete quanta. But this incompleteness is in them a negation, and it is so not because of their general variability, according to which one of them, any of the two, can assume all possible magnitudes, but because they are so determined that, as one is altered, the other is increased or decreased in corresponding measure. This means that, as indicated, only one of them, the unit, is altered as quantum, the other side, the amount, remains the same quantum of units, and the first side too retains the value of a unit, however much it is altered as quantum. Each side is thus only one of the two moments of quantum, and the self-subsistence which is their proper characteristic is in principle negated. In this qualitative combination, they are to be posited as negative with respect to each other. The exponent ought to be the complete quantum, since the determinations of both sides come together in it, but in fact, even as quotient the exponent only has the value of amount, or of unit. There is nothing available for determining which of the two sides of the relation would have to be taken as the unit or as the amount. If one side, quantum B, is measured against quantum A as unit, then the quotient C is the amount of such units. But if A is itself taken as amount, the quotient C is the unit which is required by the amount A for the quantum B. As exponent, therefore, this quotient is not posited for what it ought to be, namely the determinant of the ratio, or the ratio's qualitative unity. It is posited as such only to the extent that its value is that of the unity of the two moments, of unit and amount. And since these two sides, as quanta, are indeed present as they should be in the explicated quantum, in the ratio, but at the same time have the value, which is specific to them as the sides of the ratio, of being incomplete quanta, and of counting only as one of those qualitative moments, they are to be posited with this negation qualifying them. Thus there arises a more real ratio, one more in accordance with its definition, one in which the exponent has the meaning of the product of the sides. In this determinateness, it is the inverse ratio. 21,314. The inverse ratio. The ratio as now before us is the sublated direct ratio. It was an immediate relation and therefore not yet truly determinate. Henceforth, the newly introduced determinateness gives the exponent the value of a product, the unity of unit and amount. In immediacy, as we have just seen, it was possible for the exponent to be indifferently taken as unit or amount. Moreover, it also was only a quantum in general and therefore an amount by choice. One side was the unit, and this was to be taken as a numerical one with respect to which the other side would be a fixed amount and at the same time the exponent. The quality of the latter, therefore, was only that this quantum is taken as fixed, or rather that the constant only has the meaning of quantum. Now in the inverse ratio, the exponent is as quantum likewise immediate, a quantum or other which is assumed as fixed. But to the one of the other quantum in the ratio, this quantum is not a fixed amount. The ratio, previously taken as fixed, is now posited instead as alterable. If another quantum is taken as the unit of the one side, the other side now no longer remains the same amount of units of the first side. In direct ratio, this unit is only the common element of both sides. As such, it continues into the other side, the amount. The amount itself, or the exponent, is by itself indifferent to the unit. But as the determinateness of the ratio now is, the amount as such alters relative to the unit with respect to which it makes up the other side of the ratio. Whenever another quantum is taken as the unit, that amount alters. Consequently, although the exponent is still only an immediate quantum and only arbitrarily assumed as fixed, it does not remain fixed in the side of the ratio. Rather this side, and with it the direct ratio of the sides, is alterable. In the ratio now before us, the exponent as the determining quantum is thus posited as negative towards itself as a quantum of the ratio, and hence as qualitative, as limit. The result is that the qualitative moment distinctly comes to the fore for itself as against the quantitative moment. In the direct ratio, the alteration of the two sides is only the one alteration of the quantum from which the unity, which is the common element, is taken, by as much, therefore, as the one side is increased or decreased, so also is the other. The ratio itself is indifferent to this alteration and the alteration external to the ratio. In the indirect ratio, on the contrary, although still arbitrary according 21.315 to the moment of quantitative indifference, the alteration is contained within the ratio, and its arbitrary quantitative extension is limited by the negative determinateness of the exponent as by a limit. We must now consider this qualitative nature of the indirect ratio more closely, as it is realized, and sort out the entanglement of the affirmative and the negative moments that are contained in it. Quantum is posited as being quantum qualitatively, that is, as self-determining, as displaying its limit within it. Accordingly, first, it is an immediate magnitude as simple determinateness. It is the whole as existent, an affirmative quantum. But, second, this immediate determinateness is at the same time limit. For that purpose it is distinguished into two quanta which are at first the other of each other, but as the qualitative determinateness of these quanta, and as a determinateness which is moreover complete. Quantum is the unity of the unit and the amount, a product of which the two are the factors. Thus on the one hand the exponent of their ratio is in them identical with itself, and is their affirmative moment by which they are quanta. On the other hand, as the negation posited in them, it is in them the unity according to which each, at first an immediate and limited quantum in general, is at the same time so limited as to be only implicitly in itself identical with its other. Third, the exponent as the simple determinateness is the negative unity of this differentiation of it into the two quanta and the limit of their reciprocal limiting. In accordance with these determinations, the two moments limit themselves inside the exponent, and each is the negative of the other, for the exponent is their determinate unity. The one moment becomes as many times smaller as the other becomes greater. Each possesses a magnitude of its own to the extent that this magnitude is in it that of their other, that is the magnitude that the other lacks. The magnitude of each in this way continues into the other negatively. How much it is in amount, that much it sublates in the other as amount, and is what it is only through this negation or limit which is posited in it by the other. In this way, each contains the other as well, and is proportioned to it, for each is supposed to be only that quantum which the other is not. The magnitude of the other is indispensable to the value of each, and therefore inseparable from it. This continuity of each in the other constitutes the moment of unity through which the two magnitudes stand in relation, the moment of the one determinateness, of the simple limit which is the exponent. This unity, the whole, constitutes the in itself of each from which their given magnitude is distinct. This is the magnitude according to which each is only to the extent that it takes from the other a part of their common in itself, which is the whole. But each can take from the other only as much as will make it equal to this in itself. It has its maximum in the exponent which, in accordance with the stated second determination, is 21.316, the limit of the reciprocal delimitation. And since each is a moment of the ratio only to the extent that it limits the other and is thereby limited by it, it loses this, its determination, by making itself equal to its in itself. In this loss, the other magnitude will not only become a zero, but itself vanishes, for what it ought to be is not just a quantum, but what it is as such a quantum, namely only the moment of a ratio. Thus each side is the contradiction between the determination as its in itself, that is, as the unity of the whole which is the exponent, and the determination as the moment of a ratio. This contradiction is infinity again, in a new form peculiar to it. The exponent is the limit of the sides of its ratio, within which limit the sides increase and decrease proportionately to each other. But they cannot become equal to this exponent because of the latter's affirmative determinateness as quantum. Thus, as the limit of their reciprocal limiting, the exponent is alpha, there beyond which they infinitely approximate but can never attain. This infinity in which the sides approximate there beyond is the bad infinity of the infinite progression. It is an infinity which is itself finite, that finds its restriction in its opposite, in the finitude of each side and of the exponent itself, and for this reason is only approximation. But, beta, the bad infinite, is equally posited here as what it is in truth, namely the negative moment in general, in accordance with which the exponent is the simple limit as against the distinct quanta of the ratio. It is the in itself to which, as the absolutely alterable, the finitude of the quanta is referred, but which, as the quanta's negation, remains absolutely different from them. This infinite, which the quanta can only approximate, is then equally found affirmatively present on their side, the simple quantum of the exponent. In it is attained the beyond with which the sides of the ratio are burdened. It is in itself the unity of the two, or, consequently, in itself the other side of each side, for each side has only as much value as the other does not have. Its whole determinateness thus rests in the other, and this, their being in itself, is as affirmative infinity simply the exponent. With this, however, we have the transition of the inverse ratio into a determination other than the one it had at first. This consisted in the fact that the quantum is 21.317 immediate, but at the same time so connected to an other that the greater it is, the smaller is the other, that it is what it is by virtue of negatively relating to the other. Also, a third magnitude is the common restriction on this alteration in magnitude that the two quanta undergo. This reciprocal alteration, as contrasted to the fixed qualitative limit, is here their distinctive property. They have the determination of alterable magnitudes for which that fixed limit is an infinite beyond. But the determinations that have emerged and which we now have to sum up are not only that this infinite beyond is at the same time some present finite quantum or other, but that its fixity, which makes it with respect to the quantitative moment the infinite beyond that it is, and which is the qualitative moment of being only as abstract self-reference, has developed itself as a mediation of itself with itself in its other, the finite moments of the relation. The general point is that the whole is as such the limit of the reciprocal limiting of the two terms, and that the negation of the negation, and consequently infinity, the affirmative self-relation, is therefore posited. The more particular point is that, as product, the exponent already implicitly is already the unity of unit and amount, whereas each of these two terms is only one of two moments. And for this reason the exponent encloses them in itself, and in them it implicitly refers itself to itself. But in the inverse ratio the difference has developed into the externality of quantitative being, and the qualitative being is not only something fixed, nor does it simply enclose the two moments of the ratio immediately in it, but in the externally existent otherness it rejoins itself. It is this determination that stands out as a result in the moments we have seen. The exponent, namely, is found to be the implicit being whose moments are realized in quanta and in their generalized alterability. The indifference of the magnitudes of these moments in the course of their alteration displays itself as an infinite progression, the basis of which is that in their indifference their determinateness is to have their value each in the value of the other. Thus, alpha, according to the affirmative side of their quantum, the determinateness of the moments is that each is in itself the whole of the exponent. Equally, beta, they have the magnitude of the exponent for their negative moment, for their reciprocal limiting. Their limit is that of the exponent. The fact that such moments do not have any other immanent limit, any fixed immediacy, is posited in the infinite progression of their existence and in their limitation, in the negation of every particular value. This is, accordingly, the negation of the externality of the exponent which is displayed in them, and the exponent, itself equally a quantum as such in 21.318 also expanded into quanta, is thereby posited as preserving itself in the negation of the indifferent subsistence of the moments, as rejoining itself, and thus as the determining factor in this movement of self-surpassing. The ratio is hereby determined as the ratio of powers. The ratio of powers. Quantum, in positing itself as self-identical in its otherness and in determining its own movement of self-surpassing, has come to be a being for itself. As such a qualitative totality, in positing itself as developed, it has for its moments the conceptual determinations of number, the unit and the amount. This last, amount, is in the inverse ratio still an aggregate which is not determined as amount by the unit itself, but from elsewhere, by a third determinate aggregate, but now it is posited as determined only by the unit. This is the case in the ratio of powers where the unit, which in it is amount, is at the same time the amount as against itself as unit. The otherness, the amount of units, is the unit itself. The power is an aggregate of units, each of which is this aggregate itself. The quantum, as in different determinateness, changes, but inasmuch as the alteration is the raising to a power, the otherness of the quantum is determined purely by itself. The quantum is thus posited in the power as having returned into itself. It is immediately itself, and also its otherness. The exponent of this ratio is no longer an immediate quantum, as in the direct ratio, and also in the inverse ratio. In the ratio of powers, the exponent is of an entirely qualitative nature. It is this simple determinateness, that the amount is the unit itself, that the quantum is self-identical in its otherness. And the side of its quantitative nature is to be found in this, that the limit or negation is 21.319, not an immediate existent, but that existence is posited rather as continuing in its otherness. For the truth of quality is precisely to be quantity, or immediate determinateness as sublated. The ratio of powers appears at first as an external alteration to which a given quantum is subjected, but it has a closer connection with the concept of quantum, namely, that in the existence into which the quantum has developed in the ratio of powers, quantum has attained that concept, has realized its concept to the fullest. The ratio of powers is the display of what the quantum is implicitly in itself. It expresses its determinateness of quantum or the quality by which it is distinguished from another. Quantum is indifferent determinateness posited as sublated, that is to say, determinateness as limit, one which is just as much no determinateness, which continues in its otherness and in it, therefore, remains identical with itself. Thus is quantum posited in the ratio of powers, its otherness, the surpassing of itself in another quantum, as determined through the quantum itself. If we compare the progressive realization of quantum in the preceding ratios, we find that quantum's quality of being the difference of itself from itself is simply this, that it is a ratio. As the direct ratio, quantum is this posited difference only in the first instance or immediately, so that the self-reference which it has as exponent, in contrast to its differences, counts only as the fixity of an amount of the unit. In the inverse ratio, as negatively determined, quantum is a relating of itself to itself as to its negation in which, however, it has its value. As an affirmative self-reference, it is an exponent which, as quantum, is only implicitly in itself the determinant of its moments. But in the ratio of powers, quantum 21.320 is present in the difference as a difference of itself from itself. This externality of determinateness is the quality of quantum and is thus posited, in conformity to the concept of quantum, as quantum's own determining, as its reference to itself, its quality. By being thus posited as it is in conformity to its concept, quantum has passed over into another determination, or, as we can also say, its determination is now also as the determinateness, the in itself also as existence. It is quantum in so far as the externality or the indifference of its determining, as we say, it is that which can be increased or decreased, is simply accepted and immediately posited. It has become the other of itself, namely quality, in so far as that same externality is now posited as mediated by quantum itself, and hence as a moment of quantum. So that in that very externality quantum refers itself to itself, is being as quality. At first quantity as such thus appears in opposition to quality, but quantity is itself a quality, self-referring determinateness as such, distinct from the determinateness which is its other, from quality as such. Except that quantity is not only a quality, but the truth of quality itself is quantity, and quality has demonstrated itself as passing over into it. Quantity, in its truth, is instead the externality which has returned into itself, which is no longer indifferent. Thus is quantity quality itself, in such a way that outside this determination quality as such would yet not be anything at all. For the totality to be posited, a double transition is required, not only the transition of one determinateness into the other, but equally the transition of this other into the first, its going back into it. Through the first transition, the identity of the two is present at first only in itself. Quality is contained in quantity, but the latter still is only a one-sided determinateness. Conversely, that quantity is equally contained in quality, that it is equally also only as sublated. This results in the second transition, the going back into the first determinateness. This remark regarding the necessity of the double transition is everywhere of great importance for scientific method. Quantum is henceforth no longer an indifferent or external determination, but is sublated as such, and it is a quality, and that by virtue of which anything is what it is. The truth of quantum is to be measure. 21,321. Remark. We explained above, in the remarks concerning the quantitative infinite, 161 that the difficulties associated with it have their origin in the qualitative moment that asserts itself in the sphere of the quantitative. We also explained how it is the qualitative moment of the ratio of powers which is particularly involved in a multitude of new starts and false starts. And we showed that the failure which chiefly stands in the way of a grasp of the concept of this infinite is that one stops short at just its negative determination as the negation of quantum and fails to proceed to its simple affirmative determination as qualitative. We now have only one more remark left to make. It concerns the intrusion of quantitative forms into the pure qualitative forms of thought that has occurred in philosophy. The ratio of powers especially has recently been applied to conceptual determinations. Thus, the concept has been called the first power in its immediacy, the second power in its otherness or difference in the existence of its moments, and the third power in its turning back to itself or as totality. 162. It immediately occurs against this usage that power, as so used, is a category that essentially belongs to quantum and has no conceptual connection to the potentia of Aristotle. The ratio of powers indeed expresses determinateness in the truth that it has attained as difference, but difference is found in the particular concept of quantum, not as it is in the concept as such. Quantum contains the negativity that belongs to the nature of the concept, but not as in any way already posited in the determination which is specific to it. So far as the concept is concerned, the differences of quantum are superficial determinations. They are still far from being determined as they are in the concept. It was in the infancy of philosophical thinking that numbers were used, as by Pythagoras, to designate universal essential differences, and for this purpose, first power, second power, etc., have no advantage over numbers. This was a preliminary stage in the process of comprehension by pure thought. Only after Pythagoras were the determinations of thought themselves discovered, that is, they were explicitly brought to consciousness. But to step back in this process to number determinations is the symptom of a 21.322 thought that senses its incapacity, and, in an effort to stand up to the contemporary philosophical culture, which is accustomed to thought determinations, now adds the comedy of pretending that its weakness is something new and superior, a step forward. There is nothing much to be said against the symbolic use of the language of power, no more than there is against the use of numbers or any other kind of symbols for concepts. But there is also everything to be said against it, as there is against any system of symbols that pretends to convey pure conceptual or philosophical determinations. Philosophy has no need of any such aid, either from the world of the senses, or from the representations of the imagination, or also from spheres which belong to its own realm but are subordinated, and whose determinations are therefore unsuited to higher circles and to the whole. This last is universally the case when the categories of finitude are applied to the infinite. The common determinations of force or substantiality, cause and effect, and so on, are likewise only symbols when expressing, for instance, living or spiritual relations. That is, they are to them untrue determinations, and all the less true to them, or to speculative relations in general, are the quantum powers or the numerical powers. If one is to use numbers, powers, the mathematical infinite, and the like, not as symbols, but as forms of philosophical determinations and consequently, as themselves philosophical forms, then one must start by defining their philosophical meaning, that is, their conceptual determinateness. But the moment this is done, they become superfluous designations, for the determinateness of the concept is its own designation, and this alone is the one which is both correct and fitting. The use of those forms is, therefore, nothing more than a convenient means for sparing oneself the task of grasping the determinations of the concept, of specifying and justifying them. 160. Das quantitative Verhaltnis. 161. These are the remarks at the end of the preceding chapter. 162. Hegel is clearly referring to Schelling and his disciples, and to Bardili as well. Section 3, Measure 21, 323. Abstractly expressed, quality and quantity are in measure united. Being as such is the immediate equality of determinateness with itself. This immediacy of determinateness has sublated itself. Quantity is being that has returned to itself in such a way that it is a simple self-equality indifferent to determinateness. But this indifference is only the externality of having the determinateness not in itself, but in another. As third, we now have the externality that refers itself to itself. As self-reference, it is at the same time sublated externality and carries the difference from itself in it, a difference which, as externality, is the quantitative moment, and, as taken back into itself, the qualitative. Since among the categories of transcendental idealism modality comes after quantity and quality, with relation inserted in between, this is an appropriate place to say something about it. In transcendental idealism, this category has the meaning that it is the connection of the subject matter to thought. As understood by that idealism, thought is as such essentially external to the thing in itself. Hence, inasmuch as the other categories have the transcendental determination of belonging only to consciousness, but as its objective moment, so modality, which is the category of the connection to the subject, possesses the determination of reflection in itself in a relative sense. 221.324, that is to say, the objectivity which is granted to the other categories is lacking in those of modality. These, according to Kant's words, do not add in the least to the concept as a determination of the object, but only express its relation to the faculty of cognition, cr, of pure R, second ed., pp. 99, 266. 3. The categories which Kant groups under modality, possibility, actuality, and necessity, will come up later in their proper place. For Kant did not apply the form of triplicity, an infinitely important form even though with him it occurred only as a formal spark of light, to the genera of his categories, to quantity, quality, etc., but only to their species to which he also gave the name of genera. He was therefore unable to hit upon the third to quality and quantity. With Spinoza, the mode is likewise the third after substance and attribute. 5. Spinoza defines it as the affections of substance, or as that which is in another through which it is also comprehended. In this way of conceiving it, this third is externality as such, as has already been mentioned. 6. With Spinoza generally, the rigidity of substance lacks the turning back into itself. The remark just made extends to any of the systems of pantheism which thought has in one way or other produced. Being, the one, substance, the infinite, essence, is the first. Opposite this abstraction is the second, which can be mustered in an equally abstract form, as is habitually done as the next step in any purely formalistic thinking, namely all determinateness generally taken as the mere finite, the mere accidental, the transitory, the extraneous and unessential, etc. But the bond connecting this second with the first is too invasive for the second not to be not equally grasped with the first. Thus with Spinoza the attribute is the whole of substance, though as comprehended by the understanding, which is itself a restriction of substance or mode. And so the mode, the insubstantial as such which can be grasped only through another, constitutes the opposite extreme of substance, the third. Also Indian pantheism, taken abstractly, has attained in its monstrous fantasies this refinement which runs like a moderating thread across its excesses as its one point of interest, namely that Brahma, the one of abstract thought, progresses through the shape of Vishnu, particularly in the form of Krishna, to the third, Shiva. The determination of this third is that of mode, alteration, coming to be, and passing away. It is the field of externality in general. This Indian trinity has tempted a comparison with the Christian, and one must indeed acknowledge a common 21.325 element in them. But it is essential to be aware of the difference that separates them. It is not just that this difference is infinite, but that the true infinity makes the difference. The determination of the Indian third principle is that it is the dispersal of the substantial unity into its opposite, not its turning back to itself. A spiritual void rather, not spirit. In the true Trinity, there is not only unity but unification. The syllogism is brought to a unity which is full of content and actual, a unity which in its totally concrete determination is spirit. The principle of the mode and of alteration does not, of course, exclude unity altogether. In Spinozism, for instance, precisely the mode is as such untrue, while substance alone is what truly is. Everything is supposed to be reduced to substance, and this is then a sinking of all content into an only formal unity void of content. As for Shiva, It too is again the great whole, not distinct from Brahma itself. That is, the distinction and the determinateness just disappear without being preserved, without being sublated, and the unity does not become concrete unity, nor is the diremption reconciled. The supreme goal of the human being, relegated as he is to the sphere of coming to be and passing away, of modality in general, is to sink into unconsciousness, into unity with Brahma, annihilation. The Buddhist nirvana, nibbana, etc., is the same. Now, although the mode is as such abstract externality, indifference to qualitative as well as quantitative determinations, and nothing in the essence should depend on the external, the unessential, it is nevertheless conceded that in the many all depends on the how. 7. But this is to concede that the mode itself essentially belongs to the substance of a thing. A very indefinite connection, but one which at least implies that the externality of the mode is not all that abstract an externality. After all, 8. Here the mode has the definite meaning of being measure. The Spinozistic mode, just like the Indian principle of alteration, is the measureless. The Greeks were aware that everything has a measure. Parmenides himself introduces necessity after abstract being, as the ancient limit which is imposed on all. 9. And this awareness, although still vague, is the beginning of a much higher concept than is contained in substance and in the distinction of the mode from it. Measure in its more developed, more reflected form is necessity. Fate, nemesis, ultimately comes down to a determination of measure. Whatever renders itself beyond the pale becomes too great, too high. Is 21.326 brought down to the other extreme of being reduced to nothing, so that the mean of measure, the medium, is restored. That the absolute, God, is the measure of all things, is not a stronger statement of pantheism than the definition, the absolute, God, is being, but is infinitely truer. Measure is indeed an external way of things, a more or less, but one which is as at the same time reflected into itself, not merely an indifferent and external determinateness, but one which exists in itself. Thus it is the concrete truth of being. For this reason the nations have revered in it the presence of something inviolable and sacred. Already present in measure is the idea of essence, namely of being self-identical in the immediacy of being determined, so that this immediacy is reduced through the self-identity to something mediated, just as the self-identity is equally mediated only through this externality, but the mediation is one with itself. This is reflection, the moments of which indeed are, but in this being are absolutely nothing but moments of their negative unity. In measure, the qualitative element is quantitative, the determinateness or the difference is indifferent, and therefore a difference which is none. It is sublated, and this quantitativeness, 10 as an immanent turning back in which it is qualitative, constitutes the being in and for itself, which is essence. But measure is essence only implicitly in itself or in its concept. This concept of measure is not yet posited. Measure is as such still the existent unity of the qualitative and the quantitative element. Its moments are an existence, a quality, and some quanta of this quality which, in themselves, are indeed only indivisible, but do not yet have the meaning of this reflected determination. In the development of measure, these moments are differentiated but at the same time referred to each other, so that the identity which they are in themselves becomes their connection explicitly, that is posited. The meaning of this development is the realization of measure in which the latter posits itself in relation to itself and consequently, as moment as well. Through this mediation, measure is determined as sublated. Its immediacy as well as that of its moments disappears. These moments are reflected, and thus measure, having disclosed what it is according to its concept, has passed over into essence. Measure is at first the immediate unity of the qualitative and the quantitative element, so that it is 21,327 first, a quantum that has qualitative meaning and is as measure. As so implicitly determined in itself, Its further determination is that the difference of its moments, of its qualitatively and quantitatively determined being, is disclosed in it. These moments further determine themselves into wholes of measure which as such are self-subsistent, and, inasmuch as they refer to each other essentially, measure becomes, second, a ratio of specific quanta, each an independent measure. But their self-subsistence also rests essentially on a quantitative relation and a difference of magnitude, and so the self-subsistence becomes a transition of one measure into another. The result is that measure collapses into the measureless. But this beyond of measure is the negativity of measure only in itself. Thus, third, the indifference of the determinations of measure is thereby posited, and measure, real measure because of the negativity contained within it, is posited as an inverse ratio of measures which, as self-subsistent qualities, essentially rest on only their quantity and their negative reference to each other, and consequently prove to be only moments of their truly self-subsistent unity. This unity is the reflection into itself of each and the positing of them. It is essence. The development of measure, which we have attempted in what follows, is among the most difficult of subject matters. Starting with immediate, external measure, it would have to proceed, on the one hand, to the further abstract determination of the quantitative aspect of natural things, of a mathematics of nature. On the other side, it would have to indicate the link between this determination of measure and the qualitative aspect of those things, at least in general. For the detailed demonstration of the link between the qualitative and the quantitative aspects as they originate in the concept of a concrete object belongs to the particular science of the concrete, examples of which, concerning the law of falling bodies and the free movement of the heavens, will be found in the Encyclopedia of the Philosophical Sciences. 11. We may remark, quite in general in this connection, that the different forms in which measure is realized also 21.328 belong to different spheres of natural reality. The complete, abstract indifference of developed measure, that is, of its laws, can only be found in the sphere of mechanism, where concrete corporeity is only abstract matter itself. The qualitative differences of this matter are of an essentially quantitative nature. Space and time are nothing but pure externalities, and the aggregates of matters, the masses, the intensity of weight, are determinations which are just as external and have their proper determinateness in the quantitative element. On the other hand, in physical things, but even more so in the organic, this quantitative determinateness of abstract materiality is already disturbed by the multiplicity and consequently the conflict of qualities. And the thus ensuing conflict is not just one of qualities as such, but measure itself is subordinated here to higher relations, and its imminent development is reduced rather to the simple form of immediate measure. The limbs of the animal organism have a measure which, as a simple quantum, stands in a ratio to the other quanta of the other limbs. The proportions of the human body are the fixed ratios of such quanta, and the science of nature still has far to go in discovering anything about the link that connects these magnitudes with the organic functions on which they are entirely dependent. But the closest example of the reduction of an immanent measure to a merely externally determined magnitude is motion. In the heavenly bodies, motion is free motion, one which is only determined by the concept from which alone. Consequently, its magnitudes equally depend, see above. But in the organic body, this free motion is reduced to one which is arbitrary or mechanically regular, that is, to one which is totally abstract and formal. And in the realm of spirit, there is even less of a characteristic, free development of measure to be found. For instance, it is obvious that a republican constitution like the Athenian, or an aristocratic constitution mixed with democracy, is possible only in a state of a certain size. It is also obvious that in civil society the multitudes of individuals who belong to the different occupations stand in a certain ratio to each other. But none of this yields either laws of measures or typical forms of it. In the spiritual realm as such there are indeed distinctions of intensity of character, strength of imagination, sensations, representations, and so on. But in determining them, one cannot go past this indefinite duo of strength and weakness. To see how lame and totally empty ultimately turn out to be the so-called laws which have been established for the relation of strength and weakness in sensations, representations, and so on, one need only look at the psychologies that busy themselves with just such matters. 1A80/B109. 2. Relative. One sentence in the 1812 edition of this introduction to measure, which is not included in the present, otherwise much enlarged 1832 version of the same text, may help to explain Hegel's meaning. On one side here of thought, only pure externality is contained, for the connection to thought which could be the moment of reflection into itself is here rather the externality itself. 11, 189.17-20. That is to say, in transcendental idealism, the return of thought from the subject matter, Gegenstand, back to itself, which would constitute its truth, is only relative, i.e. still subjective, for the object from which the return is made remains an empty externality, which is indicated only at a distance. The objectivity, objectivitat, attained is still subjective. In this respect, there is an affinity between transcendental idealism and Spinoza's thought, which Hegel then goes on to consider. 3A74/B99, A219/B266 ff. For cf 11.389 ff. Below. 5 cf Ethics, definition for which follows after the definition of substance and attribute. English trans, page 45. 6 cf above, 21,247. 7 Art und Weis. Both art and Weiss can be translations of the Latin modus or mode. 8. This paragraph does not appear in the 1812 edition. It is part of the much enlarged 1832 text. It is especially important because it signals a clarification in Hegel's own mind regarding the new objective meaning that the modal categories assume when measure is understood as a yet undeveloped form of mode. See the translator's introduction. 9 C. Die Fragment der Vorsorgkritiker, Diels/Krantz, Volume 2, 28b8. 10 Quantitativität. 11 3rd ed., Section 267 and 270, Remark. Chapter 1 Specific Quantity 21, 329. Qualitative quantity is, first, an immediate, specific quantum, and this quantum, second, in relating itself to another, becomes a quantitative specifying, a sublating of the indifferent quantum. This measure is to this extent a rule, and contains the two moments of measure as different, namely, the quantitative determinateness and the external quantum as existing in themselves. In this difference, however, the two sides become qualities, and the rule becomes a relation of the two. Measure presents itself thereby, third, as a relation of qualities that have one single measure at first, a measure, however, which further specifies itself in itself into a difference of measures. The specific quantum. Measure is the simple self-reference of quantum, its own determinateness in itself. Quantum is thus qualitative. At first, as an immediate measure, it is an immediate quantum and hence some specific quantum. Equally immediate is the quality that belongs to it. It is some specific quality or other. Thus quantum, as this no longer indifferent limit but as self-referring externality, is itself quality and, although distinguished from it, it does not extend 21.330 past it, just as quality does not extend past quantum. Quantum is thus the determinateness that has returned into simple self-equality, which is at one with determinate existence, just as determinate existence is at one with it. If a proposition is to be made of the determination just obtained, it could be expressed thus: whatever is, has a measure. Every existence has a magnitude, and this magnitude belongs to the very nature of a something. It constitutes its determinate nature, and it's in itself. The something is not indifferent to this magnitude, as if, were the latter to alter, it would remain the same. Rather, the alteration of the magnitude alters its quality. As measure, the quantum has ceased to be a limit which is none. It is from now on the determination of a thing, so that, were the latter to exceed or fall short of this quantum, it would perish. A measure, in the usual sense of a standard, is a quantum which is arbitrarily assumed as the unit determinate in itself as against an external amount. Of course, such a unit can in fact also be determinate in itself, like a foot or some such other original measure. To the extent, however, that it is used as the measuring standard for other things, it is with respect to them only an external measure, not their original measure. Thus, the diameter of the Earth or the length of a pendulum may be taken as a specific quantum on their own account. But the choice of a fraction of the Earth's diameter or of the pendulum's length, and this last under which degree of latitude, for use as a standard of measure, is arbitrary. And for other things such a standard is something even more external. These have further specified the universal specific quantum in some particular way, and they have thereby been made into particular things. It is therefore foolish to speak of a natural standard of things. Anyway, a universal standard is meant for use only as an external comparison of things, and in this superficial sense of universal standard, it is quite a matter of indifference what is used for the purpose. It is not meant to be a fundamental measure in the sense that in it the natural measures of particular things would be displayed and recognized, according to a rule, as the specifications of one universal measure, the measure of the thing's universal body. But without this meaning 21.331, the sole interest and significance of an absolute standard of measure is that of something common, and any such standard is a universal not in itself, but only by convention. Immediate measure is a simple determination of magnitude as, for example, the size of organic beings, of their limbs, and so forth. But any concrete existent has the size required for being what it is, and for having existence in the first place. As a quantum, the existent is an indifferent magnitude open to external determination and capable of fluctuating increases and decreases. As a measure, however, it is at the same time distinct from itself as quantum, itself as such an indifferent determination, and is a restriction on that indifferent fluctuation of a limit. Since in the existence of anything the quantitative determinateness is thus twofold, in the sense that quality is tied to it, and yet the quantity can fluctuate without prejudice to quality, so the demise of anything that has a measure occurs through the alteration of its quantum. On the one hand, the demise appears unexpected, inasmuch as there can be alteration in the quantum without the measure and the quality being altered. But, on the other hand, it is made into something quite simple to grasp, by means namely of the concept of gradualness. It is easy to turn to this category for visualizing or explaining the disappearance of a quality or of a something, for it gives the impression that one can witness this disappearance as if before one's eyes. Since the quantum is posited as the external limit which is by nature alterable, the alteration, of quantum only, then follows by itself. But in fact nothing is thereby explained, for the alteration is at the same time essentially the transition of one quality into another, or the more abstract transition of one existence into a non-existence, and therein lies another determination than just gradualness, which is only a decrease or increase, and the one-sided holding fast to magnitude. The ancients had already taken notice of this coincidence, that an alteration which appears to be only quantitative suddenly changes into a qualitative one, and they used popular examples to illustrate the inconsistencies that arise when such a coincidence is not understood. Two such examples go under the familiar names of the bald and the heap. They are elenchi, that is, according to Aristotle's explanation, two ways in which one is 21.332 compelled to say the opposite of what one has previously asserted. 12. The question was put, does the plucking of one hair from someone's head or from a horse's tail produce baldness, or does a heap cease to be a heap if one grain is removed? The expected answer can safely be conceded, for the removal amounts to a merely quantitative difference, and an insignificant one at that. And so one hair is removed, 1 grain. And this is repeated with only 1 hair and 1 grain being removed each time the answer is conceded. At last, the qualitative alteration is revealed. The head or the tail is bald. The heap has vanished. In conceding the answer, it was not only the repetition that was each time forgotten, but also that the individually insignificant quantities, like the individually insignificant disbursements from a patrimony, add up, and the sum constitutes the qualitative whole, so that at the end this whole has vanished. The head is bald, the purse is empty. The embarrassment, the contradiction, produced by the result, is not anything sophistic in the usual sense of the word, as if the contradiction were a pretense. The mistake is committed by the assumed interlocutor, that is, our ordinary consciousness, and that is of assuming a quantity to be only an indifferent limit, that is, of taking it in the narrowly defined sense of a quantity. But this assumption is confounded by the truth to which it is brought, namely that quantity is a moment of measure and is linked to quality. Refuted is the one-sided stubborn adherence to the abstract determinateness of quantum. Also, those elenchi are, therefore, not anything frivolous or pedantic, but basically correct. They attest to a mind which has an interest in the phenomena that come with thinking. Quantum, when it is taken as indifferent limit, is the side from which an existence is unsuspectedly attacked and laid low. It is the cunning of the concept that it would seize on an existence from this side, where its quality does not seem to come into play, and it does it so well that the aggrandizement of a state or of a patrimony, etc., which will bring about the misfortune of the state or the owner, even appears at first to be their good fortune. Measure is in its immediacy an ordinary quality of a specific magnitude appropriate to it. Now there is also the distinction between the side according to which quantum is an indifferent limit that can fluctuate without the quality altering, and the other side according to which it is qualitative and specific. Both sides are the magnitude determinations of one and the same thing. But because of the original immediacy of measure, this distinction too is to be taken as immediate, and accordingly the two sides each also have a diverse concrete existence. The concrete existence of measure, which is the side of magnitude determinate in itself, then 21.333 behaves towards the concrete existence of the alterable external side by sublating the indifference of the latter. This is a specifying of measure. Specifying measure. First, this measure is a rule, a measure external to the mere quantum. Second, it is a specific quantity determining the external quantum. Third, the two sides, both as qualities of specific quantitative determinacy, relate to one another as one measure. The rule. The rule, or the standard which we have just mentioned, is in the first instance as a magnitude which is determinate in itself and is a unit with respect to a quantum of a particular concrete existence. This is a quantum with a concrete existence which is other than the something of the rule, is measured by the latter, that is determined as the amount of the said unit. This comparison is an external act, and the unit itself is an arbitrary magnitude which can in turn be posited as an amount, the foot as an amount of inches. But measure is not only an external rule. As a specific measure, its intrinsic nature is that it relates to its other, which is a quantum. Specifying measure. Measure is a specific determining of the external magnitude, that is, of the indifferent magnitude which is now posited in the measuring something by some other concrete existence in general. 13. The something of the measure is indeed itself a quantum, but with the difference that it is the qualitative side determining the merely indifferent external quantum. It has intrinsically this side of being for other to which the fluctuation in size belongs. The immanent measuring is a quality of the something, and this something is confronted by the same quality 21.334 inches another something. In the latter, however, the quality is at first relative, with a measureless quantum in general as against the something determined as measuring. 14. Inasmuch as a something has an internal measure, an alteration of the magnitude of its quality comes to it from outside, and the something does not take on the arithmetical aggregate of the alteration. Its measure reacts against it, behaves towards the aggregate as an intensive measure and assimilates it in a way typically its own. It alters the externally imposed alteration, makes something else out of this quantum, and demonstrates through this specifying function that in this externality it is for itself. This specifically assimilated aggregate is itself a quantum which is also dependent on the other, that is, on the other aggregate which is only external to it. The specified aggregate is therefore also alterable, but is not for that reason a quantum as such, but the external quantum as specified in a constant manner. Measure thus has its determinate existence as a ratio, and its specificity is in general the exponent of this ratio. An intensive and extensive quantum, as we saw when considering these determinations. 15. It is the same quantum which is present, once in the form of intensity and again in the form of extension. In this difference, the underlying quantum does not suffer any alteration. The difference is only an external form. In the specifying measure, on the contrary, the quantum is taken in one instance in its immediate magnitude, but through the exponent of the ratio it is taken in a second instance in another amount. The exponent which constitutes the element of specificity can appear at first to be a fixed quantum, as a quotient of the ratio between the external and the qualitatively determined quantum. But it would then be nothing more than an external quantum, whereas by the exponent we are to understand here nothing but the qualitative moment itself that specifies the quantum as such. The only strictly immanent qualitative determination of the quantum is, as we saw earlier, 16, that of the exponent, and it must be such an exponential determination which now constitutes the ratio, and which, as the internally existent determination, 21.335, comes to confront the quantum as externally constituted. The principle of this quantum is the numerical one which constitutes its internal determinateness. The mode of connection of this numerical one is external, and the alteration which is determined only through the nature of the immediate quantum as such consists essentially in the addition of one such numerical one and then another, and so forth. As the external quantum alters in arithmetical progression in this way, the specifying reaction of the qualitative nature produces another series which refers to the first, increases and decreases with it, not however in a ratio determined by a numerical exponent, but in a ratio which is numerically incommensurable in the manner of a power determination. Remark. To cite an example, temperature is a quality in which these two sides of external and specified quantum are distinguished. As a quantum, the temperature is external and is also, indeed, the temperature of a body as a general medium, and it is assumed that its alteration runs on the scale of an arithmetical progression, increasing or decreasing uniformly. But in fact, the temperature is differently assimilated by the different particular bodies found at that temperature. For since these bodies determine the externally received temperature through their immanent measure, the change in temperature of any of them does not correspond in a direct ratio to that of the medium or any other among them. Different bodies compared at one and the same temperature give the numerical ratios of their specific heats, of their thermal capacities. But such thermal capacities of bodies vary at diverse temperatures, and associated with the variation is the appearance of an 21.336 alteration in specific shape. In the increase or decrease of temperature, there is thus manifested a particular specification. The ratio of the temperature, represented as external, to the temperature of a particular body which is at the same time dependent on that temperature, does not have a fixed ratio exponent. The increase or decrease of this heat does not proceed uniformly with the increase or decrease of the external heat. A temperature is being assumed here which is absolutely external, of which the alteration would be merely external or purely quantitative. But the temperature is itself the temperature of air or some other specific temperature. The ratio, therefore, if looked at more closely, would properly have to be taken not as the ratio of a merely quantitative quantum to a qualifying quantum, but of two specific quanta. And this is how the specifying ratio is now further determined. The moments of measure are not only the sides of one and the same quality, one side quantitative and the other side qualifying the quantum, but consist rather in the relation of two qualities which are in themselves measures. Relation of the two sides as qualities. The qualitative side of the quantum, in itself determined, exists only as a reference to the external quantitative side. As specifying the latter, it is a sublating of its externality through which quantum as such is. This qualitative side thus has a quantum for the presupposition from which it starts. But this quantum is also qualitatively distinguished from quality, and this difference between the two must now be posited in the immediacy of being in general, which still characterizes measure. The two sides thus stand to each other in a qualitative respect, each a qualitative existence for itself, and the one side that was at first only an internally indeterminate formal quantum is the quantum of a something and of its quality, and, just as their reciprocal reference is now determined as measure in general, so too is the specific magnitude of these qualities. These qualities stand in relation to each other according to a 21.337 determination of measure. This determination is their exponent, but they are already implicitly connected to each other in the being for itself of measure. The quantum is in its double being external quantum and specific quantum, so that each of the distinct quantities has this double determination in it, and is at the same time inextricably interwoven with the other. It is in this way alone that the qualities are determined. They are not, therefore, a determinate being in general existing for each other, but are rather posited as indivisible, and the specific magnitude tied to them is a qualitative unity, one determination of measure in which they are implicitly bound together in accordance with their concept. Measure is thus the immanent quantitative relating of two qualities to each other. In measure we have the essential determination of variable magnitude, for measure is sublated quantum. Quantum, therefore, no longer as that which it ought to be in order to be quantum, but quantum as quantum and as something other besides. This other is the qualitative element, and, as we have established, is nothing else than the relation of powers of the quantum. In immediate measure, this variability is not yet posited. It is just one single quantum or other to which a quality is attached. In the specifying of measure, the preceding determination, which is an alteration of the merely external quantum by the qualitative moment. What is posited is the distinctness of two determinate magnitudes, and hence in general the plurality of measures in one common, external quantum. And it is in this differentiation of the quantum from itself that the latter shows itself for the first time to be a real measure, for it appears as a being which is one and the same, e.g., the constant temperature of the medium, and at the same time of diversified and indeed quantitative existence, in the various temperatures of the bodies found in the medium. This differentiation of quantum into the diverse qualities, the different bodies, yields a further form of measure, one in which the two sides relate to each other as qualitatively determined quanta, and this can be called the realized measure. Magnitude, simply as such, is alterable, for its determinateness is a limit which at the same time is none. The alteration only affects, therefore, a particular quantum in place of which another is posited. But the genuine alteration is that of the quantum as such. Here we have the determination, interesting when so understood, of the variable magnitude of higher mathematics, in which we neither need to stop short at the formal determination of alteration or variability in general, nor introduce any other determination except the simple determination of the concept, by which the other of the quantum is only the qualitative. The genuine determination, therefore, of real variable magnitude is that it is qualitative, that is, as we 21.338 have sufficiently shown, that it is determined by a ratio of powers. Posited in this variable magnitude is that quantum has no value as such, but only as determined in conformity with its other, that is, qualitatively. The two sides in this relating have, in keeping with their abstract side as qualitites in general, some particular meaning or other, for instance, space and time. Taken at first simply as determinacies of magnitude in their ratio of measure, One of them is the amount which increases and decreases in external arithmetical progression. The other is an amount specifically determined by the other amount, which for it is the unit. If each of these two sides were only a particular quality in general, there would be no way of distinguishing which of them is to be taken with respect to their determination of magnitude as merely externally quantitative and which is varying in quantitative specification. If they are related, for instance, as root and square, it is indifferent which is regarded as increasing or decreasing in merely external arithmetical progression, and which on the contrary has its specific determination in this quantum. But the two qualities are not indeterminate in their difference, for they are the moments of measure, and the qualification of the latter ought to rest on them. The closest determinateness of the qualities themselves is, of the one, the extensive, that it is an externality within, and of the other, the intensive, that it exists in itself or is the negative as against the other. Accordingly, amount is the quantitative moment that pertains to the former, and unit the one that pertains to the latter. In simple direct ratio, the former is to be taken as the dividend and the latter as the divisor. In specifying ratio, the former as the power or the becoming other and the latter as the root. Inasmuch as we still count here, that is, we reflect on the external quantum, which is thus the totally accidental determinateness of magnitude which we call empirical, and accordingly also equally take the alteration as advancing in external arithmetical 21.339 progression. Then this falls on the side of the unit, the intensive quality. The external extensive side, by contrast, is to be represented as altering in the specified series. But the direct ratio, like velocity as such, is reduced here to a formal determination which has no concrete existence, but belongs rather only to the abstraction of reflection. And even though in the ratio of root and square, as in s equals at 2, the root is to be taken as an empirical quantum varying in an arithmetical progression, the other side is specified instead. The higher realization of the qualification of the quantitative moment, one which would be more in keeping with the concept, is this: that both sides are related in higher determinations of powers, as in S3 equals at 2. Remark: the discussion here regarding the connection in measure between the qualitative nature of an existence and its quantitative determination has its application in the already cited example of motion. First of all, in the fact that in velocity, as the direct ratio of traversed space and the elapsed time, the magnitude of time is taken as denominator and that of space as numerator. If velocity is as such only a ratio of the space and time of a motion, it is then indifferent which of the two moments should be considered as the numerator and which as the unit. But space, like weight in specific gravity, is an external, real whole as such, and hence amount. Time, like volume, is on the contrary the ideal, the negative, the side of unity. But the more important ratio, the one essential to the point at issue here, is the one that holds in free motion. In the first instance, in the still conditioned motion of a falling body, where the quantitative values of time and space are reciprocally determined as root and square respectively, and then in the absolutely free motion of the celestial bodies, where the period of revolution and the distance 17 are reciprocally determined, the one as one power lower than the other, as square and cube respectively. Fundamental relations of this kind rest on the nature of the related qualities of space and time, and on the way they stand connected, whether their motion is mechanical, that is, unfree or not determined by the concept of its moments, or is 21.340 the motion of a falling body, that is, conditionally free, or the absolutely free motion of the heavens. These kinds of motion as well as their laws rest on the development of the concept of their moments, space, and time, for these qualities prove as such, in themselves or in their concept, to be indivisible, and their quantitative relation, the being for itself of measure, is only one measure determination. Regarding the absolute relations of measure, it should be noted that the mathematics of nature, if at all worthy of the name of science, would have to be essentially the science of measure, a science to which much has indeed been contributed empirically, but still preciously little scientifically, that is, philosophically. Mathematical Principles of Natural Philosophy, as Newton called his work, 18 if they are to live up to this title in a deeper sense than Newton and those of the entire Baconian lineage of philosophy did, would have to contain things of quite a different nature in order to shed some light on these regions, still dark, yet eminently worthy of attention. It is a great service to discover the empirical numbers of nature, e.g. the distances of the planets from each other. But an infinitely greater service would be to make the empirical quanta disappear by raising them to a universal form of quantitative determinations in which they become the moments of law or of measure. Immortal services which, for instance, Galilei achieved for the motion of falling bodies and Kepler for the movement of the celestial bodies. These men have proven the laws they have discovered by showing that the full compass of the singular things of perception conform to them. But a still higher proof of these laws must be demanded, nothing less, namely, than of knowing their quantitative determinations from the qualities or determinate concepts connected in them, such as space and time. Of this kind of proof there is still no trace in the cited mathematical principles of natural philosophy, as also there is none in subsequent works of the same kind. It has already been remarked, in connection with the semblance of mathematical proofs of certain natural relations, a semblance based on the misuse of the infinitely small 19, that the attempt to conduct any such proof on a truly mathematical basis, that is, neither empirically nor conceptually, is in 21.341 absurd undertaking. Proofs of this kind presuppose their theorems and even the laws to be proved from experience. What they manage to accomplish amounts to this, that they reduce such theorems and such laws to abstract expressions and convenient formulas. A better informed day will come when the entire and truly real merit that will be attributed to Newton in these matters as against Kepler, once the sham scaffolding of proofs has been cast aside, undoubtedly because of a clearer awareness of what mathematics can deliver and has delivered, will be restricted to Newton's said transformation of Kepler's formula O and to his albeit still incipient introduction of analysis. The being for itself in measure. In the form of specified measure just considered, the quantitative moment of each side is qualitatively determined, both in the ratio of powers. They are thus moments of one measure determinateness of qualitative nature. Here, however, the qualities are still posited immediately, only as diverse. They are not related in the manner of their quantitative determinacies, that is, that outside their relation they would have neither meaning nor existence, as is the case for the quantitative determinacies as a ratio of powers. The qualitative moment thus disguises itself as specifying, not itself, but the determinateness of magnitude. Only within the latter is it posited. For itself it is instead immediate quality as such which, besides the fact that it posits the magnitude as non-indifferent, and besides its connection with its other, still has existence subsisting on its own. Thus space and time, outside that specification which their quantitative determinateness obtains in the motion of falling bodies or in the absolutely free motion, both have the value of space in general and time in general, space subsisting on its own outside and without the duration of time, and time flowing on its own independently of space. 21,342. This immediacy of the qualitative moment as against its specific measure relation is, however, equally bound up with a quantitative immediacy and with the indifference to this same measure relation of the quantitative element in it. The immediate quality also has only an immediate quantum. For that reason, the specific measure also has a side of an at first external alteration which advances in merely arithmetical progression undisturbed by it, and in which falls the external and hence merely empirical determination of magnitude. Quality and quantum, even as they extend outside measure, are at the same time connected with it. The immediacy is a moment of their belonging to measure. Thus the immediate qualities also belong to measure, are likewise connected, and stand in a ratio which, outside the specified one of power determination, is itself only a direct ratio and an immediate measure. This conclusion and its consequences must now be indicated. Although the immediately determined quantum is as a moment of measure otherwise implicitly grounded in a conceptual nexus, in connection with specific measure it is, as such, externally given. But the immediacy which is thereby posited is the negation of the determination of qualitative measure. The same immediacy was shown just now on the sides of the determination of measure, which appeared for that reason to be self-subsisting qualities. Such a negation and the return to immediate quantitative determinateness are present in the qualitatively determined relation because a relation of distinct terms entails as such the connection of such terms in one determinateness. And here, in the quantitative sphere, in distinction from the determination of the relation, this determinateness is a quantum. As the negation of the distinct, qualitatively determined sides, this exponent is a being for itself, an absolutely determined being, but is so only in itself. As existence, it is a simple immediate quantum, the quotient or exponent of a ratio between the sides of measure which is taken as direct. As such, however, it appears in the quantitative side of measure as an empirical unit. In the motion of falling bodies, the spaces traversed are proportional to the square of the elapsed time, s equals at 2. This is a specifically determinate ratio, one between space and time. The other, the direct ratio, would pertain to space and time as mutually indifferent qualities. It is supposed to be the ratio of the space traversed to the first moment of time. The same coefficient, a, remains in all the succeeding time points, the unit of the amount, determined for its part by the specifying measure, being an ordinary quantum. This unit counts at the same time as the exponent of that direct ratio which 21.343 pertains to the merely imagined, the bad, that is, the reflectively formal velocity which is not specifically determined by the concept. Such a velocity does not have concrete existence here, no more than does the one previously mentioned which is supposed to pertain to a falling body at the end of a moment of time. That velocity is ascribed to the first temporal moment in the fall, but this so-called temporal moment is itself only an assumed unit which has no existence as such an atomic point. The beginning of the motion, its alleged smallness would make no difference, is straightway a magnitude, and one which is specified by the law of falling bodies. The said empirical quantum is attributed to the force of gravity, and this force thus has itself no connection with the specification at hand, the determinateness of powers, that is, with the determinateness characteristic of measure. The immediate moment, that in the motion of falling bodies the amount of some 15 spatial units which are assumed as feet enter into one unit of time, call it a second, the so-called first unit, is an immediate measure, just like the size of human limbs, the distances and diameters of planets, etc. The determination of such measures falls elsewhere than within the qualitative determination of measure, here of the law itself of falling bodies. On what such numbers depend? These merely immediate and therefore empirical appearances of a measure. On this the concrete sciences have yet to give us any information. Here we are only concerned with this conceptual determination, namely that in any determination of measure the empirical coefficient constitutes the being for itself, but only the moment of the being for itself, insofar as it is in principle and therefore as immediate. The other moment is the development of this being for itself, the specific measure determinateness of the sides. According to this second moment, in the ratio expressing the motion of falling bodies, this motion that is still half conditioned and half free, gravity is to be regarded as a force of nature. Its ratio is thus determined by the nature of time and space, and the said specification, the ratio of powers, therefore falls in it. The other moment mentioned above, the simple direct ratio, expresses only a mechanical relation of time and space, a reflectively formal velocity externally produced and externally determined. Measure has now taken on the determination of being a specified quantitative relation, one which, as qualitative, has within it the usual external quantum, But this quantum is not a quantum in general, but essentially the determining moment of the relation as such. It is thus an exponent, and, because of the immediacy now of its determinateness, an invariable exponent. Consequently, an exponent of the already mentioned direct ratio of the same qualities whose reciprocal quantitative relation is at the same time specifically determined by the ratio. In the example of measure that we have used, that of the 21.344 motion of falling bodies, this direct ratio is, as it were, anticipated and assumed as given, but, as remarked, in this motion it still does not have concrete existence. However, that matter is now realized, in that its sides are both measures, one distinguished as immediate and external, and the other as internally specified, while measure itself is the unity of the two. This constitutes a further determination. As the unity of its two sides, measure contains the relation in which the magnitudes, by virtue of the nature of the qualities, are posited as determined and non-indifferent. Its determinateness, therefore, is entirely immanent and self-subsisting, and has at the same time collapsed into the being for itself of an immediate quantum, the exponent of a direct ratio. In this, the self-determination of measure is negated, for in this immediate quantum, its other, measure has a final self-existent determinateness. Conversely, the immediate measure which ought to be internally qualitative assumes truly qualitative determinateness only in that other. This negative unity is real being for itself, the category of a something which is the unity of qualities in a relation of measure, a complete self-subsistence. The two resulting diverse relations also immediately yield a twofold existence, or, more precisely, that self-subsisting whole, as a being that exists for itself, is as such in itself a repulsion into distinct self-subsisting somethings whose qualitative nature and subsistence, materiality, lies in their determinateness of measure. 12. See Aristotle, Sophistical Refutations, 164b27, 165a2. 13. Measuring something equals et was de masses, literally, the something of the measure. For example, temperature is the specifying measure of the otherwise indifferent magnitude of water. The latter is specified as hot or cold to some degree or other, hot and cold being the measuring something. But this specification is done according to that same measure as specified in some other magnitude, i.e., some other concrete existence in general, for instance, mercury. 14. i.e., each measure, as a concrete something, feet, inches, etc., is in principle measurable by some other measure which is, however, left indeterminate. 15. Cf. above, 21,213. 16. Cf. above, 21,275, 318 to 320. OC Encyclopedia of the Philosophical Sciences. Remark at section 270, concerning the transformation of Kepler's into Newton's, inasmuch as the fraction is called the force of gravity. 17. From the center. 18. i.e. Philosophiae Naturalis Principia Mathematica. 19. Cf. above, 21,272. Chapter 2 Real Measure, 21, 345. Measure is now determined as a connection of measures that make up the quality of distinct self-subsisting somethings, or, in more common language, things. The relations of measures just considered belong to abstract qualities like space and time. Further examples of these now to be considered are specific gravity and then chemical properties, that is, determinations of concrete material existence. Space and time are also moments of these measures, but are now subordinated to other determinations and no longer behave relative to one another only according to their own conceptual determination. In the case of sound, for instance, the time within which a certain number of vibrations occur, the spatial width and thickness of the sounding body, are moments of its determination. But the magnitudes of such idealized moments are externally determined. They no longer assume the form of a ratio of powers but relate in the usual direct way. and harmony is reduced to the strictly external simplicity of numbers and relations which are most easy to grasp. They therefore afford a satisfaction which is the exclusive reserve of the senses, for there is nothing there of representation, imagery, thought, or the like, that would satisfy spirit. Since the sides which now constitute the relation of measure are themselves measures, but at the same time real somethings, their measures are, in the first instance, immediate measures, and the relations in them direct relations. We now have to examine the further determination of the relation of such relations. Measure, now real measure, is as follows. First, it is the independent measure of a type of body, a measure which relates to other measures, and, in thus relating to them, specifies them as well as their self-subsistent materiality. This specification, as an external connecting reference to many others in general, 21.346 produces other relations, and consequently other measures. The specific self-subsistence, for its part, does not remain fixed in one direct relation but passes over into specific determinacies, and this is a series of measures. Second, the direct relations that thus result are in themselves determinate and exclusive measures, elective affinities. 20. But because they are at the same time only quantitatively different from one another, what we have is a progression of relations which is in part merely external, but is also interrupted by qualitative relations, forming a nodal line of specifically self-subsisting things. Third, what emerges in this progression for measure, however, is the measureless. The measureless in general, and more specifically, the infinitude of measure in which the mutually exclusive forms of self-subsistence are one with each other, and anything self-subsistent comes to stand in negative reference to itself. The relation of independent measures. By measures we no longer mean now merely immediate measures, but measures that are self-subsistent because they become within themselves relations which are specified, and in this being for itself they are thus a something, things that are physical and at first material. However, the whole, which is a relation of such measures, is at first itself immediate. Thus the two sides, which are as such independent measures, have their subsistence in things external to each other, and are posited in combination externally. But the self-subsistent materialities are what they qualitatively are only in virtue of the quantitative determination that they have as measures, and are posited in virtue of this same quantitative connection with others as non-indifferent from them, the so-called affinity. They are the members of a series of such quantitative relations. This indifferent multifarious relating concludes at the same time by cutting itself off as an exclusive being for itself, the so-called elective affinity. 21,347. Combination of two measures. As a measure relation, something is in itself determined by quanta to which further qualities accrue. The something is the connection of such qualities. One of them is the something's in itselfness, according to which it is something that exists for itself, something material, a weight, if taken intensively, or, taken extensively, an aggregate of parts. The other is, however, the externality of this itselfness, something abstract and idealized, space. These qualities are quantitatively determined, and their mutual relation is what constitutes the qualitative nature of the material something, the ratio of weight to volume, the specifically determined gravity. The volume, the idealized element, is the one to be taken as unit, whereas the intensive aspect, which in quantitative determinateness and in comparison with the other appears as extensive magnitude, that is, an aggregate of ones existing for themselves, is the amount. The purely qualitative relating of the two determinacies of magnitude in a ratio of powers has disappeared, because with the self-subsistence of the being for itself, the material being, immediacy has come back, and in this immediacy the determinateness of magnitude is a quantum whose relation to the other side is likewise determined in the ordinary exponent of a direct ratio. This exponent is the specific quantum of the something, but it is an immediate quantum, and this is determined, as is also the specific nature of the something, only in being compared with other exponents of like ratios. The exponent constitutes the specific way in which the something is determined in itself, the inner measure characteristic of it. But since this, the something's measure, rests on a quantum, it is also an external and indifferent determinateness, and the something, despite its inner determination as measure, is for this reason subject to alteration. The other to which it can relate as alterable is not an aggregate of matters, not a quantum in general. On the contrary, against these it holds out its specific intrinsic determination of being. Rather, it is a quantum which is at the same time it too the exponent of such a specific ratio. Take two things of different inner measure that stand connected and enter into composition, say, two metals of different specific gravity. In what way the two must otherwise be homogeneous in nature in order for the composition to be possible, e.g. that we cannot be speaking here of a metal combining with water, this is not at issue here. Now, on the one hand, each of the two measures preserves itself in the alteration they will incur because of the externality of quantum, for each is a measure. But, on the other hand, this self-preservation is itself a negative relating to the quantum, a specification of it, and, since this quantum is the exponent of the 21.348 ratio of measure, the self-preservation is an alteration of the measure itself, and indeed a reciprocal specification. According to its merely quantitative determination, the compound would be the mere sum of the two magnitudes of the one quality and the two magnitudes of the other quality, e.g. the sum of the two weights and the two volumes in a compound of two matters of different specific weights, so that not only would the weight of the mixture remain equal to the said sum, but also the space which the mixture occupies would remain equal to the sum of the two spaces. But only the weight of the mixture is found to be in fact the sum of the weights present prior to combination. The side capable of addition is the one which, as the one existing for itself, has attained stability of being and consequently a permanent immediate quantum, the weight of matter, or, what amounts to the same thing from a quantitative standpoint, the aggregate of material parts. Alteration falls instead in the exponents, for they are the expression of the qualitative side of the compound, of its being for itself as relations of measure, and, since the quantum as such is subject to accidental alteration by an increase which is summed, this being for itself proves at the same time to be a negating factor with respect to this externality. Since this immanent determining of the quantitative element cannot appear, as we have seen, in the weight, it turns up in the other quality, which is the idealized side of the relation. It might be surprising to sense perception that, upon the mixing of two specifically diverse materials, what results is an alteration of the total volume, normally a diminution of it, for it is space which gives stability to matters otherwise existing outside one another. But this stability, in face of the negativity which is in the being for itself, is that which has no existence in itself, is the alterable as such. In this manner, space is posited as what it is in truth, an idealization. But then, not only is one of the qualitative sides posited as alterable, but measure itself, and so also the qualitative determinateness of the something which is based on it, has shown itself not to be something stable within, but, like quantum in general, to have its determinateness in other measure relations. Measure as a series of measure relations. If something united with an other were what it is only by virtue of simple qualitative determination, and the same also applied to the other, then the two would only sublate themselves in being compounded. But when something is in itself a measure relation, it is independent, yet at the same time capable of union with another which is also in itself a measure relation. For in being sublated in union, each preserves itself through the permanence of its quantitative indifference, and at 21.349 behaves as the specifying moment of a new measure relation. Its quality is enveloped in the quantitative element. It is therefore equally indifferent towards the other measure, continuing in it, and in the newly formed measure. The exponent of the new measure is itself only some quantum or other, an external determinateness, and its indifference is displayed by the fact that the specifically determined something runs, with other such measures into precisely the same kind of neutralizations of reciprocal measure relations. The specific property of the something is not expressed in the one measure relation alone, which is formed by it and another something. This combination with a plurality of others which are in themselves likewise measures yields different ratios that therefore have different exponents. The measure which is independent has the exponent of its being determined in itself only in the comparison with other measures. Neutrality with the others constitutes, however, its real comparison with them. It is its comparison with them through itself. The exponents of these ratios are, however, diverse, and the independent measure consequently displays its qualitative exponent as the series of these different amounts of which it is the unit, a series of specific ways of relating to others. As one immediate quantum, the qualitative exponent expresses one single relation. The independent measure truly differentiates itself in the characteristic series of exponents which it, taken as a unit, forms with other equally independent measures. For each of these measures, also brought in connection with any other and taken as a unit, forms another series. The relation of such series among themselves now constitutes the qualitative aspect of the independent measure. Now, inasmuch as this independent measure produces a series of exponents with a series of such independent measures, it appears at first, when compared with another independent measure outside this series itself, that it is differentiated from it by virtue of the fact that this other independent measure produces another series of exponents with the same measures opposite to it. But in this way these two independent measures would not be comparable, not insofar as each is regarded as a unit with respect to its exponents, and the two series thus resulting 21.350 on the basis of this connection of unit and exponents do not differ in any determinate way. The two measures which, as independent, are supposed to be compared, are at first differentiated from each other only as quanta. In order that their ratio be determined, the ratio requires a unit which exists for itself and is common to both. This determinate unit is to be sought, as shown, only where the specific existence of the two independent measures to be compared is to be found, namely in the ratio which the exponents of the ratio of the series have to each other. But this ratio of the exponents is itself a unit existing for itself, and in fact determinate only in so far as the members of the series have it as a constant ratio between them. In that way it can be their common unit. In it alone, therefore, lies the possibility of comparing the two independent measures which were assumed not to neutralize each other, but to be rather reciprocally indifferent. Each, taken by itself outside the comparison, is the unit of the ratios that it establishes with the opposite members. These are the amounts relative to this unit, and hence represent the series of exponents. But conversely, this series is the unit for the two independent measures which when compared with each other are as quanta to each other. As such they are themselves different amounts of their just indicated unit. But further, the measures which together with the two, or rather indefinitely many reciprocally opposing and contrasting measures yield the series of the exponents of the ratio of these same measures, are equally independent in themselves. Each is a specific something with its own relevant measure relation. To this extent, they are similarly to be taken each as a unit, so that they have a series of exponents in the two, or rather the indeterminate plurality of measures, which are first named and compared only among themselves. And these exponents are the comparative numbers of precisely these named measures. Conversely, the comparative numbers of the independent measures now taken singly are similarly the series of the exponents for the 21.351 members of the first series. In this way, both sides are a series in which, first, each number is simply a unit with respect to the opposite series in which it has its specifically determined being as a series of exponents. Second, each number is itself one of the exponents for each member of the opposite series. And third, it is a comparative number for the rest of the numbers of its series, and, as such an amount which belongs to it also as an exponent, it has its unit, determined for itself, in the opposite series. In this relation, there is a return to the mode in which quantum was posited as existing for itself, namely as degree, as being simple and yet having the magnitude of its determinateness in a quantum that exists outside it, one which is a circle of quanta. In measure, however, this externality is not merely a quantum and a circle of quanta, but a series of numerical ratios, and it is in the entirety of these that the being determined for itself of measure lies. Just as it is the case in the being for itself of quantum as degree, the nature of the independent measure has turned into this self-externality. Its self-reference is at first an immediate relation, and by that very fact its indifference to an other lies only in the quantum. Hence its qualitative side falls in this externality, and its relating to the other becomes that which constitutes the specific determination of this independent measure. Such a determination thus consists solely in the quantitative mode of this relating, and this mode is determined just as much by the other as by the measure itself, and this other is a series of quanta while the measure, for its part, is one such quantum. But this connection in which two specific measures specify themselves in a third thing, the exponent, further entails that, in the exponent, the one measure has not gone over into the other, that there is not, therefore, only one negation, but that in the connection the two measures are rather each negatively posited, and since each preserves itself in it indifferently, their negation is itself also negated. This, their qualitative unity, is thus an exclusive unit existing for itself. It is only in this moment of exclusion that the exponents, at first comparative numbers, 21.352, first gain in them the determinateness truly specifying them reciprocally, and their difference thus becomes of qualitative nature. But such a difference has a quantitative basis. First, the independent measure relates to a plurality of its qualitatively other side only because in this relating it is at the same time indifferent. Second, this neutral connection is in virtue of its quantitative basis not only alteration, but is now posited as a negation of the negation and as exclusive unit. Consequently, the affinity of an independent measure with the plurality of measures of the other side is no longer an indifferent connection, but an elective affinity. Elective affinity. The expression elective affinity used here refers to a chemical relation, as also do the preceding neutrality and affinity. For in the chemical sphere a matter receives its specific determinateness essentially in the connection with its other. It exists concretely only as this non-indifference. Moreover, this specific connection is bound up with quantity and is at the same time not only a connection with a single other, but with a series of such non-indifferent matters standing over and against it. Combinations with this series rest on a so-called affinity with every member of the series, even though in this indifference each member excludes every other. We now have to consider this connection of opposite determinations. But it is not just in the chemical sphere that specificity is exhibited in a circle of combinations. The meaning of a single note also depends on its relation to, in combination with, another note and a series of other notes. The harmony or disharmony in such a circle of combinations constitutes its qualitative nature, which is at the same time based on quantitative ratios that form a series of exponents, and the ratios of the two specific ratios is what each of the combined notes is within it. The single note is the keynote of a system, but at the same time also one member in the system of every other note. The 21.353 harmonies are exclusive elective affinities whose characteristic quality, however, equally dissolves again in the externality of a mere quantitative progression. Where to find, however, the principle of a measure for such affinities which among others and against others, whether chemical or musical or whatever, are elective affinities. On this more will be said in the following remark in connection with chemical affinity. But this is a question of a higher order which is very closely bound up with the specific nature of what is strictly qualitative and belongs to particular parts of the concrete science of nature. Inasmuch as the member of a series has its qualitative unity in the way it relates to the whole of an opposite series, the members of which differ from each other only by virtue of the quantum required for being neutralized with that member. The more specific determinateness in this manifold affinity is likewise only quantitative. In elective affinity, which is an exclusive, qualitative connection, the relating escapes this quantitative difference. The next determination which offers itself is this: that in accordance with the difference in the number, hence the extensive magnitudes, of the members of one side required for the neutralization of a member in another side, the elective affinity of this member would be directed to the members of the first series with all of which it has affinity. Thus transformed, the exclusion that would thereby be established in the form of a firmer bonding against other possibilities of combination would appear in a proportionally greater intensity. In keeping with the previously demonstrated identity of the forms of extensive and intensive magnitude, 21 in as much as the determinateness of magnitude is in both one and the same. However, this sudden conversion of the one-sided form of extensive magnitude also into its other, the intensive form, changes nothing in so far as the nature of the fundamental determination is concerned, which is one and the same quantum. In fact, therefore, no exclusiveness would thereby be posited, but instead of one single bonding, a combination of any number of members could just as well take place, provided that the portions of such members entering into the combination corresponded to the required quantum proportionately to the ratios between them. But the combination which we have also called neutralization is not only the form of intensity. The exponent is essentially a determination of measure and, as such, exclusive. On this side of exclusive relating, numbers have lost their continuity and their tendency to combine. Their relating is one of more or less, and this acquires a negative character, and the advantage that one exponent has over another does not remain confined to the determinateness of magnitude. 21.354 also equally present is the other side, which makes it again a matter of indifference to a moment of measure whether it receives its neutralizing quantum from several opposite moments, from each according to the determinateness that specifies it as against another. The exclusive, negative relating is at the same time vulnerable to this incursion of the quantitative side. What is posited here is thus the sudden conversion of an indifferent, merely quantitative relating into a qualitative one, and conversely the transition of a specifically determinate being into merely external relation, a series of relations, sometimes of a merely quantitative nature, sometimes specific relations and measures. Remark: chemical matters are the most characteristic examples of such measures, which are moments of measure and receive their determination solely in relating to other moments. Acids and alkalis or bases generally appear to be things which are immediately determined in themselves, but they are rather incomplete elements of bodies, components which in concreto do not truly exist for themselves, but for which to exist is to sublate their isolated subsistence by binding with some other component. Further, the difference in virtue of which they are self-subsistent consists not in this immediate quality, but in the quantitative mode of the relating. For that difference is not restricted to the chemical opposition of acid and alkali, or base, in general, but is specified rather in a measure of saturation. It consists in the specific way the matters that neutralize each other are quantitatively determined. This quantity determination as defined by saturation constitutes the qualitative nature of a matter. It makes it into what it is for itself, and the number expressing it is essentially one of several exponents for an opposite unit. A matter of this kind has a so-called affinity with another. If this connection remained of a purely qualitative nature, then, like the connection between the 21.355 magnetic or the electrical poles, the one determinateness would be only the negative of the other, and the two sides would simultaneously show themselves not to be indifferent to each other. But since the connection is also of a quantitative nature, each of these matters is capable of neutralizing itself with any of several matters and is not restricted to the one to which it stands opposed. The relation is not just between acid and alkali, or base, but between acids and alkalis, or bases. They do momentarily acquire distinctive character according as one acid, for instance, requires more of an alkali in order to achieve saturation with it than another. But the evidence that they have self-subsistent existence for themselves lies in the relation between the affinities, which is exclusive, one showing that it has a preference over another in that one acid can as such bond with any alkali, and conversely. Thus, the chief difference between two acids depends on whether it has a closer affinity to one base than another, that is, whether it has a so-called elective affinity with it. According to the law which has been found to govern the chemical affinities of acids and alkalis, when two neutral solutions are mixed and the result is a separation followed by two new compounds, these products are likewise neutral. It follows from this that the amounts of two alkali bases required for the saturation of an acid must be in the same ratio for the saturation of another acid. In general, granted an alkali as unit, if the series of numerical ratios in which various acids saturated is established, then this series is the same for any other alkali, except that the various alkalis are to be taken in different relative amounts, and these amounts, for their part, again form an equally stable series of exponents for each of their opposite acids, for they stand to each in just the same ratio as to any other. Fischer was the first to extract these series in their simplicity from the works of Richter. See his notes to the translation of Berthollet's treatise on the laws of affinity in chemistry, page 232, and Berthollet's Statique Chimique, part 1, p. 134 ff. 22. Since these works, our knowledge of the numerical ratios of mixtures of chemical 21.356 elements has been greatly extended in all directions, and to want to review it here would be a digression, all the more so because this empirical and in part also only hypothetical expansion does not exceed the original conceptual framework. We may, however, add a few comments concerning the categories used, as well as concerning the views on chemical affinity itself, and its connection with quantitative determination, and the attempt to base the affinity on specifically determined physical qualities. It is well known that Berthollet modified the broad conception of elective affinity by the concept of the effectiveness of a chemical mass. It is worth noting that this modification does not have any effect on the quantitative ratios of the chemical laws of saturation, but weakens the qualitative moment of exclusive elective affinity as such to the point of sublating it. If two acids and one alkali react, and the one acid of which it is said that it has a greater affinity with the alkali is also present in a quantum sufficient to saturate the quantum of the base, then according to the concept of elective affinity, this is the only saturation that results. The other acid remains quite ineffective, excluded from the neutral bonding. According to the concept of the effectiveness of a chemical mass, on the contrary, each acid is effective in a proportion established on the basis of their given amounts and their saturating capacity or so-called affinity. Berthollet's investigations have identified the more detailed circumstances under which the effectiveness of the chemical masses is sublated in one acid. The one with the stronger affinity seems to drive out the other with the weaker affinity and to shut out its effect, thus to behave in the sense of elective affinity. Berthollet has shown that it is circumstances such as the strength of cohesion, the insolubility in water of the compounded salts, which condition the occurrence of this shutting out, not the qualitative nature of the agents as such, and the effect of these circumstances can in turn be sublated by other circumstances, as for instance by temperature. With the removal of the circumstances, the effectiveness of the chemical mass proceeds unimpeded, and what appeared as a purely qualitative exclusion, an elective affinity, proves to rest on only external modifications. It is Berzelius especially who should be heard further on this subject. 2321.357, but in his textbook of chemistry, he fails to present anything original or more determinate on the matter. Berthollet's views are taken up and repeated word by word, only outfitted with a metaphysics typical of uncritical reflection, and all that we are thus offered for closer inspection is just the categories of this metaphysics. The theory departs from experience and does both. fabricates sense representations such as are not given in experience itself, and applies thought determinations, in either case exposing itself to logical criticism. On this score, we want to take a look at what it says about the theory in the textbook itself, Volume 3, Section 1, Woller's translation, pages 82 ff. 24. We now read there that one must imagine that in a uniformly mixed liquid each atom of the dissolved body is surrounded by an equal number of atoms of the solvent. And if several substances are jointly dissolved, they must share among them the intervening spaces between the atoms of the solvent, so that, granted a uniform mixture of the liquid, a symmetry is produced in the disposition of the atoms in such a way that all the atoms of each individual body find themselves uniformly disposed with reference to the atoms of the other bodies. It could therefore be said that the solution is characterized by the symmetry in the position of the atoms, and the combination by the fixed proportions. The claim is then elucidated by the example of the compounds precipitated from a solution of copper chloride when sulfuric acid is added to it. But surely the example does not demonstrate that atoms exist, or that a number of atoms of the dissolved bodies surround the atoms of the fluid, the free atoms of both acids positioning themselves around those that remain in combination with copper oxide. Or that there is actually a symmetry in their position and disposition, or, for that matter, that there are intervening spaces between atoms. Least of all, that the dissolved substances share among them these intervening spaces between the atoms of the solvent. This would mean that the loose atoms take up their position where the solvent is not, for the intervening spaces in the solvent are spaces void of it. Consequently, that the dissolved substances are not in the solvent but outside it, even though they surround and besiege it or are surrounded and besieged by it, and of course that they are not dissolved by it. One fails to see, therefore, why one would have to entertain such representations which are not evident in experience, are essentially contradictory on the face of it, and remain 21.358 uncorroborated otherwise. Corroboration could come only by a consideration of these representations themselves, that is, by metaphysics, which is logic. But logic does not confirm them any more than experience does. On the contrary, and Berzelius does admit what was also said above, that Berthollet's propositions are not opposed to the theory of determinate proportions. He of course adds that they are also not opposed to the views of corpuscular theory, that is, to the just mentioned images of atoms, of the filling of the intervening spaces in the solvent by the atoms of the solid bodies, and so on. But these are a baseless metaphysics that has essentially nothing to do with the propositions of saturation as such. The essential point expressed by the laws of saturation thus concerns only the amount of units themselves quantitative, not atoms. The units of a body with which the quantitative unit, equally not an atom, of another body chemically different from the first is neutralized. The difference consists in these different proportions alone. When Berzelius, then, despite the fact that his whole theory of proportions is only a determination of amounts, nevertheless speaks of degrees of affinity, e.g., page 86, in explaining Berthollet's chemical mass as the sum of the degree of affinity resulting from the given quantity of the active body, whereas Berthollet is more consistent in using the expression capacite to saturation. He thereby himself lapses into the form of intensive magnitude. But this is the form characteristic of the so-called dynamic philosophy, which he earlier calls the speculative philosophy of certain German schools, page 29, Locke. Sit, and vehemently rejects in favor of the superb corpuscular theory. Of this dynamic philosophy, he states in the same passage that it assumes that the elements interpenetrate one another in their chemical union, and that the neutralization consists in this reciprocal interpenetration. This means nothing else than that the chemically different particles that stand opposite as aggregate merge into the simplicity of an intensive magnitude, something also attested by the diminution of volume. In the corpuscular theory, on the contrary, the chemically bonded atoms are also supposed to be retained in the intervening spaces, that is, outside each other, juxtaposition. In this relationship, which is one of only extensive magnitude, of never-ending aggregation, degree of affinity has no meaning. Still in the same place, when it is said that for the dynamic viewpoint the phenomena of determinate proportions were quite an unforeseen event, the answer would be that this is only an external, historical circumstance. Were it not that Richter's stoichiometric series were already known to Berthollet from Fisher's summary and were cited in the first edition of this Logic 25, where the nullity of the categories on which the old, as well as the would-be new corpuscular theory rest is demonstrated. But Berzelius is wrong 21.359 inches believing that on the dynamic view, the phenomena of specific proportions would have remained forever unknown, meaning that that view is incompatible with the determinateness of proportions. This determinateness is in all cases only one of magnitude, whether in an extensive or an intensive form, so that, regardless of how much he stands by the first of these forms, that of aggregation, even Berzelius himself uses the representation of degrees of affinity. Since the affinity is thereby reduced to a quantitative distinction, it is sublated as elective affinity, but the moment of exclusivity present in it is traced back to circumstances, that is, to determinations that appear to be external to the affinity, to cohesion, to the insolubility of the compounds produced, and so on. Some comparison can be drawn here with the treatment of the effect of gravity on the moving pendulum. The pendulum necessarily comes to a state of rest because of the direct effect of gravity, yet this same effect is taken as due to the concomitant external circumstance of air resistance, thread, etc., and is ascribed to friction alone instead of gravity. Here, so far as the nature of the qualitative element present in elective affinity goes, it makes no difference whether this element appears in the form of circumstances conditioning it, and is so interpreted. A new order begins with the qualitative element as such, the specifying of which is no longer just a quantitative distinction. Accordingly, although there is a well-established and precise difference between chemical affinity in a series of quantitative ratios and elective affinity as an emerging qualitative determinateness, the behavior of which in no way coincides with the order of that series, this difference has again been thrown into utter confusion by the way in which chemical behavior has in recent times been combined with electrical behavior, and the hope of explaining from this supposedly profounder principle, the most important of relations, that of measure, has been wholly disappointed. Inasmuch as this theory in which the phenomena of electricity and of chemism are fully identified deals with things physical and not just with ratios of magnitude, we need not consider it here in close detail. We only have to bring it up in as much as it confuses the principle for differentiating the determinations of magnitude. The theory deserves to be called shallow, for shallowness consists in taking different things as identical by omitting their difference. As for affinity, since the theory identifies chemical with electrical processes, these last including the phenomena of fire and light, 21.360 it is reduced to the neutralization of opposite electricities. It is almost comical to find the identification itself of electricity and chemism stated as follows. Locke cit. Page 63. The electrical phenomena indeed explain the effect of bodies at a greater or lesser distance, their attraction before union, that is, a behavior which is not yet chemical, as well as the fire, resulting from this union. But they yield no information regarding what causes the union of bodies which persists with so great a strength after the removal of the state of electrical polarization. That is, the theory informs us that electricity is the cause of chemical behavior, but gives us no information regarding what is chemical in the chemical process. The chemical difference being reduced to the opposition between positive and negative electricity, the difference in affinity between the agents falling on either side is determined as the order of two series of electropositive and electronegative bodies. What is already being overlooked in this overall identification of electricity and chemism is that electricity in general, and its neutralization, is a transient phenomenon, one that remains external to the quality of bodies, whereas chemical action, and especially its neutralization, is directed to and alters the whole qualitative nature of the bodies. Equally transient in electricity is its opposition of positive and negative, so unstable that it is subject to the slightest external circumstances and can in no way be compared to the determinateness and stability of the opposition of acids to metals, for example, and so forth. The volatility that can occur in chemical behavior because of extremely violent influences, e.g. because of raised temperature, is not comparable to the superficiality of electrical opposition. And the further difference inside the series of each of the two sides, between a more or less positive or a more or less negative disposition, is just as entirely uncertain as it is entirely unconfirmed. Yet it is from these series of bodies, Berzelius, Locke cit. p. 64 ff. In accordance with their electrical dispositions, that we can expect the electrochemical system which is best suited to yield an idea of chemistry. But how these series which are only alleged here are in fact constituted. Regarding this point, it is added on page 67 that such is approximately the order of these bodies, but so little research has been done into this matter that 21.361 nothing altogether certain can yet be ascertained regarding this relative order. Both the numerical ratios, first made by Richter, of the series of affinities as well as the highly interesting reduction established by Berzelius of the combinations of two bodies to the simplicity of a few quantitative ratios, are totally independent of that supposed electrochemical concoction. If the experimental procedure has been the right guiding star in the theory of proportions and the extension it has won on all sides since Richter, then all the more does the mixture of these great discoveries contrast with the wasteland of the so-called corpuscular theory, which lies outside the path of experience. Only this forsaking, at the start, of the principle of experience could have motivated taking up again the notion, already advanced earlier especially by Ritter, 26 of establishing fixed orders of electropositive and electronegative bodies, which would have chemical meaning at the same time. The assumption of a basis for chemical affinity in the opposition of electropositive and electronegative bodies, even if such an opposition had more to recommend it factually than it does, reveals its nullity even experimentally, and this then leads to further inconsistency. It is admitted on page 73, Locke cit. 27 that two so-called electronegative bodies such as sulfur and oxygen combine in a much more intimate way than, for instance, oxygen and copper, although the latter is electropositive. The basis for the affinity founded on the general opposition of negative and positive electricity must here give way, therefore, to a mere more or less within one and the same series of electrical determinateness. From this, it is concluded that the affinity of bodies does not therefore depend solely on their specific unipolarity. It does not matter with which hypothesis this determination is associated. It applies here only for the either of the positive and the or of the negative. The affinity must in essence be derived from the intensity of their polarity in general. Here the consideration of affinity thus broaches the relation of elective affinity, which is our principal interest. Let us now see how it fares. It is immediately granted, Locke cit. page 73, that the degree of this polarity, if it does not exist only in our imagination, seems not to be a constant quantity, but to depend rather very much on temperature. Accordingly, the upshot is not only that every chemical effect is fundamentally an electrical phenomenon, but also that what seems to be the effect of the 21.362 so-called elective affinity is produced only by an electrical polarity, which in certain bodies is found to be stronger than in others. The conclusion, then, after so many twists and turns of hypotheses, is that we have not gone past the category of greater intensity, which is the same formal determination as elective affinity in general. And since the latter is made to rest on a greater intensity of electrical polarity, it does not take us a whit closer to a physical basis. But even what is here supposed to be determined as a greater specific intensity is later reduced to just the already cited modifications which Berthollet demonstrated. Berzelius's merit and fame because of his theory of proportions, which has been extended to all chemical relations, ought not by themselves to stand in the way of criticizing the poverty of the theory, but a more pressing reason for doing so must be the circumstance that the merit which one side of a science deserves, such as Newton's, normally lends authority to a whole unfounded structure of bad categories associated with it. And it is precisely this metaphysics which is proclaimed and circulated with the greatest pretension. Besides the forms of measure relation connected with chemical and affective affinity, others could also be considered with respect to quantities which are qualitatively specified into a system. Chemical bodies form a system of relations with respect to saturation. The saturation itself rests on the determinate proportion in which the two reciprocal amounts bind together, each with a particular material concrete existence as against the other. But there are also measure relations, the moments of which are indivisible and cannot be displayed as existing each on its own, each different from the other. These are what we called earlier 28 the immediate independent measures and are attested in the specific weights of the bodies. They are inside the bodies a ratio of weight to volume. The exponent of the ratio, which defines the difference between one specific weight and another, is a determinate quantum only by way of comparison, and this is a relation which is external to the bodies, founded on external reflection and not on a body's typical qualitative way of relating to an opposite concrete existence. The task would be 21.363 to make out the exponents of the ratios of the series of specific gravities as a system governed by a rule specifying an otherwise merely arithmetical plurality as a series of harmonic notes. The same demand would apply to the discovery of the series of the chemical affinities already mentioned. But science still has far to go before reaching this goal, just as far as would be required to collect the numbers of the distances of the planets within the solar system into a system of measure. Although the specific gravities do not seem at first to stand in any qualitative relation to one another, they nonetheless likewise enter into qualitative connection. When bodies bond chemically, even if only as amalgams or synsomates, there is likewise evidence of a neutralization of specific gravities. We earlier 29 called attention to the phenomenon that the volume of a mixture, even of materials which truly remain chemically indifferent to each other, is not the same as the sum of the volumes prior to the mixture. In the mixture, the quantum of the specific gravity with which the materials entered into connection is reciprocally modified, and this is evidence that they relate to each other qualitatively. Here the quantum of the specific gravities is expressed not merely as a fixed comparative number, but as a numerical ratio which is variable. And the exponents of the mixtures yield series of measures which are governed by some other principle than the numerical ratios of the specific gravities bonded together. The exponents of these ratios are not exclusive determinations of measure. Their progression is continuous, but holds within it a specifying law which is different from the reflectively formal progression of the ratios, in which the amounts are combined, and makes the former progression incommensurable with the latter. 21,364. Nodal lines of measure relations. The last determination of the measure relation was that, as specific, it is exclusive. Exclusiveness accrues to neutrality as a negative unity of the distinct moments. For this unity existing for itself, for this elective affinity, no further principle has become available specifying its connection with other neutralities. The specification resides only in the quantitative determination of affinity in general, according to which it is specific amounts that neutralize themselves and consequently stand opposed to other relative elective affinities of their moments. But further, because the basic determination is quantitative, the exclusive elective affinity continues also into these opposite neutralities, and this continuity is not just an external comparative connection of the different ratios of the neutralities, but the neutrality, as such, has an element of separability in it, for it is as self-subsisting somethings that the moments from whose union it has come to be enter into connection with one or the other of the opposite series. They enter into the connection indifferently, even though they combine in different specific determinate amounts. This measure, internally based on such a relation, is for this reason affected by an indifference of its own. It is something which is external within and alterable in its reference to itself. This self-reference of the measure relation differs from the externality and alterability which belong to its quantitative side. In contrast to these, its self-reference is an existent qualitative foundation, a permanent, material substrate which, since it is also the continuity of the measure with itself in its externality, would have to contain in its quality the said principle of specification of this externality. Now in more developed form, as external to itself in its being for itself, the exclusive measure repels itself from itself and posits itself both as another merely quantitative relation and as another relation which is as such at the same time another measure. It is determined as in itself a specifying unity which produces measure relations within itself. These relations differ from affinities of the kind mentioned above, in which an independent measure relates itself to independent measures of another quality and to a series of these. They occur in one and the same substrate within the same moments of the neutrality. The 21.365 self-repelling measure takes on the determination of other only qualitatively diverse relations, and these relations likewise form affinities and measures, alternating with those that remain only quantitative diversities. They form in this way a nodal line of measures on a scale of more and less. Here we have a measure relation, a self-subsistent reality qualitatively distinguished from others. Such a being for itself, since it essentially is at the same time a relation of quanta, is open to externality and quantitative alteration. It has a margin within which it remains indifferent to this alteration and does not alter its quality. But there comes a point in the quantitative alteration at which this quality alters, and the quantum shows itself to be specifying, so that the altered quantitative relation is suddenly turned into a measure and thereby into a new quality, a new something. The relation that has now replaced the first is determined by the latter, both because of the qualitative sameness of the moments which are in affinity and because of the quantitative continuity. But since the distinction falls on the side of this quantitative moment, the new something stands indifferently related to the preceding one. The difference between the two is the external one of quantum. The new something has not therefore emerged out of the preceding one. It has emerged rather immediately from itself, that is, from the internal specifying unity which has not yet entered into existence. The new quality or the new something is subjected to the same progression of alteration, and so on, into infinity. Inasmuch as the advance from a quality proceeds in the steady continuity of quantity, the ratios approaching the one qualifying point are distinguished, quantitatively considered, by a more or less. In this respect, the alteration is a gradual one. But the gradualness concerns merely the externality of the alteration, not its qualitative moment. The preceding quantitative relation, 21.366, though infinitely near to the succeeding one, is still another qualitative existence. From the qualitative side, therefore, the gradual, merely quantitative progression which has no limits in itself, is absolutely interrupted. And since in its merely quantitative connection the newly emerging quality is with respect to the vanishing one an indeterminate other, one which is indifferent to it, the transition is a leap. The two are posited as wholly external to each other. It is a favorite practice to try to make an alteration conceptually comprehensible by the gradualness of the transition leading up to it. But gradualness is rather alteration precisely as merely indifferent, the opposite of a qualitative alteration. Rather, in gradualness the connecting link between two realities, be they states or self-subsistent things, is sublated. What is posited is that neither reality is the limit of the other, but that each is absolutely external to the other. Thus, the very point necessary for the conceptual comprehension of the alteration is missed, although little enough is required for that purpose. Remark. The system of natural numbers already exhibits a nodal line of qualitative moments which issue in a merely external progression. In one respect, this progression is a merely quantitative running back and forth, a constant adding and subtracting, each number standing in the same arithmetical relation to the one preceding or following it, as this last stands to the one preceding or following it in turn, and so on. But the numbers that thus arise also stand to the others that either precede or follow them in some specific relation, whether as a multiple of one of them expressed in the form of a whole number, or as a power or root. In the quantitatively measured scale of musical relations, a quantum 30 gives rise to a relation of harmony in the progression of notes, without that quantum having on the scale any other relation to the preceding and the succeeding ones than these have in turn to those preceding and following them. The notes that follow seem increasingly to recede from the keynote, or numbers to become just other numbers in their arithmetical advance. Yet a turning back suddenly breaks out, a surprising accord 21.367 for which there was no qualitative preparation in what immediately went before, but which appears rather to be an actio in distans, a connecting reference to something far removed. The succession of merely indifferent relations which neither alter the preceding specific reality nor otherwise form any such reality is suddenly interrupted, and while from the standpoint of quantity the succession proceeds in the same manner, a specific relation breaks in through a leap. Nodes and leaps of this kind occur in chemical combinations as the proportions in the mixtures are progressively altered. At certain points on the scale of mixtures, two materials yield products that exhibit particular qualities. These products do not differ by a mere more or less, nor are they already present at the proportions closest to their nodal points, perhaps in an only weaker degree. The bonding rather occurs at just these points. For instance, oxygen and nitrogen yield in combination different oxides of nitrogen and different nitric acids exhibiting essentially different qualities only at specific mixture proportions, without any specific bonding occurring in between. Metal oxides, e.g. the lead oxides, are formed at certain quantitative points of oxidation and are distinguished by colors and other qualities. They do not pass into one another gradually. The proportions lying in between those nodal points yield nothing neutral, no specific existence. A combination which specifically depends on a measure relation occurs without having passed through the in-between stages and displaying qualities characteristically its own. Or take water. As it alters in temperature, it does not become just more or less warm, but passes through the states of solid, liquid, and vapor, and these different states do not occur gradually, but, on the contrary, even the otherwise merely gradual increase in temperature is interrupted and inhibited at these points. The eruption of another state is a leap. Every birth and every death, far from being a protracted gradualness, is rather its breaking off and a leap from quantitative into qualitative alteration. 21,368. Natura non facit saltum, as the saying goes, and ordinary thinking, when confronted by a coming to be or a passing away, believes that it has comprehended it conceptually by representing it, as we said, 31 as a gradual emerging or vanishing. But we have seen 32 that the alterations of being in general are not only the passing over of a magnitude into another magnitude, but the transition from the qualitative into the quantitative and contrariwise, a becoming other that interrupts gradualness and stands over against the preceding existence as something qualitatively other. Water, in cooling, does not become hard a bit at a time, as if it became first like a porridge and would then gradually harden to the consistency of ice, but is hard all at once. It can persist in fluid state even at freezing temperature if it stands still, but then the least disturbance brings it to the state of solid. The belief that coming to be is gradual is based on imagining that what comes to be is already present to the senses or is in principle actual, only so small that it still escapes perception. And so too for the gradual vanishing of something. What is imagined is that the non-being or the other which is to take its place is likewise there, but is not yet detectable. is there, not in the sense that this other is in itself contained in the present other, but that it exists there only undetectably. In this way, coming to be and vanishing are in principle done away with, or the existence which something has in principle, still undisplayed, before actually existing is transformed into a smallness of eternal existence, and the essential conceptual difference into a difference of mere magnitude. Explaining coming to be and vanishing from the gradualness of alteration suffers from the tediousness typical of any tautology. The coming to be and the vanishing are presupposed as ready-made beforehand, and the alteration is reduced to the mere mutation of an external difference, and in this way the change becomes in fact only a tautology. The difficulty confronting an intellect intent on this kind of explanation lies in the qualitative transition from a something into its other in General 21.369 and into its opposite, a difficulty which the intellect meets by pretending that identity and alteration are the indifferent external identity and alteration of the quantitative sphere. In moral matters, inasmuch as they are treated in the sphere of being, there occurs the same transition of the quantitative into the qualitative. Different qualities appear to be based on a difference of magnitude. It is by a more and less that the measure of frivolous delinquence is overstepped, and something entirely different comes irresistibly the scene, namely crime, which makes right into wrong and virtue into vice. Thus states, too, acquire through their quantitative difference, other things being assumed equal, a different qualitative character. The laws and the constitution of a state alter in character whenever its territory and the number of its citizens expand. A state has its own measure of magnitude, and, if this measure is trespassed, it irresistibly disintegrates internally under the same constitution which, when with just different proportions, was the source of its good fortune and strength. The measureless. The exclusive measure, even in its realized being for itself, remains affected by the moment of quantitative existence and is therefore susceptible to the movement up and down the quantum scale of varying ratios. Something, or a quality, based on such a ratio is driven beyond itself into the measureless, collapsing under the mere mutation of its magnitude. Magnitude is that constitutional aspect where an existence can be caught up in an apparently harmless entanglement and be destroyed by it. The abstract measureless is the quantum in general in as much as it lacks internal order and is only in different determinateness, which does not alter measure. In the nodal lines of measures, this determinateness is at the same time posited as specifying. The abstract measureless sublates itself into qualitative determinateness. The new measure relation into which the original passes over is measureless with respect to the latter 21.370, but, in it, it equally is a quality that exists for itself. What is thus posited is the alternation of specific existences with one another, and equally of them with relations that still remain merely quantitative, on alternation ad infinitum. Therefore, present in this transition is both the negation of the specific relations and the negation of the quantitative progression. This is the infinite existing for itself. In the sphere of existence, the qualitative infinite was the eruption of the infinite into the finite, the immediate transition and vanishing of the this here into its beyond there. In contrast to it, the quantitative infinite is in its very determinateness the continuity of quantum, its continuing beyond itself. The qualitatively finite becomes infinite. The quantitatively finite is its beyond in it. It points beyond itself. But this infinite of the specification of measure posits both the qualitative and the quantitative as each sublating itself into the other, and it thereby posits their first immediate unity, which is measure in general, as returned into itself and consequently as itself posited. The transition of the qualitative of one specific concrete existence into another is such that what happens is only an alteration of magnitude determinateness. The alteration of the qualitative as such into the qualitative is thus posited as an external and indifferent alteration, as a coming together with itself. The quantitative, for its part, sublates itself by suddenly turning into the qualitative, that is, a being which is determined in and for itself. This unity, which thus continues in itself in its alternating measures, is the self-subsistent matter that truly persists, the fact. What we have here is alpha, one and the same substantial matter which is posited as the perennial substrate of its differentiations. This detaching of being from its determinateness already begins in quantum in general. Something is great indifferently, as against the determinateness it has. In measure, the persisting matter is itself already in itself the unity of the qualitative and the quantitative, the two moments into which the general sphere of being is distinguished, each as the beyond of the other. In this way, the perennial substrate begins to possess in it the determination of an existent infinity. Beta, this self-sameness of the substrate, is 21.371 posited in that the qualitative independent measures into which the determining unit is dispersed consist of only quantitative differences, so that the substrate persists while being internally distinguished. Gamma. In the infinite progression of the nodal series, there is posited the continuation of the qualitative into the quantitative advance, as into an indifferent alteration, but equally, too, there is posited the negation of the qualitative contained in the progression and consequently, at the same time, of the merely quantitative externality. The quantitative pointing beyond itself to an other which is itself quantitative perishes with the emergence of a measure relation, of a quality, and the qualitative transition is sublated in the very fact that the new quality is itself only a quantitative relation. This reciprocal transition into the other of the qualitative and the quantitative moments occurs on the basis of their unity, and the meaning of this process is only the existence which is the demonstration or the positing that such a substrate does underlie the process and is the unity of its moments. 33. In the series of independent measure relations, the one-sided members of the series are immediate qualitative somethings, specific gravities or chemical materials, bases or alkalis, acids, for instance, and their neutralizations, by which we must understand here also the combinations of materials of different specific gravities, are in turn self-subsistent in themselves exclusive measure relations, mutually indifferent totalities existing for themselves. Such relations are now determined only as nodes of one and the same substrate. The measures and the self-subsistent forms posited with them are consequently demoted to states. Alteration is only the mutation of a state, and that which passes over is posited as remaining the same in the mutation. In reviewing the progressive determination which measure has gone through, the moments of the progression can be summed up as follows. Measure is at first itself the immediate unity of quality and quantity in the form of a common quantum, which is, however, specific. As a determinateness of quantity which does not refer to an other but refers to itself, measure is thus essentially a ratio. Consequently, it also holds its moments as sublated and unseparated in itself. As is always the case in a concept, the difference in the ratio is such that each of its moments is itself the unity of the qualitative and the quantitative moment. The difference is thus real, and it yields a multitude of measure relations which, as formal totalities, are each self-subsistent in themselves. The series which form the two sides of these ratios are for each single member 21.372 the same constant ordering by which the member, as belonging to the one side, relates itself to the whole series standing opposite it. This ordering, although a mere order, a still wholly external unity, demonstrates itself to be, as the eminently specifying unity of a measure which has a determinate being for itself, distinguished from its specifications. But this specifying principle is not yet the free concept, which alone gives its differences an immanent determination. The principle is at first, rather, only a substrate, a matter, for whose differences, in order that they be totalities, that is, that they should have in themselves the nature of their stable, self-equal substrate, there is only available the external quantitative determination, which shows itself at the same time to be a qualitative differentiation. In this self-unity of the substrate, the determination of measure is a sublated determination, its quality an external state determined by quantum. This course is equally the progressive determination of measure and its demotion to a moment. 20. This is a term which was introduced around the middle of the 18th century to describe the tendency of chemical species to combine with some substances in preference to others. Goethe popularized the term by extending its meaning to include human relations in his novella Elective Affinities, 1809. 21 cf. above, 21,212. 22 Ernst Gottfried Fischer, 1754 to 1831, professor of physics at Berlin and translator in 1802 of Claude Berthollet's Recherches sur les lois de l'infinite. He summarized the results of Richter's observations by expounding them in tables in his notes to the translation. Jeremiah Benjamin Richter, 1762 to 1807, assessor of mines and chemist in Berlin. He is responsible for establishing the law of definite proportions, stoichiometry, which was instrumental in formulating the theory of atoms. He first published his views in 3 volumes, Stoichiometrie oder Messkunstchemischer. Elementi, 1792 to 1794. Claude Louis Berthollet, 1748 to 1822, one of the founders of the École Polytechnique and professor at the École Normale Supérieure de Paris. He expounded his view on chemical affinities in 2 volumes, Recherches sur les lois de l'infinite, 1802, and Essai de statique chimique, 1803. 23 Jöns Jacob Berzelius, 1779 to 1848, Swedish chemist responsible for the introduction of modern chemical notation. After being appointed professor at the Karolinska Institute in Stockholm, 1807, he published a 3-volume textbook of chemistry, 1808 to 1828. 24 C. Jöns Jacob Berzelius, Lehrbuch der Chemie, Volume 3, translated by F. Wohler, Dresden, 1827, pages 82 to 83. 25 cf. GW 11, 213. 26 Johann Wilhelm Ritter, 1776 to 1810, born in Silesia, later in life professor at the Bavarian Academy of Science and a member of the Munich Academy of Science. Among his accomplishments, he discovered ultraviolet radiation and formulated the basic concepts of electrolysis and electroplating. Hegel is referring to his textbook, Das elektrische System der Körper, ein Versuch, Leipzig, 1805. 27 Hegel is referring to Berzelius's textbook of chemistry. 28 cf. above, 21,346. 29 cf. above, 21,349. 30 Quantum. 31 cf. above, 21.365 to 366. 32 cf. above, 21,320. 33 This is a reminder, at the end of the dialectic of being, that the task we have been performing all along, and are still engaged in at the moment, is to bring stability to the fluidity of becoming. We first did this with the category of existence, or the being this or that, Dacian. That first determination has now developed into an objective structure with an internal distinction between a permanent substrate and all the other determinations introduced so far under the rubrics of quality and quantity. This distinction will next develop into the distinction between essence and being. Chapter 3 The Becoming of Essence, 21, 373. Absolute indifference. Being is abstract indifference, and when this trait is to be thought by itself as being, the abstract expression indifferentness, 34 has been used, in which there is not supposed to be, as yet, any kind of determinateness. Pure quantity is this indifference in the sense of being open to any determinations, provided that these are external to it, and that quantity itself does not have any link with them originating in it. The indifference which can be called absolute, however, is one which, through the negation of every determinateness of being, of quality and quantity, and of their at first immediate unity, that is, of measure, mediates itself with itself to form a simple unity. Determinateness is in it still only a state, that is, something qualitative and external which has the indifference as a substrate. But that which has thus been determined as qualitative and external is only a vanishing something. As thus external with respect to being, the qualitative sphere is the opposite of itself, and, as such, only the sublating of itself. In this way, determinateness is still only posited in the substrate as an empty differentiation. But it is precisely this empty differentiation which is the indifference itself as result. And this indifference is indeed concrete, in the sense that it is self-mediated through the negation of all the determinations of being. As such a mediation, it contains negation and relation, and what was called state is a differentiation which is immanent to it and self-referring. It is precisely this externality and its vanishing which make the unity of being into an indifference. Consequently, they are inside this indifference, which thereby ceases to be only a substrate, and, within, only abstract. 21,374. Indifference as inverse ratio of its factors. We now have to see how this determination of indifference is posited in the indifference itself, and the latter is posited, therefore, as existing for itself. The reduction of at first independently accepted measure relations establishes their one substrate. This substrate is their continuing into one another and is, therefore, the one indivisible independent measure which is wholly present in its differentiation. Present for this differentiation are the two determinations contained in the measure, quality and quantity, and everything depends on how these two are posited in it. But this is in turn determined by the fact that the substrate is at first posited as result, and, though in its self-mediation, this mediation is not yet posited as such in it. For this reason, it is in the first instance substrate, and, with respect to determinateness, indifference. Consequently, the difference present in it is at first essentially one which is only quantitative and external. There simply are two different quanta of one and the same substrate which would thus be their sum, itself posited as a quantum. But the indifference is this fixed measure, the implicitly existent absolute limit which, as connected to those differences, would not itself be in itself a quantum, and would not in any way enter into opposition with others, whether as sum or also as exponent, be those others sums or indifferences. It is only the abstract determinateness which falls into the indifference. The two quanta, in order that they may be posited in it as moments, are alterable, indifferent, greater or smaller relative to one another. However, inasmuch as they are restricted by the fixed limit of their sum, they are at the same time related to each other not externally, but negatively, and this is now the qualitative determination in which they stand to each other. Accordingly, they stand in inverse ratio to each other. This relation differs from the earlier formal inverted ratio 35 inasmuch as the limit is here a real substrate, and each of the two sides is posited as having to be in itself the whole. According to the qualitative determinacy just stated, the difference is present, further, in the form of two qualities, each of which is sublated by the other, and yet, since the two are held together in the one unity which they constitute, is inseparable from it. The substrate itself, as the indifference, is in itself likewise the unity of the two 21.375 qualities. Consequently, each of the sides of the relation equally contains both sides within itself, and is distinguished from the other by a more of one quality and a less of the other, or conversely. The one quality, through its quantum, only predominates on the one side, as does the other quality on the other side. Thus each side is in it an inverted relation which, as formal, recurs in the two distinguished sides. The sides themselves thus continue into each other also according to their qualitative determinations. Each of the qualities relates itself in the other to itself, and is present in each of the two sides, only in a different quantum. Their quantitative difference is that indifference in accordance with which they continue into each other, and this continuation is the self-sameness of the qualities in each of the two unities. The sides, however, each containing the whole of the determinations and consequently the indifference itself, are thus at the same time posited as self-subsistent vis-a-vis each other. As this indifference, being is now the determinateness of measure no longer in its immediacy, but in the developed manner just indicated. It is indifference because it is in itself the whole of the determinations of being now resolved into this unity. And it is existence as well, as a totality of the posited realization, in which the moments themselves are the totality of the indifference existing in itself, sustained by the latter as their unity. But because the unity is held fast only as indifference and consequently only implicitly in itself, and the moments are not yet determined as existing for themselves, that is, are not yet determined as sublating themselves into unity internally and through each other. What is here present is therefore simply the indifference of the unity itself towards itself as a developed determinateness. This thus indivisible independent measure is now to be more closely examined. It is immanent in all its determinations, and in them it remains in unity with itself and undisturbed by them. But, alpha, since the determinacies sublated in it implicitly remain the totality, they emerge in it groundlessly. The implicit being of indifference and its existence are thus unconnected. The determinacies show up in the indifference in an immediate manner, and the indifference is in each of them entirely the same. The difference between them is thus posited at first as sublated, hence as quantitative. For this reason, therefore, not as a self-repelling, and the indifference not as self-determining, but as having and becoming the determinate being that it has only externally. Beta, the two moments are an inverse quantitative relation, a fluctuating on the scale of magnitude which is not, however, determined by the indifference, which is precisely the indifference of the fluctuation, but only externally. For the determining appeal is made to an other which lies outside the indifference. The absolute, as indifference, has in this respect the second 21.376 defect of quantitative form, namely that the determinateness of the difference is not determined by the absolute itself, just as it has the first defect in that the differences emerge in it only in general, that is, the positing of them is something immediate, not a self-mediation. Gamma, the quantitative determinateness of the moments which are now sides of the relation constitutes the mode of their subsistence. Their existence is by virtue of this indifference withdrawn from the transitoriness of quality. But they do have a subsistence of their own in themselves, one that differs from this quantitative existence, for they are in themselves the indifference itself, each the unity itself of the two qualities into which the qualitative moment splits itself. The difference of the two moments is restricted by the fact that the one quality is posited on the one side with a more and in the other with a less, and the other is posited in inverse order accordingly. Each side is thus in it the totality of the indifference. Each of the two qualities taken singly for itself likewise remains the same sum which the indifference is. It continues from one side into the other without being restricted by the quantitative limit which is thereby posited in it. At this, the determinations come into immediate opposition, an opposition which develops into contradiction, as we must now see. Namely, each quality enters inside each side in connection with the other, and it does so in such a manner that, as has been determined, this connection also is supposed to be only a quantitative difference. If the two qualities are both self-subsistent, something like sensible materials independent of each other, then the whole determinateness of indifference falls apart. Their unity and totality would be empty names. But they are at the same time determined as comprised into one unity, as inseparable, each having meaning and reality only in this one qualitative connecting reference to the other. But now, because their quantitativeness 36 is simply and solely of this qualitative nature, each reaches only as far as the other. If they are assumed to differ as quanta, then the one would reach beyond the other, and would have in this more an indifferent existence which the other would not have. As qualitatively connected, however, each is only in so far as the other is. The result is that they are in equilibrium, so that to the extent that one increases or decreases, the other likewise increases or decreases and would do so in the same proportion. 21,377. On the basis, therefore, of their qualitative connection, there is no question of a quantitative difference or of a more of the one quality. The more by which the one of the two connected moments would exceed the other would be only an unstable determination, or would only be the other itself again. But, in this equality of the two, neither would then be there, for their existence would have to rest on the inequality of their quantum. Each of these supposed factors vanishes, whether the one factor is assumed to exceed the other or to be equal to it. From the standpoint of quantitative representation, the vanishing appears as a disturbance of the equilibrium, one factor becoming greater than the other. The sublation of the quality of the other and its instability are thus posited. The first factor becomes the predominant one as the other diminishes with accelerated velocity and is overcome by it. This in turn constitutes itself as the one self-subsistent factor. With this, however, there are no longer two specific moments as factors, but only the one whole. This unity, thus posited as the totality of the process of determining, itself determined in this process as indifference, is a contradiction all around. It must therefore be posited as this self-sublating contradiction and be determined as subsistence existing for itself, one which no longer has a merely indifferent unity for result, but a unity immanently negative and absolute. This is essence. Remark. The relation of a whole whose determinateness is to be had in the difference in magnitude of factors qualitatively determined against each other is used in the case of the elliptical movement of the celestial bodies. This example displays throughout only two qualities in inverse relation to each other, not two sides each of which would be itself the unity of the two in their inverse relation. The bare fact on which the theory is based is solid enough. But because of this solidity, the consequence to which the theory 21.378 leads is overlooked, namely the wrecking of the bare fact itself on which it is based, or, if this is held on to, as it ought, the trivialization of the theory vis-a-vis it. By ignoring the consequence, the fact and the theory contradicting it are left to rest untroubled side by side. The bare fact is that in the elliptical movement of the celestial bodies their velocity accelerates as they approach perihelion and decreases as they approach aphelion. The quantitative side of this fact has been accurately established by the untiring diligence of observation and, further, it has been reduced to its simple law and formula. All that is legitimately required of a theory has thus been provided. But it did not seem sufficient to the reflection of the understanding. For the purpose of a so-called explanation of the phenomenon and its law, a centripetal and a centrifugal force have been assumed as the qualitative moments of movement along a curved line. Qualitatively, their difference lies in the contrariety of their direction. Quantitatively, granted that the two are unequally determined, in that as one increases, the other is supposed to decrease, and vice versa. And also, in that the relation between the two is suddenly reversed again, for after the centripetal force has been increasing for a length of time, and the centrifugal force has decreased accordingly, a point is reached at which the centripetal force decreases and the centrifugal increases. But what contradicts this way of imagining things is the reciprocal relation of the essentially qualitative determinateness of the two forces, which will simply not allow their being taken apart. For each force has meaning only with respect to the other, and to the extent, therefore, that the one had an excess over the other, to that extent it would have no connection with this other and would not be. If it is assumed that one of them is at one time greater than the other and stood in relation to the smaller precisely as greater, then what was said above applies. 37 namely that the greater would gain absolute predominance, and the smaller would vanish. It is as something vanishing, lacking support, that the latter is being posited, and nothing is altered in this determination by supposing that the vanishing happens only gradually, or that it decreases only as much as the other increases. For the one force that increases is destroyed together with the other that decreases, since it is what it is only to the extent that the other is what it is. It takes but little consideration to see that if 21.379, for example, a body's centripetal force increases as it approaches perihelion, as it is claimed, while the centrifugal force decreases in the same proportion, the latter force would no longer be able to pull the body away from the former and steer it again at a distance from the central body. On the contrary, since the one force has gained the upper hand, the other is overpowered, and the body will be driven with accelerated velocity to its central body. And conversely, if the centrifugal force gains the upper hand when infinitely near to aphelion, it is contradictory that now, right in aphelion, it would be overpowered by the weaker force. Further, it is evident that it is an alien force which would produce this turnabout, and this means that the sometimes accelerating, sometimes decelerating, velocity of the movement cannot be ascertained or, as it is said, explained from the assumed determination of the very factors which were assumed precisely for the sake of explaining this difference. The logical consequence of the vanishing of the force in either direction, and thus of elliptical movement in general, is ignored and obscured because of the undeniable fact that this motion does endure, shifting from accelerating to decelerating velocity. The assumption of the sudden conversion in aphelion of the weakness of the centripetal force into the predominating strength of the centrifugal force, and of the converse in perihelion, implies for one thing our earlier result, namely that each of the two sides of the inverse relation is in it the whole inverse relation. For the side of the motion from aphelion to perihelion, that is, the side where the centripetal force is taken to predominate, is still supposed to contain the centrifugal force, though in decreasing proportion as the other increases. And, on the side of the retarded motion, the predominant and ever more predominating centrifugal force is supposed to be present in an exact inverse relation to the centripetal, so that on neither side does one of the two forces ever vanish but only becomes smaller up to the moment of its sudden conversion into the predominant force. All that thus transpires on each side is the defect typical of an inverse relation, in this case namely, that either each force is taken to be self-subsistent for itself, but then the two forces merely join in a movement externally, as in the parallelogram of forces, and the unity of the concept, the nature of the thing itself, is consequently done away with, or, since each relates to the other qualitatively by virtue of the concept, neither can attain in face of the other the indifferent, independent subsistence which a more supposedly imparts to it. The form of intensity, the so-called 21.380 dynamic factor, changes nothing, because it too has its determinateness in quantum and hence can express force, that is, has concrete existence, only to the extent that it is confronted by an opposing force. But this same sudden conversion of a predominating force into its opposite also implies the alternation of the qualitative determination of positive and negative, the increase of the one being just as much the loss of the other. But the theory breaks up the indivisible qualitative bond of this qualitative opposition into a temporal succession and consequently begs the explanation of the qualitative alternation and, most of all, of the breaking up itself. There is no trace left here of the semblance of unity which is still to be found in the increase of the one side accompanied by the corresponding decrease of the other. All that we have is a merely external succession which contradicts what the bond between the two entails, namely that as one predominates, the other must disappear. The same relation has been applied to the forces of attraction and repulsion for the purpose of understanding the different densities of bodies. Also, the inverse relation of sensibility and irritability has been enlisted in order to understand, from the inequality of these factors of life, the different determinations of the whole, health, as well as the differentiation of living things into species. This kind of explaining was supposed to become in the philosophy of nature the basis for physiology, nosology, and then zoology. But the confusion, The verbal nonsense into which it became entangled because of the uncritical use of these conceptual determinations quickly led to the abandonment in these areas of philosophy of this formalism, though it is widely practiced in science, especially physical astronomy. Since absolute indifference may seem to be the fundamental determination of Spinoza's substance, we may further remark that this is indeed the case to the extent that in both all the determinations of being, like in general every further concrete differentiation of thought and extension, etc., are posited as vanished. It is simply a matter of indifference what anything might have looked like in existence before being swallowed up in this abyss of abstraction if one stops short at it. But substance, as indifference, is obligated on one side by the need of determining it, and of taking 21.381 this need into consideration. Substance ought not to remain Spinoza's substance, the sole determination of which is the negative one that everything is absorbed into it. Differentiation occurs with Spinoza quite empirically: attributes, thought and extension, and then modes, effects, and all the remaining. The differentiation falls to the intellect, itself a mode. The connection of the attributes to substance and to each other says no more than that they express the whole of substance, that their content, the order of things as extended and as thoughts, is this same substance. But by the determination of substance as indifference, difference itself now becomes a topic of reflection and is now explicitly posited as it de facto is in Spinoza, namely as an external and therefore, more precisely, a quantitative difference. The indifference does remain, just like substance, immanent in the differentiation, but abstractly, only in itself. The difference is not immanent in the indifference, but, being quantitative, is rather the opposite of immanence, and the quantitative indifference is rather the self-externality of the unity. Thus the difference is also not conceptually grasped qualitatively, and the substance is not determined as self-differentiating, as subject. The immediate consequence, so far as the category of indifference itself is concerned, is that in it the differentiation of qualitative and quantitative determination falls apart, just as was our result when developing the category itself. 38. Whereas in measure both moments were immediately posited as one, indifference is the dissolution of measure. Transition into essence. Absolute indifference is the final determination of being before the latter becomes essence, but it does not attain essence. It shows that it still belongs to the sphere of being because it is still determined as indifferent, and therefore difference is external to it, quantitative. This externality is its existence, by which it finds itself at the same time in the opposition of being determined over against it as existing in itself. 39. Not as being thought as the absolute that exists for itself. Or again, it is external reflection which insists that specific determinations, whether in themselves or in the absolute, 21.382, are one and the same, that their difference is only an indifferent one, not a difference in itself. What is still missing here is that this reflection should sublate itself, that it would cease to be the external reflection of thought, of a subjective consciousness, but that it would be rather the very determination of the difference of that unity, a unity which would then prove itself to be the absolute negativity, the unity's indifference towards itself, towards its own indifference no less than towards otherness. But this self-sublation of the determination of indifference has already manifested itself. In the progressive positing of its being, it has shown itself on all sides to be contradiction. Indifference is in itself the totality in which all the determinations of being are sublated and contained. Thus it is the substrate, but at first only in the one-sided determination of being in itself, and consequently the differences, the quantitative difference and the inverse ratio of factors, are present in it as external. As thus the contradiction of itself and its determinateness, of its implicitly existent determination and of its posited determinateness, it is the negative totality whose determinacies have internally sublated themselves, consequently, have also sublated the one-sidedness of their substrate, their in-itselfness. Indifference, now posited as what it in fact is simple and infinitely negative self-reference, the incompatibility of itself with itself, the repelling of itself from itself. Determining and being determined are not a transition, nor an external alteration, nor again an emergence of determinations in it, but its own referring to itself, which is the negativity of itself, of its in-itselfness. But as so repelled, the determinations are not self-possessed, do not emerge as self-subsistent or external, but are rather as moments. First, as belonging to the unity whose existence is still only implicit, they are not let go by it, but are rather borne by it as their substrate and are filled by it alone. And second, as determinations immanent to the unity as it exists for itself, they are only through their repulsion from themselves, instead of some existent or other, as they are in the whole sphere of being. They now are simply and solely as posited, with the sole determination and significance of being referred to their unity and hence each to the other and to negation, marked by this their relativity. Being in general and the being or immediacy of the different determinacies have thereby vanished just as much as the in-itselfness, and the unity is being, immediately presupposed totality, so that it is only 21.383 this simple self-reference, mediated by the sublation of this presupposition, and this presupposedness, the immediate being, is itself only a moment of its repelling. The original self-subsistence and self-identity are only as the resulting infinite self-rejoining, and so is being determined as essence, being which, through the sublation of being, is simple being with itself. 34. Indifference. Indifferentness is recognized in the OED. I use it here because ness is the normal way of creating abstract nouns in English, and in this passage Hegel stresses the abstractness of the term. I shall revert to the more common indifference. 35 cf. above, 21.314 to 318. 36 quantitativitat. 37 cf. above, 21,377. 38 cf. above, 21,377. 39 and succinct. Book 2 The Doctrine of Essence 11,241. Essence. The truth of being is essence. Being is the immediate. Since the goal of knowledge is the truth, what being is in and for itself, knowledge does not stop at the immediate and its determinations, but penetrates beyond it on the presupposition that behind this being there still is something other than being itself, and that this background constitutes the truth of being. This cognition is a mediated knowledge, for it is not to be found with and in essence immediately, but starts off from an other, from being, and has a prior way to make, the way that leads over and beyond being, or that rather penetrates into it. Only inasmuch as knowledge recollects itself into itself out of immediate being, does it find essence through this mediation. The German language has kept essence, Wesen, in the past participle, gewesen, of the verb to be, sein. For essence is past, but timelessly past, being. When this movement is represented as a pathway of knowledge, this beginning with being and the subsequent advance which sublates being and arrives at essence as a mediated term appears to be an activity of cognition external to being and indifferent to its nature. But this course is the movement of being itself, that it is being's nature to recollect itself, and that it becomes essence by virtue of this interiorizing. This has been displayed in being itself. If, therefore, the Absolute was at first determined as being, now it is determined as essence. Cognition cannot in general stop at the manifold of existence, but neither can it stop at being, pure being. Immediately one is forced to the reflection that this pure being, this negation of everything finite, presupposes a recollection and a movement which has distilled immediate existence into pure being. Being thus comes to be determined as essence, as a being in which everything determined and finite is negated. So it is simple unity, void of determination, from which the determinate has been removed in an external manner. To this unity, the determinate was itself something external, and, after this removal, it 11.242 still remains opposite to it, for it has not been sublated in itself, but relatively, only with reference to this unity. We already noted above 1 that if pure essence is defined as the sum total of all realities, these realities are equally subject to the nature of determinateness and abstractive reflection, and their sum total is reduced to empty simplicity. Thus defined, essence is only a product, an artifact. External reflection, which is abstraction, only lifts the determinacies of being out of what is left over as essence, and only deposits them, as it were, somewhere else, letting them exist as before. In this way, however, essence is neither in itself nor for itself. It is by virtue of another, through external abstractive reflection, and it is for another, namely for abstraction, and in general for the existent which still remains opposite to it. In its determination, therefore, it is a dead and empty absence of determinateness. As it has come to be here, however, essence is what it is, not through a negativity foreign to it, but through one which is its own, the infinite movement of being. It is being in and for itself, absolute in its selfness, since it is indifferent to every determinateness of being. Otherness and reference to other have been sublated. But neither is it only this in itselfness. As merely being in itself, it would be only the abstraction of pure essence, but it is being for itself just as essentially. It is itself this negativity, the self-sublation of otherness and of determinateness. Essence, as the complete turning back of being into itself, is thus at first the indeterminate essence. The determinacies of being are sublated in it. It holds them in itself, but without their being posited in it. Absolute essence in this simple unity with itself has no existence. But it must pass over into existence, for it is being in and for itself. That is to say, it differentiates the determinations which it holds in itself, and, since it is the repelling of itself from itself or indifference towards itself, negative self-reference, it thereby posits itself over against itself, and is infinite being for itself only in so far as in thus differentiating itself from itself, it is in unity with itself. This determining is thus of another nature than the determining in the sphere of being, and the determinations of essence have another character than the determinations of being. Essence is absolute unity of being in itself and being for itself. Consequently, its determining remains inside this unity. It is neither a becoming nor a passing over, just as the determinations themselves are neither an other as other nor references to some other. They are self-subsisting, but, as such, at the same time conjoined in the unity of essence. Since essence is at first simple negativity, in order to give itself existence, and then being for itself, it must now posit in its sphere the determinateness which it contains in principle only in itself. 11,243. Essence is in the whole what quality was in the sphere of being, absolute indifference with respect to limit. Quantity is instead this indifference in immediate determination, limit being in it an immediate external determinateness. Quantity passes over into quantum. The external limit is necessary to it and exists in it. In essence, by contrast, the determinateness does not exist. It is posited only by the essence itself, not free but only with reference to the unity of the essence. The negativity of essence is reflection, and the determinations are reflected, posited by the essence itself, in which they remain as sublated. Essence stands between being and concept. It makes up their middle, its movement constituting the transition of being into the concept. Essence is being in and for itself, but it is this in the determination of being in itself. For its general determination is that it emerges from being or that it is the first negation of being. Its movement consists in positing negation or determination in being, thereby giving itself existence and becoming as infinite being for itself what it is in itself. It thus gives itself its existence which is equal to its being in itself, and becomes concept. For the concept is the absolute as it is absolutely, or in and for itself, in its existence. But the existence which essence gives to itself is not yet existence as it is in and for itself, but as essence gives it to itself, or as posited, and hence still distinct from the existence of the concept. First, essence shines within itself or is reflection. Second, it appears. Third, it reveals itself. In the course of its movement, it posits itself in the following determinations. As simple essence existing in itself, remaining in itself in its determinations. As emerging into existence, or according to its concrete existence and appearance. As essence which is one with its appearance, as actuality. 1 cf. GW 1176, also above, 21.99 to 100. Section 1 Essence as reflection within 11.244. Essence issues from being. Hence it is not immediately in and for itself, but is a result of that movement. Or, since essence is taken at first as something immediate, it is a determinate existence to which another stands opposed. It is only essential existence, as against the unessential. But essence is being which has been sublated in and for itself. What stands over against it is only shine. The shine, however, is essence's own positing. First, essence is reflection. Reflection determines itself. Its determinations are a positedness which is immanent reflection at the same time. Second, these reflective determinations or essentialities are to be considered. Third, as the reflection of its immanent determining, essence turns into foundation and passes over into concrete existence and appearance. Chapter 1 Shine. As it issues from being, essence seems to stand over against it. This immediate being is, first, the unessential. But, second, it is more than just the unessential. It is being void of essence. It is shine. Third, this shine is not something external, something other than essence, but is essence's own shining. This shining of essence within it is reflection. 11,245. The essential and the unessential. Essence is sublated being. It is simple equality with itself, but is such as the negation of the sphere of being in general. And so it has immediacy over against it, as something from which it has come to be, but which has preserved and maintained itself in this sublating. Essence itself is in this determination an existent immediate essence, and with reference to it being, is only something negative, nothing in and for itself. Essence, therefore, is a determined negation. Being and essence relate to each other in this fashion as again others in general which are mutually indifferent, for each has a being, an immediacy, and according to this being they stand in equal value. But as contrasted with essence, being is at the same time the unessential, as against essence, it has the determination of something sublated. And in so far as it thus relates to essence as an other only in general, essence itself is not essence proper, but is just another existence, the essential. The distinction of essential and unessential has made essence relapse into the sphere of existence. For as essence is at first, it is determined with respect to being as an existent and therefore as an other. The sphere of existence is thus laid out as foundation, and that in this sphere being is being in for itself is a further determination external to existence, just as, contrariwise, essence is indeed being in and for itself, but only over against another, in a determinate respect. Consequently, inasmuch as essential and unessential aspects are distinguished in an existence from each other, this distinguishing is an external positing, a taking apart that leaves the existence itself untouched. It is a separation which falls on the side of a third and leaves undetermined what belongs to the essential and what belongs to the unessential. It is dependent on some external standpoint or consideration, and the same content can therefore sometimes be considered as essential, sometimes as unessential. On closer consideration, essence becomes something only essential as contrasted with an unessential, because essence is only taken, is as sublated being or existence. In this fashion, essence is only the first negation, or the negation, which is determinateness, through which being becomes only existence, or existence only another. But essence is the absolute negativity of being. It is being itself, but not being determined only as an other. It is being rather that has sublated itself both as immediate being and as immediate negation, as the 11.246 negation which is affected by an otherness. Being, or existence, therefore, does not persist except as what essence is, and the immediate which still differs from essence is not just an unessential existence, but an immediate which is null in and for itself. It only is a non-essence, shine. Shine. 1. Being is shine. The being of shine consists solely in the sublatedness of being, in being's nothingness. This nothingness it has an essence, and apart from its nothingness, apart from essence, it does not exist. It is the negative posited as negative. Shine is all that remains of the sphere of being, but it still seems to have an immediate side which is independent of essence, and to be, in general, an other of essence. Other entails in general the two moments of existence and non-existence. Since the unessential no longer has a being, what is left to it of otherness is only the pure moment of non-existence. Shine is this immediate non-existence, a non-existence in the determinateness of being, so that it has existence only with reference to another, in its non-existence. It is the non-self-subsistent which exists only in its negation. What is left over to it is thus only the pure determinateness of immediacy. It is as reflected immediacy, that is, one which is only by virtue of the mediation of its negation, and which, over against this mediation, is nothing except the empty determination of the immediacy of non-existence. Shine, the phenomenon of skepticism, and also the appearance of idealism, is thus this immediacy which is not a something nor a thing, in general, not an indifferent being that would exist apart from its determinateness and connection with the subject. Skepticism did not permit itself to say it is, and the more recent idealism did not permit itself to regard cognitions as a knowledge of the thing in itself. The shine of the former was supposed absolutely not to have the foundation of a being. The thing in itself was not supposed to enter into these cognitions. But at the same time, skepticism allowed a manifold of determinations for its shine, or rather the latter turned out to have the full richness of the world for its content. Likewise for the appearance of idealism. It encompassed the full range of these manifold determinacies. So, the shine of skepticism and the 11.247 appearance of idealism do immediately have a manifold of determination. This content, therefore, might well have no being as foundation, no thing or thing in itself. For itself, it remains as it is. It is simply transposed from being into shine, so that the latter has within itself those manifold determinacies that exist immediately, each and other to the other. The shine is thus itself something immediately determined. It can have this or that content, but whatever content it has not posited it, but possesses it immediately. Idealism, whether Leibnizian, Kantian, Fichtean, or in any other form, has not gone further than skepticism in this. It has not advanced beyond being as determinateness. Skepticism lets the content of its shine to be given to it. The shine exists for it immediately, whatever content it might have. The Leibnizian monad develops its representations from itself, but is not their generating and controlling force. They rise up in it as a froth, indifferent, immediately present to each other and to the monad as well. Likewise, Kant's appearance is a given content of perception that presupposes affections, determinations of the subject which are immediate to each other and to the subject. As for the infinite obstacle of Fichte's idealism, it might well be that it has no thing in itself for foundation, so that it becomes a determinateness purely within the I. But this determinateness that the I makes its own, sublating its externality, is to the I at the same time an immediate determinateness, a limitation of the I, which the latter may transcend, but which contains a side of indifference, and on account of this indifference, although internal to the I, it entails an immediate non-being of it. 2. Shine thus contains an immediate presupposition, an independent side vis-a-vis essence. But the task, inasmuch as this shine is distinct from essence, is not to demonstrate that it sublates itself and returns into essence, for being has returned into essence in its totality. Shine is the null as such. The task is to demonstrate that the determinations which distinguish it from essence are the determinations of essence itself. Further, that this determinateness of essence, which shine is sublated in essence itself. What constitutes the shine is the immediacy of non-being. This non-being, however, is nothing else than the negativity of essence within essence itself. In essence, being is non-being. Its inherent nothingness is the negative nature of essence itself. But the immediacy or indifference which this non-being contains is essence's own absolute in itself. The negativity of essence is its self-equality or its simple immediacy and indifference. Being has preserved itself in essence inasmuch as this latter, in its infinite negativity, has this equality with itself. It is through this that essence is itself being. The immediacy that 11.248 the determinateness has in shine against essence is thus none other than essence's own immediacy, though not the immediacy of an existent, but rather the absolutely mediated or reflective immediacy, which is shine. Being, not as being, but only as the determinateness of being as against mediation, being as moment. These two moments, nothingness but as subsisting and being but as moment, or again, negativity existing in itself and reflected immediacy. These two moments that are the moments of shine are thus the moments of essence itself. It is not that there is a shine of being in essence or a shine of essence in being. The shine in the essence is not the shine of an other, but is rather shine as such, the shine of essence itself. Shine is essence itself in the determinateness of being. Essence has a shine because it is determined within itself and is therefore distinguished from its absolute unity. But this determinateness is as determinateness just as absolutely sublated in it. For essence is what stands on its own. It exists too as self-mediating through a negation which it itself is. It is, therefore, the identical unit of absolute negativity and immediacy. The negativity is negativity in itself. It is its reference to itself, and thus immediacy in itself. But it is negative reference to itself, a self-repelling negating. Thus the immediacy existing in itself is the negative or the determinate over against the negativity. But this determinateness is itself absolute negativity, and this determining, which is determining immediately sublates itself, is a turning back into itself. Shine is the negative which has a being, but in another, in its negation, it is a non-self-subsisting being which is sublated within and null. And so it is the negative which returns into itself, the non-subsistent as such, internally non-subsistent. This reference of the negative or the non-subsistent to itself is the immediacy of this non-subsistent. It is an other than it. It is its determinateness over against it, or the negation over against the negative. But this negation which stands over against the negative is negativity as referring solely to itself, the absolute sublation of the determinateness itself. The determinateness that shine is in essence is, therefore, infinite determinateness. It is only the negative which coincides with itself, and hence a determinateness that, as determinateness, is self-subsistence and not determined. Contrariwise, the self-subsistence, as self-referring immediacy, equally is just determinateness and moment, negativity solely referring to itself. This negativity which is identical with immediacy, and thus the immediacy which is identical with negativity, is essence. 11.249 Shine is, therefore, essence itself, but essence in a determinateness, in such a way, however, that the determinateness is only a moment, and the essence is the shining of itself within itself. In the sphere of being, non-being arises over against being, each equally and immediate, and the truth of both is becoming. In the sphere of essence, we have the contrast first of essence and the non-essential, then of essence and shine, the non-essential and the shine being both the leftover of being. But these two, and no less the distinction of essence from them, consist solely in this, that essence is taken at first as an immediate, not as it is in itself, namely as an immediacy, which is immediacy as pure mediacy or absolute negativity. This first immediacy is thus only the determinateness of immediacy. The sublating of this determinateness of essence consists, therefore, in nothing further than showing that the unessential is only shine, and that essence rather contains this shine within itself. For essence is an infinite self-contained movement which determines its immediacy as negativity and its negativity as immediacy, and is thus the shining of itself within itself. In its self-movement, essence is reflection. Reflection. Shine is the same as what reflection is, but it is reflection as immediate. For this shine which is internalized and therefore alienated from its immediacy, the German has a word from an alien language, reflection. Essence is reflection, the movement of becoming and transition that remains within itself, wherein that which is distinguished is determined simply and solely as the negative in itself, as shine. In the becoming of being, it is being which lies at the foundation of determinateness, and determinateness is reference to another. Reflective movement is by contrast the other as negation in itself, a negation which as being only is self-referring. Or, since this self-referring is precisely this negating of negation, what we have is negation as negation, negation that has its being in its being negated, as shine. Here, therefore, the other is not being with negation or limit, but negation with negation. But the first over against this other, the immediate or being, is only this self-equality itself of negation, the negated negation, the absolute negativity. This self-equality or immediacy, therefore, is not a first from which the beginning is made and which 11.250 would pass over into its negation, nor is there an existent substrate which would go through the moves of reflection. Immediacy is rather just this movement itself. In essence, therefore, the becoming, the reflective movement of essence, is the movement from nothing to nothing and thereby back to itself. Transition or becoming sublates itself in its transition. The other which comes to be in this transition is not the non-being of a being, but the nothingness of a nothingness. And this, to be the negation of a nothingness, constitutes being. Being is only as the movement of nothingness to nothingness, and so it is essence. And this essence does not have this movement in itself, but the movement is rather the absolute shine itself, the pure negativity which has nothing outside it which it would negate, but which rather negates only its negative, the negative which is only in this negating. This pure absolute reflection, which is the movement from nothing to nothing, further determines itself. It is, first, positing reflection. Second, it takes as its starting point the presupposed immediate, and then it is external reflection. Third, it sublates however this presupposition, and because in the sublating of the presupposition it presupposes at the same time, it is determining reflection. Positing reflection. Shine is a nothingness or a lack of essence. But a nothingness or that which is void of essence does not have its being in an other in which it shines, but its being is its own equality with itself. This conversion of the negative with itself has been determined as the absolute reflection of essence. This self-referring negativity is therefore the negating of itself. It is thus just as much sublated negativity as it is negativity. Or again, it is itself the negative and the simple equality with itself or immediacy. It consists, therefore, in being itself and not being itself, and the two in one unity. Reflection is at first the movement of the nothing to the nothing, and thus negation coinciding with itself. This self-coinciding is in general simple equality with itself, immediacy. But this falling together is not the transition of negation into equality as into a being other than it. Reflection is transition rather as the sublating of transition, for it is the immediate falling together of the negative with itself. And so this coinciding is, first, self-equality or 11.251 immediacy. But, second, this immediacy is the self-equality of the negative, and hence self-negating equality. Immediacy, which is in itself the negative of itself. Its being is to be what it is not. The self-reference of the negative is therefore its turning back into itself. It is immediacy as the sublating of the negative, but immediacy simply and solely as this reference or as turning back from a one, and hence as self-sublating immediacy. This is positedness, immediacy purely as determinateness or as self-reflecting. This immediacy, which is only as the turning back of the negative into itself, is the immediacy which constitutes the determinateness of shine, and from which the previous reflective movement seemed to begin. But, far from being able to begin with this immediacy, the latter first is rather as the turning back or as the reflection itself. Reflection is therefore the movement which, since it is the turning back, only in this turning is that which starts out or returns. It is a positing, inasmuch as it is immediacy as a turning back, that is to say, there is not an other beforehand, one either from which or to which it would turn back. It is, therefore, only as a turning back or as the negative of itself. But further, this immediacy is sublated negation and sublated return into itself. Reflection, as the sublating of the negative, is the sublating of its other, of the immediacy. Because it is thus immediacy as a turning back, the coinciding of the negative with itself, it is equally the negation of the negative as negative. And so it is presupposing. Or immediacy is as a turning back only the negative of itself. Just this, not to be immediacy. But reflection is the sublating of the negative of itself, coincidence with itself. It therefore sublates its positing, and inasmuch as it is in its positing the sublating of positing, it is presupposing. In presupposing, reflection determines the turning back into itself as the negative of itself, as that of which essence is the sublating. It is its relating to itself, but to itself as to the negative of itself. Only so is it negativity which abides with itself, self-referring negativity. Immediacy comes on the scene simply and solely as a turning back, and is that negative which is the semblance of a beginning, the beginning which the return negates. The turning back of essence is therefore its self-repulsion, or inner-directed reflection is essentially the presupposing of that from which the reflection is the turning back. It is only by virtue of the sublating of its equality with itself that essence is equality with itself. Essence presupposes itself, and the sublating of this 11.252 presupposing is essence itself. Contrariwise, this sublating of its presupposition is the presupposition itself. Reflection thus finds an immediate before it which it transcends, and from which it is the turning back. But this turning back is only the presupposing of what was antecedently found. This antecedent comes to be only by being left behind. Its immediacy is sublated immediacy. The sublated immediacy is, contrariwise, the turning back into itself, essence that arrives at itself, simple being equal to itself. This arriving at itself is thus the sublating of itself and self-repelling, presupposing reflection, and its repelling of itself from itself is the arriving at itself. It follows from these considerations that the movement of reflection is to be taken as an absolute internal counter-repelling. For the presupposition of the turning back into itself, that from which essence arises, essence being only as this coming back, is only in the turning back itself. Transcending the immediate from which reflection begins occurs rather only through this transcending, and the transcending of the immediate is the arriving at the immediate. The movement, as forward movement, turns immediately around into itself, and so is only self-movement. A movement which comes from itself in so far as positing reflection is presupposing reflection, yet, as presupposing reflection, is simply positing reflection. Thus is reflection itself and its non-being, and only is itself by being the negative of itself, for only in this way is the sublating of the negative at the same time a coinciding with itself. The immediacy which reflection, as a process of sublating, presupposes for itself is simply and solely a positedness, something in itself sublated, which is not diverse from reflection's turning back into itself, but is itself only this turning back. But it is at the same time determined as a negative, as immediately in opposition to something, and hence to another. And so is reflection determined. According to this determinateness, because reflection has a presupposition and takes its start from the immediate as its other, it is external reflection. External reflection. Reflection, as absolute reflection, is essence shining within, essence that posits only shine, only positedness, for its presupposition, and as presupposing reflection, it is immediately only positing reflection. But external or real reflection presupposes itself as sublated, as the negative of itself. In this determination, it is doubled. At one time it is as what is presupposed, or the reflection into itself, which is the 11.253 immediate. At another time, it is as the reflection negatively referring to itself. It refers itself to itself as to that its non-being. External reflection thus presupposes a being, at first not in the sense that its immediacy is only positedness or moment, but in the sense rather that this immediacy refers to itself, and the determinateness is only as moment. Reflection refers to its presupposition in such a way that the latter is its negative, but this negative is thereby sublated as negative. Reflection, in positing, immediately sublates its positing, and so it has an immediate presupposition. It therefore finds this presupposition before it as something from which it starts, and from which it only makes its way back into itself, negating it as its negative. But that this presupposition is a negative or a positedness is not its concern. This determinateness belongs only to positing reflection, whereas in the presupposing positedness it is only as sublated. What external reflection determines and posits in the immediate are determinations which to that extent are external to it. In the sphere of being, external reflection was the infinite. The finite stands as the first, as the real from which the beginning is made as from a foundation that abides, whereas the infinite is the reflection into itself standing over against it. This external reflection is the syllogism in which the two extremes are the immediate and the reflection into itself. The middle term is the reference connecting the two, the determinate immediate, so that one part of this connecting reference, the immediate, falls to one extreme alone, and the other, the determinateness or the negation, only to the other extreme. But if one takes a closer look at what the external reflection does, it turns out that it is, secondly, the positing of the immediate, an immediate which thus becomes the negative or the determined, but it is immediately also the sublating of this positing, for it presupposes the immediate. In negating, it is the negating of its negating. But thereby it immediately is equally a positing, the sublating of the immediate which is its negative, and this negative, from which it seemed to begin as from something alien, only is in this its beginning. In this way, the immediate is not only implicitly in itself, that is, for us or in external reflection, the same as what reflection is, but is posited as being the same. For the immediate is determined by reflection as the negative of the latter or as the other of it, but it is reflection itself which negates this determining. The externality of reflection vis-a-vis the immediate is consequently sublated. Its self-negating positing is its coinciding with its negative, with the immediate, and this 11.254 coinciding is the immediacy of essence itself. It thus transpires that external reflection is not external, but is just as much the immanent reflection of immediacy itself, or that the result of positing reflection is essence existing in and for itself. External reflection is thus determining reflection. Remark. Reflection is usually taken in a subjective sense as the movement of judgment which transcends an immediately given representation and seeks more universal determinations for it, or compares it with such determinations. Kant opposes reflective and determining judgment. Critique of Judgment, Introduction, pages XEF. He defines judgment in general as the faculty of thinking the particular as contained under the universal. If the universal, the rule, the principle, the law, is given, then the judgment which subsumes the particular under it is determining. But if what is given is only a particular, for which it is up to the judgment to find the universal, then the judgment is reflecting. Here, too, reflection is therefore a matter of rising above the immediate to the universal. On the one hand, the immediate is determined as particular only by being thus referred to its universal. For itself, it is only a singular or an immediate existent. But, on the other hand, that to which it is referred, its universal, its rule, principle, law, is in general that which is reflected into itself, which refers itself to itself, is the essence or the essential. But at issue here is neither the reflection of consciousness, nor the more specific reflection of the understanding that has the particular and the universal for its determinations, but reflection in general. It is clear that the reflection to which Kant assigns the search of the universal for a given particular is likewise only an external reflection which applies itself to the immediate as to something given. But the concept of absolute reflection, too, is implicit in it. For the universal, the principle or the rule and law, to which reflection rises in its process of determination, is taken to be the essence of the immediate from which the reflection began. The immediate, therefore, to be a nothingness which is posited in its true being only by the turning back of the reflection from it, by the determining of reflection. Therefore, what reflection does to the immediate and the determinations that derive from it is not anything external to it, but is rather its true being. External reflection was also meant whenever reflection, as it was for a while the fashion in recent philosophy, was being accused of all evil. 11.255, and it and its ways of determining were regarded as the polar opposite, nay the ancestral enemy, of true philosophical method. In fact, also thought reflection, in so far as it operates externally, proceeds from something immediately given that is alien to it, and considers itself to be a merely formal operation that receives its material content from outside, and of itself only is a movement conditioned by that content. Further, as the examination of determining reflection will now bear out, reflective determinations are of a different kind than the merely immediate determinations of being. These last are more readily admitted to be transient, merely relative, confined to the reference to another. The reflective determinations have instead the form of a being which is in and for itself. They claim the status, therefore, of essential determinations, and instead of passing over into their opposites, they appear rather as absolute, free, and mutually indifferent. They stubbornly resist, therefore, their movement. Their being is the self-identity which they possess in their determinateness, and by virtue of it, though indeed presupposing each other, in this referring to the other they nonetheless maintain themselves as totally separate. Determining reflection. Determining reflection is in general the unity of positing and external reflection. This is now to be examined more closely. External reflection begins from immediate being, positing reflection from nothing. In its determining, external reflection posits another in the place of the sublated being, but this other is essence. The positing does not posit its determination in the place of an other. It has no presupposition. But, precisely for this reason, it is not complete as determining reflection. The determination which it posits is consequently only a posited. This is an immediate, not however as equal to itself, but as self-negating. Its connection with the turning back into itself, is absolute. It is only in the reflection into itself, but is not this reflection itself. The posited is therefore an other, but in such a manner that the self-equality of reflection is retained, for the posited is only as sublated, as reference to the turning back into itself. In the sphere of being, existence was the being that had negation in it, and being was the immediate ground and element of this negation which was, therefore, itself immediate negation. In the sphere of essence, positedness is what corresponds to existence. Positedness is equally in existence, but its ground is being as essence or as pure negativity. It is a determinateness or a negation, not as existent but immediately as sublated. Existence is only positedness. This is the 11.256 principle of the essence of existence. Positedness stands on the one side over against existence, and over against essence on the other. It is to be regarded as the means which conjoins existence with essence and essence with existence. If it is said, a determination is only a positedness, the claim can thus have a twofold meaning, according to whether the determination is such an opposition to existence or an opposition to essence. In either meaning, existence is taken for something superior to positedness, which is attributed to external reflection, to the subjective. In fact, however, positedness is the superior because, as posited, existence is what it is in itself, something negative, something that refers simply and solely to the turning back into itself. For this reason, positedness is only a positedness with respect to essence. It is the negation of this turning back as achieved return into itself. Positedness is not yet a determination of reflection. It is only determinateness as negation in general. But the positing is now united with external reflection. In this unity, the latter is absolute presupposing, that is, the repelling of reflection from itself or the positing of determinateness as its own. As posited, therefore, positedness is negation, but as presupposed, it is reflected into itself. And in this way positedness is a determination of reflection. The determination of reflection is distinct from the determinateness of being, of quality. The latter is immediate reference to other in general. Positedness also is reference to other, but to immanently reflected being. Negation as quality is existent negation. Being constitutes its ground and element. The determination of reflection, on the contrary, has for this ground immanent reflectedness. Positedness gets fixed in determination precisely because reflection is self-equality in its negatedness. The latter is therefore itself reflection into itself. Determination persists here, not by virtue of being, but because of its self-equality. Since the being which sustains quality is unequal to the negation, quality is consequently unequal within itself, and hence a transient moment which disappears in the other. The determination of reflection is on the contrary positedness as negation. Negation, which has negatedness for its ground, is therefore not unequal to itself within itself, and hence essential rather than transient determinateness. What gives subsistence to it is the self-equality of reflection, which has the negative only as negative, as something sublated or posited. Because of this reflection into themselves, the determinations of reflection appear as free essentialities, sublated in the void without reciprocal attraction or repulsion. In them the determinateness has become entranced and infinitely fixed by virtue of the reference to itself. It is the determinate which has subjugated its transitoriness and its mere positedness to itself, that is to say, has deflected its reflection into 11.257 reflection, into itself. These determinations hereby constitute the determinate shine as it is in essence, the essential shine. Determining reflection is for this reason reflection that has exited from itself. The equality of essence with itself is lost in the negation, and negation predominates. Thus there are two distinct sides to the determination of reflection. First, reflection is positedness, negation as such. Second, it is immanent reflection. According to the side of positedness, It is negation as negation, and this already is its unity with itself. But it is this unity at first only implicitly or in itself, an immediate which sublates itself within, is the other of itself. To this extent, reflection is a determining that abides in itself. In its essence does not exit from itself. The distinctions are solely posited, taken back into essence. But, from the other side, they are not posited but are rather reflected into themselves. Negation as negation is a quality with itself, not in its other, not reflected into its non-being. Now, keeping in mind that the determination of reflection is both immanently reflected reference and positedness as well, its nature immediately becomes more transparent. For, as positedness, the determination is negation as such, a non-being as against another, namely, as against the absolute immanent reflection or as against essence. But as self-reference, it is reflected within itself. This, the reflection of the determination, and that positedness are distinct. Its positedness is rather the sublatedness of the determination, whereas its immanent reflectedness is its subsisting. In so far as now the positedness is at the same time immanent reflection, the determinateness of the reflection is the reference in it to its otherness. It is not a determinateness that exists quiescent, one which would be referred to an other in such a way that the referred term and its reference would be different, each something existing in itself. Each is something that excludes its other and its reference to this other from itself. Rather, the determination of reflection is within it the determinate side and the reference of this determinate side as determinate, that is, the reference to its negation. Quality, through its reference, passes over into another. Its alteration begins in its reference. The determination of reflection, on the contrary, has taken its otherness back into itself. It is positedness, negation which has however deflected the reference to another into itself, and negation which, equal to itself, is the unity of itself and its other, and only through this is an essentiality. It is, therefore, positedness, negation, but as reflection into itself it is at the same time the sublatedness of this positedness, infinite reference to itself. 2 ist, stressed in Hegel. Chapter 2 The Essentialities or the Determinations of Reflection 11, 258. Reflection is determined reflection. Accordingly, essence is determined essence, or it is essentiality. Reflection is the shining of essence within itself. Essence, as infinite immanent turning back, is not immediate simplicity, but negative simplicity. It is a movement across moments that are distinct, is absolute mediation with itself. But in these moments it shines. The moments are, therefore, themselves determinations reflected into themselves. First, essence is simple self-reference, pure identity. This is its determination, one by which it is rather the absence of determination. Second, the specifying determination is difference, difference which is either external or indefinite, diversity in general, or opposed diversity or opposition. Third, as contradiction, this opposition is reflected into itself and returns to its foundation. Remark: the determinations of reflection have customarily been singled out in the form of propositions which were said to apply to everything. They were said to have the status of universal laws of thought that lie at the base of all thinking, to be inherently absolute and indemonstrable, but immediately and indisputably recognized and accepted as true by all thought upon grasping their meaning. Thus identity, as an essential determination, is enunciated in the proposition, everything is equal to itself, A equals A, or, negatively, A cannot be A and not A at the same time. On the face of it, it is difficult to see why only these simple determinations of reflection should be expressed in this particular form and not also the rest. 11.259, such as the categories that belong to the sphere of being. We would then have, for instance, such propositions as everything is, everything has an existence, etc., or again, everything has a quality, a quantity, and so on. for being, existence, etc., are as logical determinations the predicates of everything in general. A category, according to the etymology of the word and Aristotle's definition of it, is what is said and asserted of every existent. But the difference is that a determinateness of being is essentially a transition into the opposite of it. The negative of every determinateness is just as necessary as that determinateness itself. As immediate determinacies, each determinateness immediately confronts the others. If any of these categories is therefore expressed in a proposition, the opposite proposition comes up just as well, both offering themselves with equal necessity, and, as immediate claims, each has at least equal right. Each would therefore require a proof as against the other, and both claims would no longer possess the character of immediately true and indisputable propositions. The determinations of reflection are, on the contrary, not qualitative in kind. They are self-referring and consequently abstract from the determinateness of others. Further, since as determinacies they are self-references, they therefore already have the propositional form in them. For proposition and judgment differ mainly because in the former the content constitutes the connection itself of the terms, or is a specific connection. Judgment, on the contrary, converts the content into a predicate which is a universal determinateness by itself, distinct from its connection, which is the simple copula. Whenever a proposition is to be transformed into a judgment, the determinate content, if, for instance, it resides in a verb, is transformed into a participle in order in this way to separate the determination itself from its connection with the subject. The propositional form is instead more closely allied to the determinations of reflection, which are immanently reflected positiveness. Only, when they are enunciated as universal laws of thought, they are in need of a subject of their connection, and this subject is the everything, or an A which equally means all being and each being. Now this propositional form is, for one thing, something superfluous. The determinations of reflection are to be regarded in and for themselves. Moreover, the propositions suffer from the drawback that they have being, everything, for subject. They thus bring being into play again and enunciate the determinations of reflection, the identity, etc., of anything, as a quality which a something would have within, not in any speculative sense, but in the sense that the something, as subject, persists in such a quality as an existent, not that it has passed over into identity, etc., as into its truth and essence. 11,260. Finally, although the determinations of reflection have the form of self-equality, and are therefore unconnected to another and without opposition, they are in fact determinate against one another, as it will result on closer examination, or is immediately evident in them in the case of identity, diversity, and opposition, and are not therefore exempt from transition and contradiction because of their reflective form. Therefore, on closer examination, the several propositions that are set up as absolute laws of thought are opposed to each other. They contradict each other and mutually sublate each other. If everything is identical with itself, then it is not different, is not opposed, has no ground. Or if it is assumed that there are no two things alike, that is, that all things are different from each other, then A is not equal to A, nor is A in opposition, etc. The assumption of any of these propositions does not allow the assumption of any other. The thoughtless examination of them enumerates them one after the other, so that they appear unconnected. It merely adverts to their reflectedness without paying attention to their other moment, to the positiveness, or the determinateness as such which propels them on to transition or to their negation. Identity. Essence is simple immediacy as sublated immediacy. Its negativity is its being. It is equal to itself in its absolute negativity by virtue of which otherness and reference to other have, as such, simply disappeared into pure self-equality. Essence is therefore simple self-identity. This self-identity is the immediacy of reflection. It is not that self-equality which being is, or also nothing, but a self-equality which, in producing itself as unity, does not produce itself over again, as from another, but is a pure production, from itself and in itself, essential identity. It is not, therefore, abstract identity or an identity which is the result of a relative negation preceding it, one that separates indeed what it distinguishes from it, but, for the rest, leaves it existing outside it, the same after as before. Being, and every determinateness of being, has rather sublated itself not relatively, but in itself, and this simple negativity, the negativity of being in itself, is the identity itself. In general, therefore, it is still the same as essence. 11,261. Remark 1. Thought that keeps to external reflection and knows of no other thought except that of external reflection does not attain to identity as we have just grasped it, nor does it recognize essence, which is the same. Such a thought will always have only abstract identity in mind, and, outside and alongside it, difference. In its opinion, reason is no more than a loom intertwining warp, say, identity, and woof, say, difference, joining them externally, or, if it turns to analysis, now specifically pulling out identity, and at the same time also obtaining difference alongside it. Now a comparing, and also a differentiating at the same time. A comparing in that it abstracts from difference, and a differentiating in that it abstracts from the comparing. One must completely dismiss these assertions and these opinions concerning what reason does, since they are, as it were, of merely historical interest. It is rather the consideration of all things that are that reveals, in them, that each is self-unlike and contradictory in its equality with itself, and each self-identical in its difference, in its contradiction, that everything intrinsically is this movement of transition of one of these determinations to the other, and that everything is this transition because each determination is itself, within it, the opposite of itself. The concept of identity, a simple negativity that refers itself to itself, is not the product of external reflection, but derives from being itself. Contrary to this, the identity that stays distant from difference, and the difference that stays distant from identity, are the products of external reflection and of an abstraction that arbitrarily clings to this point of indifferent difference. This identity is, in the first instance, essence itself, not yet a determination of it. It is the entire reflection, not a distinct moment of it. As absolute negation, it is negation immediately negating itself, a non-being and difference that vanishes as it arises, or a distinguishing by which nothing is distinguished, but which immediately collapses within itself. But the non-being of the other is the sublating of the other and hence of the distinguishing itself. Here, then, distinguishing is present as self-referring negativity, as a non-being which is the non-being of itself, a non-being which does not have its non-being in an other 11.262, but has it within itself. What is present, therefore, is self-referring, reflected difference, or pure, absolute difference. Or identity is immanent reflection, reflection which is such only as inner repelling, and it is this repelling as immanent reflection, repelling that immediately recovers itself. And so identity is identity as difference which is identical with itself. But difference is identical with itself only inasmuch as it is not identity, but absolute non-identity. But again, non-identity is absolute to the extent that it does not contain anything of its other, but is only itself, that is, to the extent that it is identity with itself. Internally, therefore, identity is absolute non-identity. But it is also the determination of identity over against non-identity. For, as immanent reflection, it posits itself as its own non-being. It is the whole, but as reflection it posits itself as its own moment, as the positedness from which it is the turning back into itself. Thus identity is such only as a moment of itself, as determination of simple self-equality over against absolute difference. Remark 2. In this remark, I shall examine identity more closely as the principle of identity, which is commonly adduced as the first law of thought. In its positive formulation, A equals A, this proposition is at first no more than the expression of empty tautology. It is rightly said, therefore, that this law of thought is without content and that it leads nowhere. It is thus to an empty identity that they cling, those who take it to be something true, insisting that identity is not difference but that the two are different. They do not see that in saying identity is different from difference, they have thereby already said that identity is something different. And since this must also be conceded as the nature of identity, the implication is that to be different belongs to identity not externally, but within it, in its nature. But, further, inasmuch as these same individuals hold firm to their unmoved identity, of which the opposite is difference, they do not see that they have thereby reduced it to a one-sided determinateness which, as such, has no truth. They are conceding that the principle of identity only expresses a one-sided determinateness, that it only contains formal truth, truth abstract and incomplete. Immediately implied in this correct judgment, however, is that the truth is complete only in the 11.263 unity of identity and difference, and, consequently, that it only consists in this unity. When asserting that formal identity is incomplete, there is vaguely present to one's mind the totality, measured against which that identity is incomplete, but the moment one insists that identity is absolutely separate from difference, and in this separation takes it to be something essential, valid, true, then what transpires from these two contradictory claims is only the failure to reconcile these two thoughts. That identity is as abstract identity essential, but that, as such, it is equally incomplete. What is lacking is the awareness of the negative movement as which, in these claims, identity itself is displayed. Or when this is said, that identity is identity essentially as separation from difference or in the separation from difference, then right there we have the express truth about it, namely that identity consists in being separation as such, or in being essentially in the separation. That is, it is nothing for itself, but is rather moment of separation. As to the other confirmation of the absolute truth of the principle of identity, this is made to rest on experience in so far as appeal is made to the experience of every consciousness. For anyone presented with this proposition, A is A, a tree is a tree, immediately grants it, and is satisfied that the proposition is self-evident and in need of no further justification or demonstration. On the one hand, this appeal to experience, that every consciousness acknowledges the principle universally, is a mere manner of speaking. For nobody will want to say that the abstract proposition, A is A, has actually been tried out on every consciousness. The appeal to actual experience is therefore not in earnest, but is rather only an assurance that, if the said experiment were made, universal acknowledgement of the proposition would be the result. And if it is not the abstract proposition as such that is meant, but the proposition in concrete application, from which application the abstract proposition would then have to be developed, then the claim to the universality and immediacy of the latter would consist in the fact that every consciousness assumes it or implies it as foundation, and indeed does so in its every utterance. But the concrete and the application are precisely in the reference that connects simple identity with a manifold which is different from it. Expressed as a proposition, the concrete would be first of all a synthetic proposition. From this concrete itself, or from the synthetic proposition expressing it, abstraction could indeed extract the principle of identity through analysis, but, in actual fact, it would not then leave experience as is, but would have altered it, since in experience the 11.264 identity was rather in unity with difference. And this is the immediate refutation of the claim that abstract identity is as such something true, for what transpires in every experience is the very opposite, namely identity only united with difference. On the other hand, the experiment with the pure principle of identity is also all too often made, and it demonstrates clearly enough how the truth contained in the principle is regarded. If, for instance, To the question, what is a plant? The answer is given, a plant is, a plant. The whole company on which this answer is tried out would both grant it and at the same time unanimously declare that the statement says nothing. If anyone opens his mouth and promises to announce what God is, and says that God is, God, expectation is cheated, for a different determination was anticipated. And though the proposition is absolute truth, very little is made of such absolute verbiage. Nothing will be held to be more tedious, more aggravating, than a conversation which only chews the cud, however true the cud might nevertheless be. Let us take a closer look at what makes such a truth tedious. So, the beginning, the plant is, makes moves in the direction of saying something, of adducing a further determination. But since only the same is repeated, the opposite has happened instead, nothing has occurred. Such talk of identity, therefore, contradicts itself. Identity, instead of being in itself the truth and the absolute truth, is thus rather the opposite. Instead of being the unmoved simple, it surpasses itself into the dissolution of itself. More is entailed, therefore, in the form of the proposition expressing identity than simple, abstract identity. Entailed by it is this pure movement of reflection in the course of which there emerges the other, but only as reflective shine, as immediate disappearing. A is a beginning that envisages a something different before it to which the A is would proceed, but the A is never gets to it. A is, The difference is only a disappearing and the movement goes back into itself. The propositional form can be regarded as the hidden necessity of adding to abstract identity the extra factor of that movement. Thus an A is added, a plant or some other substrate, a useless content with no significance, but it constitutes the difference that seems to associate itself by accident. If instead of A or any other substrate, identity itself is assumed, identity is identity, it is then thereby admitted that any other substrate could be assumed instead of this identity. Consequently, if appeal is to be made to what appearance indicates, then the result is this, that in the expression of identity, difference also 11.265 immediately emerges, or more precisely, in accordance with what has been said, that this identity is a nothing, is negativity, the absolute difference from itself. The other expression of the principle of identity, A cannot be A and not A at the same time, is in a negative form. It is called the principle of contradiction. No justification is normally given for how the form of negation by which this principle is distinguished from the other comes to identity. But this form is implied by the pure movement of reflection which identity is, by the simple negativity, which is contained in a more developed form by the just stated second formulation of the principle. A is enunciated, and a not A, which is the pure other of A, but this not A only shows itself in order to disappear. In this proposition, therefore, identity is expressed as a negation of negation. A and not A are distinct. The two terms are distinguished with reference to one and the same A. Here identity is displayed, therefore, as this differentiation of the terms in the one connection or as the simple difference in the terms themselves. From this, it is clear that the principle of identity itself, and still more the principle of contradiction, are not of merely analytical, but of synthetic nature. For the latter expresses not only empty, simple self-equality, but the other of this self-equality, and not just this other in general, but as absolute inequality, contradiction in itself. As for the principle of identity itself, we have shown that it entails the movement of reflection, identity as the disappearing of otherness. Thus the result of this consideration is this. 1. The principle of identity or contradiction, when meant to express merely abstract identity in opposition to difference as a truth, is not a law of thought, but expresses rather the opposite of it. 2. These two principles contain more than is meant by them, namely this opposite, absolute difference itself. Difference. Absolute difference. Difference is the negativity that reflection possesses in itself, the nothing which is said in identity discourse, the essential moment of identity itself which, as the negativity of itself, at the same time determines itself and is differentiated from difference. 11,266. This difference is difference in and for itself, absolute difference, the difference of essence. It is difference in and for itself, not difference through something external, but self-referring, hence simple difference. It is essential that we grasp absolute difference as simple. In the absolute difference of A and not A from each other, it is the simple not which, as such, constitutes the difference. Difference itself is a simple concept. In this, so it is said, two things differ, in that etc. In this, that is, in one and the same respect, relative to the same basis of determination. It is the difference of reflection, not the otherness of existence. One existence and another existence are posited as lying outside each other. Each of the two existences thus determined over against each other has an immediate being for itself. The other of essence, by contrast, is the other in and for itself, not the other of some other which is to be found outside it. It is simple determinateness in itself. Also in the sphere of existence did otherness and determinateness prove to be of this nature, simple determinateness, identical opposition. But this identity showed itself only as the transition of a determinateness into the other. Here, in the sphere of reflection, difference comes in as reflected, so posited as it is in itself. Difference in itself is the difference that refers itself to itself. Thus it is the negativity of itself, the difference not from another but of itself from itself. It is not itself, but its other. What is different from difference, however, is identity. Difference is, therefore, itself and identity. The two together constitute difference. Difference is the whole and its moment. One can also say that difference, as simple difference, is no difference. It is such only with reference to identity. Even better, that as difference it entails itself, and this reference equally. Difference is the whole and its own moment, just as identity equally is its whole and its moment. This is to be regarded as the essential nature of reflection and as the determined primordial origin of all activity and self-movement. Both difference and identity make themselves into moment or positedness because, as reflection, they are negative self-reference. Difference, thus as unity of itself and of identity, is internally determined difference. It is not the transition into another, not reference to another outside it. It has its other, identity, within, and in like manner identity, in being included in the determination of difference, has not lost itself in it as its other, but retains itself therein, is the reflection into itself of difference, its moment. 11,267. Difference has both these moments, identity and difference. Thus the two are both a positedness, determinateness. But in this positedness each refers to itself. The one, identity, is itself immediately the moment of imminent reflection, but no less is the other, difference, difference in itself, reflected difference. Difference, inasmuch as it has two such moments which are themselves reflections into themselves, is diversity. Diversity. Identity internally breaks apart into diversity because, as absolute difference in itself, it posits itself as the negative of itself, and these, its two moments, itself and the negative of itself, are reflections into themselves, are identical with themselves, or precisely because it itself immediately sublates its negating and is in its determination reflected into itself. The different subsists as diverse, indifferent to any other, because it is identical with itself, because identity constitutes its base and element, or the diverse remains what it is even in its opposite, identity. Diversity constitutes the otherness as such of reflection. The other of existence has immediate being, where negativity resides, for its foundation. But in reflection it is self-identity, the reflected immediacy, that constitutes the subsistence of the negative and its indifference. The moments of difference are identity and difference itself. These moments are diverse when reflected into themselves, referring themselves to themselves. Thus, in the determination of identity, they are only self-referring. Identity is not referred to difference, nor is difference referred to identity. Hence, inasmuch as each of these moments is referred only to itself, the two are not determined with respect to each other. Now, because in this way the two are not differentiated within, the difference is external to them. The diverse moments, therefore, conduct themselves with respect to each other, not as identity and difference, but only as moments different in general, indifferent to each other and to their determinateness. In diversity, as the indifference of difference, reflection has in general become external. Difference is only a positedness or as sublated, but is itself the whole reflection. On closer consideration, both identity and difference are reflections, as we have just established. Each is the unity of it, and its other. Each is the whole. But the determinateness, to be only identity or only difference, is thus a sublated something. They are not, therefore, qualities, since their 11.268 determinateness, because of the immanent reflection, is at the same time only as negation. What we have is therefore this duplicity, immanent reflection as such and determinateness as negation or positedness. Positedness is the reflection that is external to itself. It is negation as negation and consequently, indeed in itself self-referring negation and immanent reflection, but only in itself, implicitly. Its reference is to a something external. Reflection in itself and external reflection are thus the two determinations in which the moments of difference, identity and difference, are posited. They are these moments themselves as they have determined themselves at this point. Immanent reflection is identity, but determined to be indifferent to difference, not to have difference at all, but to conduct itself towards difference as identical with itself. It is diversity. It is identity that has so reflected itself into itself that it truly is the one reflection of the two moments into themselves. Both are immanent reflections. Identity is this one reflection of the two, the identity which has difference within it only as an indifferent difference, and is diversity in general. External reflection, on the contrary, is their determinate difference, not as absolute immanent reflection, but as a determination towards which the implicitly present reflection is indifferent. Its two moments, identity and difference themselves, are thus externally posited, are not determinations that exist in and for themselves. Now this external identity is likeness, and external difference is unlikeness. Likeness is indeed identity, but only as a positedness, an identity which is not in and for itself. Unlikeness is equally difference, but an external difference which is not, in and for itself, the difference of the unlike itself. Whether something is like or unlike something else is not the concern of either the like of the unlike. Each refers only to itself. Each is in and for itself what it is, identity or non-identity. In the sense of likeness or unlikeness, depend on the point of view of a third external to them. External reflection connects diversity by referring it to likeness and unlikeness. This reference, which is a comparing, moves back and forth from likeness to unlikeness and from unlikeness to likeness. But this back and forth referring of likeness and unlikeness is external to these determinations themselves. Moreover, they are not referred to each other, but each, for itself, is referred to a third. In this alternation, each immediately stands out on its own. External reflection is as such external to itself. Determinate difference is negated absolute difference. It is not simple difference, therefore, not an immanent reflection, but has this reflection outside it. Hence its moments come apart, and both refer, each also outside the other, to the immanent reflection confronting them. 11,269. In reflection thus alienated from itself, likeness and unlikeness present themselves, therefore, as themselves unconnected, and reflection keeps them apart, for it refers them to one and the same something by means of in so far, from this side or that, and from this view or that. Thus diverse things that are one and the same, when likeness and unlikeness are said of them, are from one side like each other, but from another side unlike, and in so far as they are alike, to that extent they are not unlike. Likeness thus refers only to itself, and unlikeness is equally only unlikeness. Because of this separation from each other, they sublate themselves. Precisely that which should save them from contradiction and dissolution, namely that something is like another in one respect, but unlike in another. Precisely this keeping of likeness and unlikeness apart is their destruction. For both are determinations of difference. They are references to each other, each intended to be what the other is not. The like is not the unlike, and the unlike is not the like. Both have this connecting reference essentially, and have no meaning outside it. As determinations of difference, each is what it is as different from its other. But because of their indifference to each other, the likeness is referred to itself, and similarly is unlikeness a point of view of its own and a reflection unto itself. Each, therefore, is like itself. Difference has vanished, since they have no determinateness to oppose them. In other words, each is consequently only likeness. Accordingly, this indifferent viewpoint or the external difference sublates itself, and it is in itself the negativity of itself. It is the negativity which in comparing belongs to that which does the comparing. This latter oscillates from likeness to unlikeness and back again. Hence it lets the one disappear into the other and is in fact the negative unity of both. This negative unity transcends at first what is compared as well as the moments of the comparing as a subjective operation that falls outside them. But the result is that this unity is in fact the nature of likeness and unlikeness themselves. Even the independent viewpoint that each of these is rather the self-reference that sublates their distinctness and so, too, themselves. From this side, as moments of external reflection and as external to themselves, likeness and unlikeness disappear together into their likeness. But this, their negative unity, is in addition also posited in them, for their reflection implicitly exists outside them. That is, they are the likeness and unlikeness of a third, of another than they themselves are. Thus the like is not the like of itself, and the unlike, as the unlike not of itself but of an unlike to it, is itself the like. The like and the unlike is each therefore the unlike of itself. Each is thereby this reflection. 11.270 Likeness, that it is itself and the unlikeness. Unlikeness, that it is itself and the likeness. Likeness and unlikeness constituted the side of positedness as against what is being compared or the diverse which, as contrasted with them, had determined itself as implicitly existent reflection. But this positedness has consequently equally lost its determinateness as against this reflection. Likeness and unlikeness, the determinations of external reflection, are precisely the merely implicitly existent reflection which the diverse as such was supposed to be, its only indeterminate difference. Implicitly existent reflection is self-reference without negation, abstract self-identity, and therefore positedness itself. The merely diverse thus passes over through the positedness into negative reflection. The diverse is difference which is merely posited, hence a difference which is no difference, hence a negation that negates itself within. Likeness and unlikeness themselves, the positedness, thus return through indifference or through implicitly existing reflection back into negative unity with themselves, into the reflection which is the implicit difference of likeness and unlikeness. Diversity, the indifferent sides of which are just as much simply and solely moments of a negative unity, is opposition. Remark. Diversity, like identity, is expressed in a proposition of its own, but the two propositions otherwise remain indifferent to each other, each valid on its own irrespective of the other. All things are different, or no two things are alike. This principle is in fact opposed to the principle of identity, for it says, A is something distinctive, therefore A is also not A, or A is unlike another, Hence it is not A in general, but rather a distinctive A. In the proposition expressing identity, the A can be replaced by any other substrate, but when A is something distinctive, it cannot be interchanged with anything else. Of course, it is not supposed to be different from itself, but only from some other, but this diversity is its own determination. As self-identical, A is indeterminateness, but as determinate it is the opposite thereof. It no longer has only self-identity, but also carries a negation within, and hence a difference within it of itself from itself. That everything is different from everything else is an altogether superfluous proposition, for in the plural of things there is already implied a multitude and totally indeterminate diversity. The principle, however, there are no two perfectly like things, expresses more than that, for it expresses determinate difference. 11.271 Two things are not merely two. Numerical multiplicity is only the repetition of one, but are rather differentiated by a determination. The proposition that there are no two things which are like each other strikes the imagination as strange, as in the anecdote about the court where Leibniz propounded it, occasioning the ladies to search among the leaves of trees to see whether two alike could be found. Happy times for metaphysics those, when it was practiced at court and no greater effort was called for to demonstrate its propositions than to compare the leaves of trees. The reason why the principle strikes us as strange lies in what has just been said, namely because two, or any numerical plurality, does not yet contain a diversity which is determinate, and because diversity as such, taken in abstraction, is at first indifferent with respect to likeness and unlikeness. Ordinary thinking, when it goes on to determine it, assumes that these two moments are themselves indifferent to each other, so that each is sufficient for the determination without the other, the mere likeness of things sufficient without their unlikeness, as if the things would be diverse even if only numerically many, diverse in general without being unequal. The law of diversity, on the contrary, proclaims that things are diverse from each other by virtue of unlikeness, that the determination of unlikeness belongs to them just as much as that of likeness, for only the two together constitute determinate difference. Now this proposition, that the determination of unlikeness pertains to all things, is surely in need of demonstration. It cannot be advanced as an immediate proposition, for it is the ordinary norm of cognition itself to require a demonstration for linking diverse determinations together into one synthetic proposition, or to indicate some third term in which such determinations are mediated. Such a demonstration would have to display the transition from identity to diversity, and the transition then from diversity to determinate diversity to unlikeness. But this is not ordinarily done. The demonstration would follow from the fact that diversity or external difference is in truth reflected into itself, is difference within, that the indifferent subsistence of the diverse is a mere positiveness, and therefore not external, indifferent difference, but one reference of the two moments. In this lies also the dissolution, the nothingness, of the law of diversity. Two things are not perfectly alike. So they are at the same time alike and unlike. Alike, by the very fact that they are things, or two in general, for each is a thing or a one just as well as any other, and each is therefore the same as the other. Unlike, however, ex hypothesi. What we then have is this determination, that the two moments, likeness and unlikeness, are different in one and the same thing, or that their differentiating difference is at the same time one and the same reference. Here is where we have the transition into opposition. 11,272. They at the same time of the two predicates will indeed be held fragmented by means of the in so far. Two things are in so far alike, in so far unlike, or they are alike from one side in viewpoint, but unlike from another. In this way, the unity of likeness and unlikeness is kept away from a thing, and what would be the thing's own reflection and the immanent reflection of likeness and unlikeness is fixed as a reflection external to the thing. But it is this reflection which, in one and the same activity, distinguishes the two sides of likeness and unlikeness, by the same token contains them in one activity, and lets the one shine reflected into the other. The ordinary tenderness for things, the overriding worry of which is that they do not contradict themselves, forgets instead, here as elsewhere, that contradiction is not thereby dissolved, but is rather shoved elsewhere, into subjective or external reflection. Forgets that the two moments of this reflection, of which it speaks as assumed facts in its effort at removing them or displacing them, are in fact contained in it as sublated, and each referring to the other in one unity. Opposition. In opposition, the determinate reflection, difference, is brought to completion. Opposition is the unity of identity and diversity. Its moments are diverse in one identity, and so they are opposites. Identity and difference are the moments of difference as held inside difference itself. They are reflected moments of its unity. Likeness and unlikeness are instead the externalized reflection. Their self-identity is not only the indifference of each towards the other differentiated from it, but towards being in and for itself as such. Theirs is a self-identity that contrasts with identity reflected into itself, hence an immediacy which is not reflected into itself. The positedness of the sides of external reflection is therefore a being, just as their non-positedness is a non-being. On closer consideration, the moments of opposition are positedness reflected into itself or determination in general. Positedness is likeness and unlikeness. These two, reflected into themselves, constitute the determinations of opposition. Their immanent reflection consists in that each is within it the unity of likeness and unlikeness. Likeness is only in a reflection which compares according to the unlikeness, and is therefore mediated by its other indifferent moment. Similarly, unlikeness is only in the same reflective reference in which likeness is. Each of these moments, in its determinateness, is therefore the whole. It is the whole because it also contains its other moment. But 11.273 this, its other, is an indifferent existent. Thus each contains a reference to its non-being, and it is reflection into itself, or the whole, only as essentially referring to its non-being. This self-likeness, reflected into itself and containing the reference to unlikeness within it, is the positive, and the unlikeness that contains within itself the reference to its non-being, to likeness, is the negative. Or again, both are positedness. Now in so far as the differentiated determinateness is taken as a differentiated determinate reference of positedness to itself, opposition is, on the one hand, positedness reflected into its likeness with itself, and, on the other hand, it is the same positedness reflected into its inequality with itself, the positive and the negative. The positive is positedness as reflected into self-likeness, but what is reflected is positedness, that is, the negation as negation, and so this immanent reflection has the reference to the other for its determination. The negative is positedness as reflected into unlikeness. But positedness is the unlikeness itself, and so this reflection is therefore the identity of unlikeness with itself and absolute self-reference. Each, therefore, equally has the other in it. Positedness reflected into self-likeness has the unlikeness, and positedness reflected into self-unlikeness, the likeness. The positive and the negative are thus the sides of opposition that have become self-subsisting. They are self-subsisting because they are the reflection of the whole into itself, and they belong to opposition in so far as the latter is determinateness which, as the whole, is reflected into itself. Because of their self-subsistence, the opposition which they constitute is implicitly determinate. Each is itself and its other. For this reason, each has its determinateness not in another but within. Each refers itself to itself only as referring itself to its other. This has a twofold aspect. Each is the reference to its non-being as the sublating of this otherness in itself. Its non-being is thus only a moment in it. But, on the other hand, here positedness has become a being, an indifferent subsistence. The other of itself which each contains is therefore also the non-being of that in which it should be contained only as a moment. Each is, therefore, only to the extent that its non-being is the two in an identical reference. The determinations which constitute the positive and the negative consist, therefore, in that the positive and the negative are, first, absolute moments of opposition. Their subsistence is indivisibly one reflection. It is one mediation in which each is by virtue of the non-being of its other, hence by virtue of its other or its own non-being. Thus they are simply opposites, or each is only the opposite of the other. The one is not yet the positive and the other not yet the negative, but both are negative with respect to each other. 11.274 Each, therefore, simply is, first, to the extent that the other is. It is what it is by virtue of the other, by virtue of its own non-being. It is only positiveness. Second, it is to the extent that the other is not. It is what it is by virtue of the non-being of the other. It is reflection into itself. The two, however, are both the one mediation of opposition as such in which they simply are only posited moments. Moreover, this mere positedness is reflected into itself in general, and, according to this moment of external reflection, the positive and the negative are indifferent towards this first identity where they are only moments, or again, because that first reflection is the positive's and the negative's own reflection into itself. Each is indifferent towards its reflection into its non-being, towards its own positiveness. The two sides are thus merely diverse, and because their determinateness, that they are positive or negative, constitutes their positiveness as against each other, each is not specifically so determined internally, but is only determinateness in general. To each side, therefore, there belongs indeed one of the two determinacies, the positive or the negative, but the two can be interchanged, and each side is such as can be taken equally as positive or negative. But, in third place, the positive and the negative are not only a posited being, nor are they something merely indifferent, but their positedness, or the reference to the other in the one unity which they themselves are not, is rather taken back into each. Each is itself positive and negative within. The positive and the negative are the determination of reflection in and for itself. Only in this reflection of the opposite into itself is the opposite either positive or negative. The positive has within it the reference to the other in which the determinateness of the positive consists. And the same applies to the negative. It is not negative as contrasted with another, but has the determinateness by which it is negative within. Each is thus self-subsistent unity existing for itself. The positive is indeed a positedness, but in such a way that the positedness is for it posited being as sublated. It is the non-opposed, the sublated opposition, but as the side of the opposition itself. As positive, it is indeed a something which is determined with reference to an otherness, but in such a way that its nature is not to be something posited. It is the immanent reflection that negates otherness. But its other, the negative, is itself no longer positedness or a moment, but itself a self-subsisting being. And so the negating reflection of the positive is internally determined to exclude this being, which is its non-being, from itself. Thus the negative, as absolute reflection, is not the immediate negative, but is the negative as sublated positedness, the negative in and for itself, which 11.275 positively rests upon itself. As immanent reflection, it negates its reference to its other. Its other is the positive, a self-subsisting being. Hence its negative reference to this positive is the excluding of it from itself. The negative is the independently existing opposite, over against the positive which is the determination of the sublated opposition, the whole opposition resting upon itself, opposed to the self-identical positedness. The positive and the negative are such, therefore, not just in themselves, but in and for themselves. They are in themselves positive and negative when they are abstracted from their excluding reference to the other and are taken only in accordance with their determination. Something is in itself positive or negative when it is not supposed to be determined as positive or negative merely in contrast with the other. But the positive and the negative, taken not as a positiveness and hence not as opposed, are each an immediate, being and non-being. They are, however, moments of opposition. Their in itself constitutes only the form of their immanent reflectedness. Something is said to be positive in itself, outside the reference to something negative, and something negative in itself, outside the reference to something negative. In this determination, merely the abstract moment of this reflectedness is held on to. However, to say that the positive and the negative exist in themselves essentially implies that to be opposed is not a mere moment, nor that it is just a matter of comparison, but that it is the determination of the sides themselves of the opposition. The sides, as positive or negative in themselves, are not, therefore, outside the reference to the other. On the contrary, this reference, precisely as exclusive, constitutes their determination or their in-itselfness. In this, therefore, they are at the same time in and for themselves. Remark. Mention must be made here of the concept of the positive and negative as it occurs in arithmetic. The concept is presupposed there as known, but, since it is not grasped in its specific difference, it is not immune to insoluble difficulties and complications. We have just seen how the two real determinations of the positive and negative, outside the simple concept of their opposition, come to be. Namely, only a differentiated immediate existence stands in a first instance as ground, the simple immanent reflection of which is distinguished from its positiveness, from the opposition itself. This opposition, therefore, does not count as anything which is in and for itself, and, although it does apply to its diverse sides so that each is an opposite in general, the sides remain nonetheless indifferent to it, and it is a matter of indifference which of the 11.276.2 is regarded as positive or negative. In a second instance, the positive is however the positive in itself, and the negative is the negative in itself, so that the two diverse sides are not indifferent to their respective determination, but each is that determination in and for itself. We see these two forms of the positive and the negative occur in arithmetic in the very first applications of them. In a first sense, the plus a and minus a are simply opposite magnitudes. There is the unit that stands by itself at the base of both, itself indifferent towards the opposition and serving here as an inert foundation, without further conceptual consideration. The minus a is indeed designated as the negative, the plus a as the positive, but the one is just as much an opposite as the other. In yet another sense, the is not only the simple unit serving as the foundation, but, as plus a and minus a, it is the reflection of these opposites into themselves. There are two different as at hand, and it is indifferent which of the two is designated as the positive or the negative. Each has a particular self-subsistence and is positive. According to the first sense, plus y and y equals 0, or, in minus 8 plus 3, the positive 3 are negatives in the 8. The opposites cancel themselves in combination. A 1-hour march is made to the east, and an equal march back to the west undoes it. So many are the debts pending, that many less assets are available. So many are the assets available, that many debts are absolved. The 1-hour march to the east is not in itself a positive march, nor is the march to the west a negative march. The directions are rather indifferent to this determinateness of opposition. Only a third standpoint external to both makes a positive of the one and a negative of the other. So also debts are not a negative in and for themselves, but are such only with reference to the one in debt. For the creditor, they are a positive asset. They are a sum of money or anything else of a given value, which, in accordance with standpoints external to it, is either debt or asset. The opposites do indeed cancel themselves in reference to each other, the result being equal to 0, but there is also present in them their identical reference 3, which is itself indifferent to the opposition, so the two constitute a 1. The same goes for the sum of money just mentioned, which is only one sum, or for the a, which is only one a whether in plus a or minus a, and for the 1-hour march as well, which covers one stretch of road, whether in the direction of east or west. And the same applies to an ordinate y, which is the same whether taken on one side or the other of the axis. Hence, plus y, y equals y. It is only one ordinate with only one determination and law for it. 11,277. But, in the second sense, the opposites are not only one indifferent something, but also two indifferent somethings. For, as opposites, they are also reflected into themselves and thus stand as diverse. Thus in -8 plus 3 there are 11 units altogether, plus y. Y are ordinates on opposite sides of the axis, where each is in existence indifferent to this limit and to their opposition. In this sense, plus y equals 2y. Also the road covered from east to west and back is the sum of a twofold effort or the sum of two time periods. Likewise in the economy of a state, a quantum of money or of assets is not just this one quantum as a means of subsistence, but is rather doubled. It is a means of subsistence for both creditor and debtor. The capital of a state is calculated not merely as the sum of cash and of other real or liquid assets available to it, even less so as the sum of what is left over after subtracting passive from active assets. For the capital rather, even if its active and passive accounts nullify each other, remains, first, positive capital, as plus a equals a, and, second, since it is passive in a variety of ways. By being lent many times over, it is thereby a resource many times over. But not only are opposite magnitudes, on the one hand, just merely opposed, and, on the other hand, real or indifferent. For although quantum itself is being indifferent to limit, the positive in itself and the negative in itself do also occur in it. Take the a, for instance, with no sign designation. If a sign is required, the presumption is that the is positive. If opposition is required, though only in general, then it can just as well be taken as -a. But the positive sign is the one given to it immediately, for the positive carries as such the particular meaning of the immediate, as self-identical, in contrast to the opposition. Further, inasmuch as positive and negative magnitudes are added or subtracted, they count as positive or negative for themselves, not as acquiring this value externally, merely through the connective 4 of addition or subtraction. In 8, -3, the first minus means opposite to 8, but the second, the -3, has the value of something opposed in itself, outside the reference to 8. This is even more apparent in multiplication and division. Here we must take the positive as essentially the not opposite and the negative, on the contrary, as the opposite, not both determinations equally as just opposites in general. In the textbooks of arithmetic, the demonstrations of how the signs function in these two types of reckoning do not go past the concept of 11.278 opposite magnitudes in general, and for this reason they remain incomplete and land themselves in contradictions. In multiplication and division, the plus and the minus obtain the more specific meaning of the positive and the negative in itself, because the relation of unit and amount in which the factors stand to each other is not a mere relation of the more and less, as in addition and subtraction, but is a qualitative relation. And for this reason the plus and minus also obtain the qualitative meaning of the positive and the negative. Without this determination and merely from the concept of opposite magnitudes, the false conclusion can easily be drawn that, if a plus a equals a2, then contrariwise plus a equals plus a2. Since one factor indicates the amount and the other the unit, and the amount is usually indicated by the factor that comes first, the two expressions, a plus a and plus a, are distinguished by the fact that in the first the plus a is the unit and minus of the amount, and the contrary is the case in the other. Now it is common to say with respect to the first expression that if I am to take plus a, the unit, minus a times, then I take it not merely a times, but also in the manner opposite to it, plus a times minus a. Therefore, since the is plus, I have to take it negatively, and the product is minus a2. But if, in the second case, minus a is to be taken plus a times, then minus a should equally be taken not minus a times, but in the determination opposite to it, namely plus a times. Therefore, on the argument of the first case, the product would have to be plus a2. The same goes for division. This is the conclusion that necessarily follows when we take plus and minus as opposite magnitudes in general. In the first case, to the minus is attributed the power of altering the plus. Yet in the second case, the plus is supposed not to have the same power over the minus, despite the fact that it is as good an opposite determination of magnitude as the minus. In point of fact, the plus does not have this power, for it is to be taken here according to its qualitative determination as against the minus, since the factors stand in qualitative relation to each other. For this reason, the negative here is therefore the inherently opposite as such, but the positive is the indeterminate, the indifferent in general. It, too, is indeed the negative, but the negative of the other, not a negative within it. A determination of negation thus derives solely by virtue of the negative at hand, not by virtue of the positive. And so, a equals plus a2, because the negative plus alpha is not to be taken merely in the opposite manner, as it would have to be taken when multiplied, a times, but because it is to be taken negatively. But the negation of the negation is the positive. 11,279. Contradiction. Difference in general contains both its sides as moments. In diversity, these sides fall apart as indifferent to each other, and in opposition as such, they are the moments of difference, each determined by the other and hence only moments. But in opposition, these moments are equally determined within, indifferent to each other and mutually exclusive, self-subsisting determinations of reflection. One is the positive and the other the negative, but the former as a positive which is such within, and the latter as a negative which is such within. Each has indifferent self-subsistence for itself by virtue of having the reference to its other moment within it. Each moment is thus the whole self-contained opposition. As this whole, each moment is self-mediated through its other and contains this other. But it is also self-mediated through the non-being of its other and is, therefore, a unity existing for itself and excluding the other from itself. Since the self-subsisting determination of reflection excludes the other in the same respect as it contains it, and is self-subsisting for precisely this reason, in its self-subsistence the determination excludes its own self-subsistence from itself. For this self-subsistence consists in that it contains the determination which is other than it in itself, and does not refer to anything external for just this reason, but no less immediately in that it is itself, and excludes from itself the determination that negates it. And so it is contradiction. Difference as such is already implicitly contradiction, for it is the unity of beings which are, only in so far as they are not one, and it is the separation of beings which are, only in so far as they are separated in the same reference connecting them. The positive and the negative, however, are the posited contradiction, for, as negative unities, they are precisely their self-positing and therein each the sublating of itself and the positing of its opposite. They constitute determining reflection as exclusive, for the excluding is one act of distinguishing, and each of the distinguished beings, as exclusive, is itself the whole act of excluding, and so each excludes itself internally. If we look at the two self-subsisting determinations of reflection on their own, the positive is positedness as reflected into likeness with itself. Positedness which is not reference to another, hence subsistence inasmuch as the positedness is sublated and excluded. But with this the positive makes itself into the reference of a non-being, into a positedness. 11.280 inches this way the positive is contradiction, in that, as the positing of self-identity by the excluding of the negative, it makes itself into a negative, hence into the other which it excludes from itself. This last, as excluded, is posited free of the one that excludes, hence, as reflected into itself and itself, as excluding. The reflection that excludes is thus the positing of the positive as excluding the other, so that this positing immediately is the positing of its other which excludes it. This is the absolute contradiction of the positive, but it is immediately the absolute contradiction of the negative, the positing of both in one reflection. Considered in itself as against the positive, the negative is positedness as reflected into unlikeness to itself, the negative as negative. But the negative is itself the unlike, the non-being of another. Consequently, reflection is in its unlikeness its reference rather to itself. Negation in general is the negative as quality or immediate determinateness, but taken as negative, it is referred to the negative of itself, to its other. If this second negative is taken only as identical with the first, then it is also only immediate, just like the first. They are not taken, therefore, as each the other of the other, hence not as negatives. The negative is not at all an immediate. But now, since each is moreover equally the same as what the other is, this reference connecting them as unequal is just as much their identical connection. This is therefore the same contradiction which the positive is, namely positedness or negation as self-reference. But the positive is only implicitly this contradiction, is contradiction only in itself. The negative, on the contrary, is the posited contradiction, for in its reflection into itself, as a negative which is in and for itself or a negative which is identical with itself, its determination is to be the not identical, the exclusion of identity. The negative is this, to be identical with itself over against identity, and consequently, because of this excluding reflection, to exclude itself from itself. The negative is therefore the whole opposition, the opposition which, as opposition, rests upon itself, distinction that absolutely does not refer itself to another, distinction which, as opposition, excludes identity from itself, but thereby also excludes itself, for as reference to itself it determines itself as the very identity which it excludes. Contradiction resolves itself. In the self-excluding reflection we have just considered, the positive and the negative, each in its self-subsistence, sublates itself. Each is simply the passing over, or rather the self-translating of itself into its opposite. This internal ceaseless vanishing of the opposites is the first unity that arises by virtue of contradiction. It is the null. 11,281. But contradiction does not contain merely the negative. It also contains the positive, or the self-excluding reflection is at the same time positing reflection. The result of contradiction is not only the null. The positive and the negative constitute the positedness of the self-subsistence. Their own self-negation sublates it. It is this positedness which in truth founders to the ground in contradiction. The immanent reflection by virtue of which the sides of opposition are turned into self-subsistent self-references is, first of all, their self-subsistence as distinct moments. Thus they are this self-subsistence only in themselves, for they are still opposites, and that they are in themselves self-subsistent constitutes their positedness. But their excluding reflection sublates this positedness, turns them into self-subsistent beings existing in and for themselves, such as are self-subsistent not only in themselves, but by virtue of their negative reference to their other. In this way, their self-subsistence is also posited. But, further, by thus being posited as self-subsistent, they make themselves into a positedness. They fate themselves to founder, since they determine themselves as self-identical. Yet in their self-identity they are rather the negative, a self-identity which is reference to other. However, on closer examination, this excluding reflection is not only this formal determination. It is self-subsistence existing in itself, and the sublating of this positedness is only through this sublating a unity that exists for itself and is in fact self-subsistent. Of course, through the sublating of otherness or positedness or the negative of an other is indeed present again. But in fact, this negation is not just a return to the first immediate reference to the other, is not positedness as sublated immediacy, but positedness as sublated positedness. The excluding reflection of self-subsistence, since it is excluding, makes itself a positedness but is just as much the sublation of its positedness. It is sublating reference to itself. In that reference, it first sublates the negative and it secondly posits itself as a negative. And it is only this posited negative that it sublates. In sublating the negative, it both posits and sublates it at the same time. In this way, the exclusive determination is itself that other of itself of which it is the negation. The sublation of this positedness is not, therefore, once more positedness as the negative of an other, but is self-withdrawal, positive self-unity. Self-subsistence is thus unity that turns back into itself by virtue of its own negation, for it turns into itself through the negation of its positedness. It is the unity of essence, to be identical with itself through the negation not of another, but of itself. According to this positive side, since self-subsistence in opposition, as excluding reflection, makes itself into a positedness, and equally 11.282 sublates this positedness, not only has opposition foundered, but in foundering it has gone back to its foundation, to its ground. The excluding reflection of the self-subsisting opposition turns it into a negative, something only posited. It thereby reduces its formerly self-subsisting determinations, the positive and the negative, to determinations which are only determinations, and the positedness, since it is now made into positedness, has simply gone back to its unity with itself. It is simple essence, but essence as ground. Through the sublating of the determinations of essence, which are in themselves self-contradictory, essence is restored, but restored in the determination of an exclusive, reflective unity, a simple unity which determines itself as negation, but in this positedness is immediately like itself and withdrawn into itself. In the first place, therefore, because of its contradiction, the self-subsisting opposition goes back into a ground. This opposition is what comes first, the immediate from which the beginning is made, while the sublated opposition or the sublated positedness is itself a positedness. Accordingly, essence is as ground a positedness, something that has become. But conversely, only this has been posited, namely that the opposition or the positedness is something sublated, only is as positedness. As ground, therefore, essence is excluding reflection because it makes itself into a positedness, because the opposition from which the start was just now made and was the immediate is the merely posited determinate self-subsistence of essence, because opposition only sublates itself within, whereas essence is in its determinateness reflected into itself. As ground, therefore, essence excludes itself from itself, it posits itself. Its positedness, which is what is excluded, is only as positedness, as identity of the negative with itself. This self-subsistent is the negative posited as the negative, something self-contradictory which, consequently, remains in the essence as in its ground. The resolved contradiction is therefore ground, essence as unity of the positive and the negative. In opposition, determinateness has progressed to self-subsistence. But ground is this self-subsistence as completed. In it, the negative is self-subsistent essence, but as negative, and as self-identical in this negativity. Ground is thus equally the positive. In ground, therefore, opposition and its contradiction are just as much removed as preserved. Ground is essence as positive self-identity which, however, at the same time refers itself to itself as negativity and therefore determines itself, making itself into an excluded positedness. But this positedness is the whole self-subsisting essence, and essence is ground, self-identical in its negation and positive. The self-contradictory, self-subsistent opposition was itself, therefore, already ground. All that was added to it was the determination of self-unity, which emerges 11.283 as each of the self-subsisting opposites sublates itself and makes itself into its other, thereby founders and sinks to the ground, but therein also reunites itself with itself. Thus in this foundering, that is, in its positedness or in the negation, it rather is for the first time the essence that is reflected into itself and self-identical. Remark 1. The positive and the negative are the same. This is a maxim of external reflection, for it sets up a comparison between the two terms. But it is not an external comparison that should be drawn between them or, for that matter, between any two other categories. The categories must rather be considered on their own. That is to say, it is their own reflection that must be considered. And we have seen in this reflection that each is the reflective shining of itself in the other, and itself the positing of itself as the other. Superficial thought that does not consider the positive and the negative as they are in themselves can of course be made aware of the instability of these distinct terms, which it assumes to be fixed in their opposition to each other, by being referred to the act of comparing. The most cursory experiment in reflective thought will demonstrate that, if something is determined as a positive and is then taken as the starting point, this same something will have immediately turned in the process into a negative and, vice versa, anything negatively determined will have turned into a positive. It will demonstrate that reflective thinking gets confused and runs into contradictions in these determinations. Ignorance of their nature will interpret this confusion as a misstep that should not occur and will ascribe it to a subjective failure. Indeed, the shifting back and forth from one determination to the other will remain mere confusion as long as there is no awareness of the necessity of the alternation. But even to external reflection, it will be a matter of simple consideration that the positive, to start with, is not a simple identity, but is rather, on the one hand, opposed to the negative, has meaning only in this reference to it, and therefore entails the negative in its very concept, and, on the other hand, is inherently the self-referring negation of mere positiveness or of the negative, and therefore is itself implicitly the absolute negation. Similarly, the negative that stands over against the positive has meaning only in thus referring to its other. It contains it, therefore, in its concept. But the negative has a self-subsistence of its own also without the reference to the positive. It is self-identical. Thus it is itself what the positive was supposed to be. 11,284. The opposition of positive and negative is normally taken in the sense that the former, even though its name conveys positiveness, is to be supposed as objective, the latter, instead, as something subjective that only belongs to an external reflection and has nothing to do with what exists objectively in and for itself, even is for the latter nothing at all. And in fact, if the negative only expressed a subjectively arbitrary abstraction or a determination of external comparison, then it would indeed be for the positive nothing at all. That is, there would be no reference in the positive to such an empty abstraction, but then its determination, that it is a positive, would equally be only external to it. As an example of the fixed opposition of these determinations of reflection, take light in general to be the solely positive, and darkness the solely negative. But light has, in its unending expansion and power to suscitate and vivify, the nature of absolute negativity. Darkness, on the other hand, as a non-manifold or as the non-self-differentiating womb of generation, is simple self-identity, the positive. In the way it is taken, it is only a negative, in the sense that it is the mere absence of light, nothing at all for itself, so that light, in referring to it, would not be referring to another but purely to itself, would therefore simply disappear before it. But surely light is dimmed to gray by darkness, and, besides this merely quantitative alteration, it also suffers the qualitative one of being determined as color by referring to darkness. So also virtue, for example, is not without struggle, it is rather the highest, the perfect struggle, and thus not only a positive but rather absolute negativity. Virtue is virtue, not just by comparison to vice, but for the opposition and the combat in it. Or again, vice is not only the lack of virtue. Innocence, too, is such a lack, and distinct from virtue not just in the eyes of an external reflection, but as opposed to virtue in itself. It is evil. Evil consists in maintaining one's own ground as against the good. It is positive negativity. Innocence, on the other hand, as the lack of both good and evil, is indifferent to these determinations, is neither positive nor negative. But at the same time, this lack must be taken also as a determinateness, and, as such, on the one hand it is to be considered as the positive nature of something just as, on the other, as referring to an opposite. And thus all natures fall from innocence, from their indifferent self-identity. Because of what they are in themselves they refer to their other, and therefore they cause themselves to founder, or, positively expressed, 11.285 they return to their ground. Truth also is the positive as the knowledge that agrees with the object, but it is this likeness to itself only in so far as knowledge has related itself negatively to the other, has penetrated the object, and sublated the negation which the latter is. Error is something positive as the self-aware and deliberate assertion of something which has no existence in and for itself. Ignorance, for its part, is either something indifferent to truth and error, hence neither positively nor negatively determined, its determination a lack and thus the domain of external reflection, or, objectively taken as the defining determination of a nature, an instinct that is directed against itself, a negative containing a positive direction within it. To perceive and to be mindful of this nature of the determinations of reflection is among the most important steps in cognition. That their truth consists only in their reference to one another, and hence that each contains the other within its very concept. Without this recognition, no proper step in philosophy can be made. Remark 2. The determination of opposition has equally been made into a proposition, the so-called principle of the excluded middle. Something is either A or not A, there is no third. This principle contains, first, that everything is an opposite, determined either as positive or as negative. It is an important principle, necessary because identity passes over into diversity and diversity into opposition. But this is not the sense in which it is normally understood, for its ordinary meaning amounts rather to just this, that of all predicates, either this one here or its non-being comes to a thing. Here the opposite of the predicate signifies a mere lack or rather indeterminateness, and the principle is so insignificant that it is hardly worth the effort of enunciating it. If the predicates green, sweet, square are taken, and it is assumed that they are all taken, and then it is said of spirit that it is either sweet or not sweet, green or not green, and so on, this is a triviality that leads nowhere. Determinateness, the predicate, is referred to something. This something is determined, the principle says. Now what the principle ought essentially to imply is that the determinateness should further determine itself, that it become determinateness in itself, opposition. Instead of this, however, it only goes, in the trivial sense just mentioned, from determinateness over to its non-being in general, goes back to indeterminateness. The principle of the excluded middle is further distinguished from the previously examined principles of identity or contradiction that said, nothing is 11.286a and not a at the same time. What this implies is that there is nothing which is not either a or not a, that there is no third that would be indifferent to that opposition. But in fact a third indifferent to it is given in the principle itself, for the a itself is there. This a is neither plus a nor minus a, and just as much also plus a and minus a. The something which ought to have been either plus a or minus a is here attached to the plus a as well as the minus a, and again, inasmuch as it is attached to the a, it ought not to be attached to the minus a, just as it ought not to be attached to the a inasmuch as it is to the not dash a. The something itself is therefore the third which ought to have been excluded. Since in this something the opposite determinations are equally posited and sublated, that third which is here in the shape of an inert something, when taken more profoundly, is the unity of the reflection into which the opposition returns as into ground. Remark 3. Now if the first determinations of reflection, identity, diversity, and opposition have been formulated each as a principle, 5 all the more should the one determination into which they pass over as in their truth, namely contradiction, be grasped and enunciated as a principle. All things are in themselves contradictory, in the sense, moreover, that as contrasted with the other, this proposition expresses rather the truth and the essence of things. The contradiction that emerges in opposition is only the developed nothing which is contained in identity and came to the fore in the claim that the principle of identity says nothing. This negation further determines itself into difference and into opposition, which is now the posited contradiction. It is, however, one of the basic prejudices of previous logic and of ordinary thought that contradiction is not as essential and imminent a determination as identity. But in fact, if order of precedence were an issue, and the two determinations were to be held separate, it would be the principle of contradiction that should be taken as the more profound and the more essential. For in contrast to it, identity is only the determination of simple immediacy, of inert being, whereas contradiction is the root of all movement in life. It is only in so far as something has a contradiction within it that it moves, is possessed of instinct and activity. Contradiction is ordinarily the first to be kept away from things, away from any existent, and from the true. As the saying goes, there is nothing contradictory. For the rest, it is 11.287 relegated to subjective reflection, which allegedly first posits it by way of reference and comparison. And even within this reflection, it is not really there, for the contradictory cannot supposedly be represented or thought. Whether it occurs in actuality or in the reflection of thought, it is universally reckoned as an accident, an abnormality as it were, a momentary fit of sickness. Now as regards the claim that there is no contradiction, that none is to be found, we need not worry on account of such protestations. An absolute determination of essence must be found in every experience, in anything actual, just as in every concept. We have already remarked this much earlier on in connection with the infinite, 6, which is contradiction as displayed in the sphere of being. But ordinary experience itself testifies that there do exist at least a great many contradictory things, contradictory dispositions, etc., of which the contradiction is present not in any external reflection, but right in them. Nor is contradiction to be taken as an abnormality which happens only here and there, but it is rather the negative in its essential determination, the principle of all self-movement, which consists in nothing else than in the display of contradiction. External, sensuous motion is itself contradiction's immediate existence. Something moves, not because now it is here and there at another now, but because in one and the same now it is here and not here, because in this here it is and is not at the same time. One must concede to the dialecticians of old the contradictions which they pointed to in motion, but what follows from them is not that motion is not, but that it is rather contradiction as existent. Internal self-movement proper, drive in general, the appetite or nisus of the monad, the entelechy of the absolutely simple essence. 7 is likewise nothing else than that something is, in itself, and the lack of itself, the negative, in one and the same respect. Abstract self-identity is not yet vitality, but the positive, since implicitly it is negativity, goes out of itself and sets its alteration in motion. Something is alive, therefore, only to the extent that it contains contradiction within itself. Indeed, force is this, to hold and endure contradiction within. If, on the contrary, a concrete existent were not capable of overreaching its positive determination and grasping the negative one at the same time, holding the two firmly together, if it were not capable of harboring contradiction within it, it would not then be a living unity as such, not a ground, and in contradiction it would founder and sink to the ground. Speculative thought consists only in this, in holding firm to contradiction and to itself in the contradiction, but not in the sense that, as it happens in ordinary thought, it would let itself be ruled by it, and allow it to dissolve its determinations into just other determinations or into nothing. 11,288. If to ordinary thought the contradiction which is in motion, in a drive and the like, remains concealed in the simplicity of such determinations. Contradiction is, on the other hand, immediately displayed in the determinations of relation. The most trivial of examples, above and under, right and left, father and son, and so on ad infinitum, all contain opposition within one and the same term. Above is what under is not. Above is determined by just this, not to be under, and is only to the extent that an under is, and contrariwise. Father is the other of son, and son the other of father, and each is only as this other of the other, and the one determination is at the same time only with reference to the other. Their being is one subsisting. The Father is indeed something for itself outside this reference to the Son, but then he is not Father, but a man in general. The same applies to above and under, right and left. They too are something outside the reference when reflected into themselves, but just places in general. Opposites entail contradiction inasmuch as, in negatively referring to each other, they sublate each other reciprocally and are indifferent to each other. Ordinary thought, when it passes over to the moment of indifference, forgets they're the negative unity of the opposites and therefore holds on to them only as different in general. And, of course, in this general determination, right is no longer right, left no longer left, and so on. But if right and left are in fact there, present to the thought, then they are present to it in determinations which are self-negating, each negating itself and the other, and yet, in this unity, also not negating itself, but each existing indifferently for itself. Ordinary thought, therefore, does have contradiction everywhere for content, but fails to become aware of it. It remains an external reflection that simply shifts from likeness to unlikeness or from the negative reference connecting distinct terms to their immanent reflectedness. It holds these two determinations apart, external to each other, and has only them in mind, not the transition from the one to the other which is the essential and that which contains the contradiction. The speculative reflection of spirit, to mention it here, consists on the contrary in grasping and enunciating contradiction. Although it might not express the concept of things and their relations, and has only representational determinations for its content, it nevertheless connects these in a reference that contains their contradiction and lets their concept reflectively shine through the contradiction. But thoughtful reason sharpens, as it were, the blunt difference of diverse terms, the mere manifold of representation, to essential distinction, to opposition. Only when driven to the extreme of contradiction are the many of that manifold quickened and alive to each other. They hold the negativity in them, which is the inner pulse of self-movement and life. 11,289. We have already remarked concerning the ontological proof of God's existence that the determination on which it is based is that of the sum total of all realities. It is customary regarding this determination first to demonstrate that it is possible because it entails no contradiction, since reality is taken here only as reality without restrictions. We pointed out that this concept, the sum total of all realities, is thereby reduced to simple, indeterminate being, or, if the realities are in fact taken as severally determinate, to the sum total of all negations. And if the distinction differentiating them is then taken with greater precision, the difference turns into opposition and consequently into contradiction, and the sum total of all realities in general into absolute internal contradiction. The usual horror which ordinary, not speculative, thought has of contradiction, as nature has of the vacuum, rejects this consequence, for it remains at the one-sided consideration that contradiction resolves into nothing without recognizing its positive side, where it becomes absolute activity and absolute ground. The upshot of this examination of the nature of contradiction is that, if a contradiction can be pointed out in something, by itself this is still not, as it were, a blemish, not a defect or failure. On the contrary, every determination, anything concrete, every concept, is essentially a unity of distinguished and distinguishable elements which, by virtue of the determinate, essential difference, pass over into elements which are contradictory. This contradictoriness, of course, resolves itself into nothing. It goes back into its negative unity. A thing, a subject, a concept, is then precisely this negative unity. It is something inherently self-contradictory, but it is no less the resolved contradiction. It is the ground which contains the determinations it bears. The thing, the subject, or the concept, each as reflected into itself within its sphere, is their contradiction as resolved. But the whole sphere of each is in turn determinate, diverse, and therefore finite, and this means contradictory. This sphere is not itself the resolution of its higher contradiction, but has yet a higher sphere for its negative unity, for its ground. Finite things, in their indifferent variety, are therefore just this, to be contradictory, internally fractured, and bound to return to their ground. As we shall see in due course, 9. The true inference from the finite and accidental to an absolutely necessary being does not consist in inferring the latter from that finite and accidental as a being which is and remains the ground of the inference, but from it as a being which is only falling, as accidentality, from the Latin caetera, immediately conveys, a being inherently self-contradictory. Or rather, the inference consists in demonstrating that accidental being makes in itself its return to its ground 11.290 and is there sublated. In addition, that in this return to the ground it posits the latter in such a manner that it makes itself rather into a positedness. In customary inference, the being of the finite appears to be the ground of the absolute, because the finite is, the absolute is. But the truth is that the absolute is because the finite is the immanently self-contradictory opposition, because it is not. In the former meaning, the conclusion is that the being of the finite is the being of the absolute, but in the latter, that the non-being of the finite is the being of the absolute. 3. Identisch Beziehung. For Beziehung, 5 cf. above, 11,258, 270, 285. 6 cf. above, 21,127, where Hegel refers to contradiction in the transition from the finite to the infinite. But Hegel must here be referring to the 1812 edition of the Logic. Cf. GW 11, 83, 140. 7 Monadology, sections 18, 19, 20. 8 cf. above, 21.99 ff. But Hegel must here be referring to the 1812 edition of the Logic. Cf. GW 11, 64. 9 cf. below, 11.384 ff. Chapter 3 Ground 11, 291. Essence determines itself as ground. Just as nothing is at first in simple immediate unity with being, so here too the simple identity of essence is at first in simple unity with its absolute negativity. Essence is only this negativity, which is pure reflection. It is this pure reflection as the turning back of being into itself. Hence it is determined, in itself or for us, as the ground into which being resolves itself. But this determinateness is not posited by the essence itself. In other words, essence is not ground precisely because it has not itself posited this determinateness that it possesses. Its reflection, however, consists in positing itself as what it is in itself, as a negative, and in determining itself. The positive and the negative constitute the essential determination in which essence is lost in its negation. These self-subsisting determinations of reflection sublate themselves, and the determination that is foundered to the ground is the true determination of essence. Consequently, ground is itself one of the reflected determinations of essence, but it is the last, or rather, it is determination determined as sublated determination. In foundering to the ground, the determination of reflection receives its true meaning, that it is the absolute repelling of itself within itself, or again, that the positedness that accrues to essence is such only as sublated, and conversely that only the self-sublating positedness is the positedness of essence. In determining itself as ground, Essence determines itself as the not determined, and only the sublating of its being determined is its determining. Essence, in thus being determined as self-sublating, does not proceed from an other but is, in its negativity, identical with itself. Since the advance to the ground is made starting from determination as an immediate first, is done by virtue of the nature of determination itself that founders to the ground through itself. The ground is at first determined by that immediate first. But this determining is, on the one hand, as the sublating of the determining, the merely restored, purified, or manifested identity of essence which the determination of reflection is in itself. On the other hand, this negating movement is, as determining, the first positing of that reflective determinateness that appeared as immediate determinateness, but which is posited only by the self-excluding reflection of ground, and therein is posited as only something posited or sublated. Thus essence, in determining itself as ground, proceeds only from itself. As ground, therefore, it posits itself as essence, and its determining consists in just this positing of itself as essence. This positing is the reflection of essence that sublates itself in its determining. On that side is a positing, on this side is the positing of essence, hence both in one act. Reflection is pure mediation in general, ground, the real mediation of essence with itself. The former, the movement of nothing through nothing back to itself, is the reflective shining of one in another. But, because in this reflection opposition does not yet have any self-subsistence, neither is the one, that which shines, something positive, nor is the other in which it reflectively shines something negative. Both are substrates, actually of the imagination, they are still not self-referring. Pure mediation is only pure reference, without anything being referred to. Determining reflection, for its part, does posit such terms as are identical with themselves, but these are at the same time only determined references. Ground, on the contrary, is mediation that is real, since it contains reflection as sublated reflection. It is essence that turns back into itself through its non-being and posits itself.